If you are ready to master Autodesk Revit, specifically for the MEP electrical trade, focusing only on the absolutely necessary concepts, then this video is exactly what you need. I will guide you step by step from a blank project to a complete 3-bedroom residential house electrical design, complete with receptacles, HVAC and plumbing equipment connections, light fixtures, light switches, panels or a residential load center, the service meter, and even out to the utility transformer at the street. Plus, I will give you everything you need up front to follow along with me, entirely free, which you can download in the description below. So this package includes the 3D architectural model, the 3D mechanical and plumbing model, my custom residential electrical project template to start from with all the settings set up, and every single out-of-the-box electrical family that you will need to create your own version of this model, including a bonus of 2 custom generic electrical families that you can use for many other electrical devices. So if you are finally ready to become proficient in Revit Electrical, then let's get right into it. So I've opened up Revit 2025, and your screen may look different. I have my recent files disabled on this view because I want to make sure that I open things from the proper place. But we're going to start, like I said, from scratch. So we're going to go to New, and we want a project, and we want from a template file. So if you haven't already, you can actually download in the description below this whole package of the electrical project template to start with, which has many of the settings already tweaked for you, as well as all of the families that you will need to do this project. And so we can open that template file from there. So we need to go in and find that. So I have mine here, and here it is, my residential tutorial electrical template. We're going to start from that template and say open. And we are creating a new project. We're not creating a template. We're just creating a project. Say OK. And it will upconvert it if you're using something newer than 2023. And you can go as far back as the 2023 Revit to do this project and use this template. So anything 23 and above, and 26 is coming out next month as of the filming of this. So it's coming up soon. And what I have in this template is just a thing called a starting view. It is just a simple 2-dimensional view that is easy to open. Many people like this kind of a view so that we don't open it up to, as your model gets built, it's going to be complex and it will have 3D views, things like that. We don't want to open up to something complex graphically. We want to make sure we start from here. A lot of this stuff is set up in this project template, so you don't have to do it every time you start a project, and that's an important thing, is to develop this template. So I'll be presenting this as if you're fairly new to Revit. So if I go a little too fast, you may need to back up and rewatch and pause it. And actually the best way to learn Revit is just repetition. Do things over and over. Take good notes. So let's just get right into this. On the left is the project browser. It is arranged with headings. The first heading is views by discipline. And this is an electrical template, so it only has electrical types of views. Now, views can be a floor plan view. It can be an elevation view, a section view. It can even be a schedule, a sheet, a legend, a diagram. All these are called views. So we have ceiling plan views, we have floor plan for power, we have 3D views, elevations, and these are views that are already set up. You can delete some, you can add some, you can change their names. But we're going to start looking at one of these floor plan views just to get started. Now, you may wonder, why is there an 11 and 12, all that? Well, you can add numbers to the beginning of these to help them sort properly, and then we can take the numbers out later when we print things. But for now, for sorting, I start with some double-digit numbers. If I double-click First Floor Plan Power, it puts me in up here, a tab up here for this first floor power plan. And of course, there's nothing here. It's blank. We haven't modeled anything yet. But you'll see these little markers. These are actually they're called elevation markers. If you click on one and over on the right, it'll tell you it's an elevation, building elevation. And if I escape out of that, hit escape to back out, you can see that right now, without clicking on anything, I'm looking at a floor plan, and this is all of the data just associated with this floor plan. It tells you what scale it is, what kind of detail level it may be at, because we can have high detail, low detail. This is medium right now, and all these parameters that you'll learn over time. Down here under identity data, there's a thing called a view template. We can control what's on and off in this view with another template called a view template. Right now it has none. And the view name is just what it says over here. It's 11 first floor plan power. The first thing we need to do is to have a floor plan, or more accurately in Revit, we need a 3D architectural model to design our electrical system in. And then we're going to take pieces of that and create these floor plan views. So let me show you what I mean. We're going to link in a architectural Revit. Now, again, in that package that you can download is this full 3D architectural model. Now, what we do is up top, you'll see all these tabs. There's one called Insert. If you go to Insert, there's all these different things we can insert and link. So we want to find one that says Link Revit. So right here, this says Link Revit. We're not going to insert it. We're going to link it so that any changes made to the architectural model will automatically show up in our link. So let's go Link Revit. So now you'll see an Explorer type view of files that are available and get to where you put these architectural and mechanical models. So as you can see, I have an architectural and mechanical, and there's a couple of them because the ones with the long numbers after it are actual backup copies. Every time you open up this model and save it, it creates a backup and it gives it a number. We don't want to open up the backup file. We want to open up the actual file. And my typical naming is I like to give the name of the project. I like to say which discipline it is, architectural in this case, and which Revit version it's in. If you're working with an architecture firm and you need to send your file back to them, you need to be in the same version they are. But in this case, I'm not doing that, so I can use my 2025 with this older model. So now, some important things to notice are, here's the file name. It's a Revit file. Now, positioning. Because we are linking this architectural model into our file, into our model, we want them to line up. Like in other programs, maybe CAD, you'd put them at 0, 0, or some kind of a same place. Well, here in Revit, we have a number of different origins or base points, different coordinate systems. So it will try to do origin to origin, but that can be pretty random. So I like to use what's called project base point to project base point. And that's a point that was established in the architectural model by the architect that we can keep track of. So let's go with base point to base point and then just say open, which will actually load this in. And it's linked models being upgraded from 23 to 25. So it just takes a second for that to upgrade. It's not a huge model, so it comes in. Now, if you are going to continue working in 2025 on this, we may just go back to the architectural Revit model, open it by itself, and up convert it to 25 and save it that way so that we don't have to do this up convert every time. But this is a small model, so I'm not worried about that for this example project. So this is the architectural model. Let's go in and see what we have. It's a floor plan view of it right now because that's what I'm in, is a plan view. But as you can see, it's got the full site. We have, these are trees, and this is the floor plan of our 3-bedroom home. There's no room names or anything in it yet. We'll get to that. It has a grid system that architects often use. And we even have this little property line. You can see kind of this dashed line around here. Now this green box we will get into eventually. One thing I like to make sure I do when I bring in a linked model is I like to lock it in place so I don't actually move it around. So up here, when you click on this Revit link and it highlights in blue, you can see on the top right, it's a linked Revit model. It gives you the name and it gives you some information about it that we're not too concerned with right now. But it also changes the ribbon up top to the Modify and Revit Links contextual ribbon. We can get to some things up here like a modify area and all these other things that we'll get to eventually as we go through this. But for right now, under the modify, over here you'll see above this X, which is delete, is this little pin. So you click on the pin, it's pinned, and you can get to the unpin up here. So we've pinned this model in place. And if you see it, you kind of see there's a little white symbol here. That's actually a pin. So now I escape out of there. Now, I'm not able to click on that. Why is that? Well, there's another piece up here on the left, under this modify button, is a select button, a little drop down. This lets you decide what you can and cannot click on or select. I can select links, it's checked. I can select underlay elements, which we'll get into. Select pinned elements. Well, that's turned off, so that's why I cannot click on this pinned element. That's a way you can turn on and off things so that you don't actually grab this. If you're trying to window something, you can use a window like this by clicking and dragging. That way I won't click on my pinned element. Now, if I do want to select a pinned element, I can just click on that. Now, if I click on this and try to move it, I can't move it. And that's using just the move drag. You can also go up to the move symbol here, hit move, click on this, and it will try to highlight a snap point, like a corner or a midpoint. Like this is a midpoint. Click on that, and I'm trying to move it. It won't let me. And now what happens is I get an error message, which will pop up down here in the bottom right. Autodesk Revit 2025, error can't be ignored, can't move the pinned element. So it's telling me it's pinned, I can't move it. Now it cannot be ignored. That just means that I have to cancel out of this and cancel my command. So let me turn that back off so that I don't accidentally select this. Now that the model is in and pinned, I want to make sure that we have the same coordinate system and the same project information as the architect did. And we can bring in information from the architectural file. Typically, the architect will give it a name, an address, a client name, things like that, that you would end up eventually putting on a title block. But it also has things like the project location and maybe some coordinate systems. So I like to make sure that I bring in the project information. So this happens to be under the Manage tab. And again, you may need to write down your own notes of shortcuts how to find this stuff because it can be buried under any of these tabs. Manage tab, under Settings, there's a thing called Transfer Project Standards. Click on that, and it will automatically notice that I have a link in here, the Tutorial 3-Bedroom Home Architectural link. It knows that I already have this link, so it brings that up automatically. And if I had multiple links, I'd have a drop down. But here's all the things that standards that I can bring in from that architectural model if I want it in my model, my electrical model, which I'm creating. There's different pipe connections and assembly codes, cable tray settings, architectural, MEP, everything. Now, I don't want to overwrite my stuff in my template with the architectural stuff, so I want to make sure I check none. All I want to bring in at this time is the project information. Project info. So say, okay, I don't want to bring in their pipe sizes. They're not going to be set up properly. They already exist, but they want to change it. So they want to change my energy settings, location data, project information like project address and client, and some shared site information. So I want to overwrite these things. And then every once in a while, it'll say, do you want to save your project? You do want to save it. Now, I haven't given this project a name yet, so it's asking me what name do I want to call this. So I'm going to call this, and you'll want to come up with some kind of a standard naming convention. I'm going to call this Tutorial 3-Bedroom, and I can just get to the end of this. I'm going to call this one Electrical R25. So that's when I'm going to name my electrical project. Before you just hit save, the default options is to make a few backups. Now, one backup is good. Sometimes you'll see a 3, sometimes you'll see a 20. I don't recommend keeping 20 backups. It'll eat up your hard drive. So 1's enough for me. And that's all I check here and say, okay. So now I can save it. And then up top, it will rename the file once it saves. There. Tutorial 3-Bedroom Home Electrical R25. So now we have that saved. But we brought in the information, and there's nothing really visible yet. I like to do that because it could change the location or things like that. One thing you'll notice is that that green box is tilted. I said we'll get into that eventually, but this can be oriented differently. Right now, my floor plan is very much horizontal and perpendicular exactly. Well, that was done on purpose by the architect. They like the floor plans to be that way. They're easier to work on than if it was skewed. Over here under floor plan, and make sure you escaped out, there's a thing called orientation. It's set up for project north. Now there's a drop down here. You can click, you can go to true north. They may be different. Let me try true north and hit apply. And look, it tilted the project. So true north is up in this view. The building sits on the property at a tilt from true north. When we do a site plan, which we'll get into here eventually, we will want to use this true north. But when we're working on a floor plan, we like to use the project north. So I need to put this back to project north, apply it, and that lets me work on this building in a horizontal and vertical type of orientation. Now, if for some reason the plan ends up on top of these little elevation markers, they can actually be moved. If you just click on one, you'll only get part of it. There's a couple pieces to this. There's the box, and then there's the actual arrow. So to do this, I would circle this with the drag, and you can also drag the other way, and you'll see the dash line. That's a crossing drag. Either way works. And then you can move this wherever you want as one piece. But they're okay for now, so we'll leave them. Next thing I like to do is get familiar with the building I'm working on. Let's take a look at this in 3D. Now on the left in our project browser, you can see we have something called a 3D view. That's just a default exterior 3D view that is in every project in this template. So let's double click that and see what we get. There. We have a three-dimensional view, and it's just black and white with hidden lines, it's called. You see that green box again, and that's called a scope box, and we'll get into that again later. But you can kind of see the internals of the building as I zoom in and out. You also can see these things here. Grade, level 1, roof, all these are actually called levels, and they are three-dimensional objects. If you hover over it, you can see one of them highlights. That's a three-dimensional plane that extends throughout this portion of the project. It's called a level, and that is what floor plans are based upon, different levels. They could be different floors, they could be a roof level, basement level, they could be a ceiling level, so not just floors, but we will see how those affect our plans. But I just want to show you the 3D view. You get a view cube in the top right that you can use to navigate this view. So if I hover over the ring, click on it, and now drag it, I can kind of rotate this, orbit around that pivot point, and it's got a predefined pivot point. So I can do that to take a look at this project. I can also just click on the cube to get different views. Like this is a front right corner. I can do a bottom right corner. So I'm underneath the model, which is a strange view. Let's go back to the top. I can do a front, so it's like an elevation view of the front of the house. I can do a left view, left elevation. So I can easily take a look at these pre-canned views. Now I can also orbit this if I hold down the Shift key and then use my mouse button, click on the mouse button. So Shift, mouse button. Now I can orbit up and down or left and right to circle it, and I can pick my orbit point. So here, if I want to look at what's going on. Again, these are all exterior views right now. And I can even change how this view looks. Over in the 3D view, discipline, electrical, we can change this to a different discipline. Now, I like to jump down to coordination view and apply it. Now we start to get some colors applied, and it depends on how the architect built this model. Again, this is a very simple model. There's not a lot of color, to the walls, or it's just kind of gray because we're mainly using this for electrical purposes. But you can change the view to shaded. You can change it to consistent colors, which changes it a little bit. Hold the Shift and orbit again. This will give you a good view of what this house is. And now, if we look through the back windows, now you're starting to see some of the internals, interior details of this. So that's the basic 3D view to get an idea of what we're looking at. So now I want to jump into these things I call levels. And these are very important for creating our floor plans. So let's go back to the power plan, floor plan, first floor power. Double click that. Now this shows up automatically looking, it looks correct to me, right? I see doors and windows, things like that. And this just happens to be by default set up properly, but we need to verify this. So let's go to one of our elevations and let's try like a south elevation. We're going to be at the south, looking at the south side of this house. South elevation, double click that. This is where we can see these levels. It's these lines with the circles. There's a head on them. There's levels established in the architectural model, and then we also need levels in our own electrical model to develop floor plans from. Each floor plan has to be based upon an actual physical level inside our model. Because I can't select the architectural model because it's pinned, anything I select is only going to be ours. So if I click on this, you can see I've selected 2 levels. So if I hover over it, there we go, there. Now it's hard to see because they stacked on top of each other. What I can do is there's a little circle right here on this level that I can take and I can drag it. And now I'm dragging both of my levels. I only have 2 levels in here right now. I can drag them. So I have a level 1 and a level 2, which are what these 2 floor plans were derived from in my project template. Now I need to make sure that my levels match the architect's levels, and each project you get will have a different level set up that you will need to adjust to. As you can see, my level 1 is down here at the architect's grade level, and I want it to be up at level 1. And I can't really see what height it's at. Well, that's a scale issue. Down at the bottom left, you can change the scale of this view, just this one view. And so I'm going to change it to a different scale. That will make my annotations, my text, be a different size visually. So let me go to a 1/4 inch scale. As you can see, as we get a larger scale, the text shrinks because it's annotative. But now I can actually see what level 1 is. This is at 1'6" above grade. So I want to move my level up to level 1. We can grab it and we can just drag it and move it around. That's one way to do it, and try to get close, but it's hard to get exactly on. So what I can use is a tool called the Align tool. I can get to it from the Modify tab up top, or I can just, once I click on my level, the Modify opens up automatically. So then I get to the Modify ribbon. So under Modify over here, this little guy here called Align. Now you can see in parentheses AL after it. That is a keyboard shortcut that as you get more proficient in Revit, you can just use AL. You just type AL and no enter, nothing like that. Just type in AL. Like right here, AL. And it gives me the Align tool. I like to teach it first using the ribbon so you get familiar with things are. Click on Align. You'll see the Align tool pop up on the cursor. Now what this is saying down the bottom left, tiny little text, please select the line or point reference for alignment. Okay, so what it means is, what do I want to align to? Where's my target? I want to align to this level 1. And now it lets me select it. And then select an entity to align. It will move into alignment with the reference, the first one. So to here from here, and that pops up. Now it's aligned exactly. And then my level 2, I don't have a second story on this building. It's a simple single story residence. Let's make level 2 be the roof level. Now, I may never need to show a floor plan of the roof. I may not have roof equipment on this house, but it's still good to have an upper level above the main level for kind of constraining some of our objects in view. So let's go ahead and do that. So we're going to click on level 2, hit the Align tool, click on, I want to go to the roof from here. And then I can merely click on this word level 2 a couple times and I can change it. I'm going to make it roof. I want to make it match the architect's. So we have the architect's level in their model. We have the actual roof in our model. I also want to get the grade level. Well, it turns out that looks like our walls come down to grade level. The garage looks like it's at grade level. Even though the rest of the house may be at level 1. So we want the grade level as well. Now, how do I add one? Well, I can go up to architecture and go over here to the level command and add one. Start drawing in a level. Or I can copy this level. So click on it. Now up on my Modify tools, here I have one called Copy or CO. Copy. Click to enter move start point. Well, it's not a move, it's a copy, but same idea. I want to start from here and I want to copy it down to here. I can't copy and align at the same time, but if I do copy it from this point, copy there, it will kind of give me a snap. You can see the little purple, it highlights it. So it does give me a snap. As long as I stay in a 90-degree angle, it will snap right to it. If it doesn't, I can use the align tool. Now, it just gave it the next name in the sequence. Now, this template looks like someone had been doing some mechanical plans since this template was originally developed from a full MEP template. So it tries to name it mechanical. Well, we don't have to go with that name. We can name it what we want. I'm going to call this grade. So now I have levels in my model that I can get to and control that mimic what's in the architectural model. And many architectural models will be more complex. They'll have interstitial levels in here that you don't care about. You don't have to copy all of the levels. Just copy the ones that we will need. So there. Now what that does is levels dictate what my floor plan views are going to look like. And so let's get into that next, how we control what the floor plan looks like. So jump back into my floor plan, and I can also get to it from these tabs up top. I can navigate to the views I've already opened. Now, if you get too many of these tabs up here and you really just want one, you can close them individually with the X, or there's a shortcut for that. Clear up top. This very, very top bar is called the quick access toolbar. And there's things like opening files and saving files, printing, but there's also some things over here. There's one here that has a little red X on it. That's called close inactive views. If you click on that, it will close all of the other views except for the one you're looking at. It doesn't get rid of anything. It just closes them so they're not here as tabs. So if I just click on that, there, it got rid of all the other tabs. It closed them, didn't delete them. So here I am in my first floor power plan, and you can tell it's highlighted. That's the one I'm in. Now that whole level idea dictates what this plan looks like. And over on the right, if you dig deep, you can see that the associated level of this view, floor plan view, is level 1. And it's grayed out. I can't change it. Once a plan is created at a level, it stays at level forever. So I have this level. Now, what I see in floor plan depends on where in relation to this level do I slice the walls, slice everything to see it in plan view. I can see doors, and I can see these windows and windows back here. That's because I cut the building at a certain spot where it cuts through all these doors and windows. So let me just draw some lines in here for you to show you what I'm talking about. Good. I have some red lines. I'm going to draw that. So I'm going to draw a line like right here. If I was to cut this building in two pieces right across there, I'd be cutting through the wall, cutting through the garage door, I'm cutting through windows and such, and that's why I can see the garage door. See how it looks like a door? And I can see doors and windows. If I was to cut this floor plan way up here, I would not be cutting the doors down here. I'm above the door. I would not be cutting the door. I would not be cutting this door, not this window. So my floor plan would just look like walls. This cut line is determined in a thing called the view range. So back to my floor plan, over, under, extents, there's a thing called view range. This is very important in Revit because Revit's a 3D world. So let me jump into view range and edit it. And it's got a number of boxes that we're going to talk about. And here's a diagram that I was kind of showing you of our section of our building. So first of all, let's look at this top here. The primary range. We have a bottom of the range. It's just controlling what we see. The bottom is this little line 3. Primary range bottom right there. That's the bottom extents. So the bottom is set up at the associated level. That means associated level that this view, this plan, is associated with level 1. That's going to be the bottom. Now we can offset that to be above the bottom or below if we want. Maybe we want to go a foot. We don't want to see the floor. We want to see above the floor. You can change that. And then you have the top, this line 1, primary range top, is how far up do we want the floor plan to see. This is set up right now for the level above. That's why it's important to have that roof level. It can be set for the associated level, level 1, and then I can just give it, maybe I want to see 8 feet above level 1. So I can give an absolute value above level 1, or I can just say, go to the next level, whatever it is. I don't care how high the roof is, just show me everything to the roof. Or I can even say unlimited, and that's useful in some situations. But the basics are, we want the bottom at level 1, the top is up at the next level, and then the cut plane, where I'm cutting the walls, cutting the building to see the objects, is this number 2, this cut plane. And right now it's set at 4 feet above the associated level. I could change this cut plane to something higher. Now I have a whole other video on this view range, which goes very much into detail about it, and I'll put a link for that in the description below. But it's very important to get familiar with this view range. So let me just show you a few things here. That cut plane, let me draw some dimensions. We can go up to this quick access toolbar right here, align dimensions, and I'm going to draw a dimension from my level 1 up to there. And I'm going to click anywhere. So 8'6", let's move this down to something like 8 foot. And I can click on this to get it to 8 foot. I'm going to do a cut line at 8 feet above the level and see what happens to my floor plan. So go over here to view range, change this cut to 8 feet. Now, did my floor plan change? Well, let's zoom in and take a look. I no longer see doors. I don't see the garage door. I don't see these front windows. I see these windows. So what's going on here? Well, it's hard to tell here, but these windows actually extend up above the 8 foot mark. That is what determines what my floor plan actually looks like. So the long and short of it is the cut plane is typically somewhere down into 3 or 4 foot range so that I can cut through windows, cut through doors. So if I go back here and let's change, escape out, let's change that view range cut line back down to 4 feet, enter. Now I see what I want to see in my floor plan. Again, it's essential to understand view range, and you'll find as you get into Revit that you need to adjust that cut line. Sometimes different views need different cut planes. You need different top levels, bottom levels. There's even a way you can see under the floor, but we'll get into all that as we go. I just want to give you the basics. So that is what determines what the floor plan looks like, and it affects your electrical stuff too. Now, since we do not have a second floor in this simple single-story residence, I don't even need a second floor plan that's in my template. So I'm just going to delete it. Click on that and hit delete, and it's gone. And I can do that up here with my lighting as well. One more thing I like to do to prepare this for electrical information, and we'll get to electrical here soon, I promise. But there's always some prep work when you get a new project started. These grid lines that architects use to identify structural elements and walls and such in the building, you'll find that you really want to have control of what they look like. We want to be able to control which end the circle is on. How far do they extend into our floor plan? Even what line weight are they? So I can't control it now because it's part of the architectural link. I could turn them on or off, but I can't change how they look visually. So I need to copy these grids into my electrical model that I'm working in so that I have control over them. I could just draw them from scratch on top of the others, like you could with levels, but I'm just going to show you how you can copy them. And so a common thing to do with these is to copy, and you can even monitor them. That means Revit will tell you if they move so that you know. You can keep track of if the architect has moved them or changed them. Let's go up to the Collaborate tab now. This is a collaboration thing. And over here under the Coordinate is a Copy Monitor button. So let's hit that. And they're asking which project. No, I don't want to use the current project. That's my project. I want to select a link. So hit Select Link, and then I can hover over it. It'll let me select a link even if I have this pinned element turned off. So if I hover over this enough where it lights up in blue, I hit an element, Then I can just click on that. Now I have selected that Revit link. And get out of this and do it again. You can make sure you get the right link. Sometimes we'll have more than one link, but in this case I only have one. Hover over it and wait a second, and it'll tell you that it's the linked Revit model, the Arch R23. So you know you have the right link. We only have one right now, so it's obvious. Now over here, we have all these other buttons. Well, we want to actually copy. We'll copy and monitor it. It's not written that way, but once you hit copy, you can see you're going to copy and monitor. And we don't just want to copy and monitor one grid. Like if you start hovering over, you can see they start highlighting. We can also copy and monitor walls and other things like that. But we just want to copy and monitor the grids. We don't want to or need to copy any of the architecture. We want to leave that as the link. So we're not going to copy that. We're only going to copy the grids. We want to copy multiple grids at once. So that's what this little button here is for. Click on multiple. Now we can use the window tool to window around the entire building. Make sure we get all of the grids. Now we got walls and windows and everything, but we'll fix that. An important tool in Revit is the filter tool. This little guy right here. It looks like a funnel. You'll find filters throughout Revit, and this is a selection filter. So click on that, and it gives you a list of all the things that I've selected with my window. I've got 7 floors, 10 grids, 9 plumbing fixtures even, and 39 walls. I don't need all of that. So let me just say check none. I only want grids. I've got 10 of them. Okay. Now I've only selected 10 grids. Now it stays highlighted, but it knows that I've only selected 10 grids. So now I want to finish my multiple selection with this finish. I don't go to this finish yet. Stay down here. I finished my selection. And it just says that the family grid head has been renamed to grid head circle 1 to avoid conflicts. That's fine. I've finished the selection, but I still need to finish the copy. So it dumps you out of the command. You have to go back up to the copy monitor tab on your own to bring it back. Now I can click the green check mark to actually finish the copy monitor command. And then it wants to save the project, which I would encourage you to do every chance you get. And it's done. Now, as I hover over these, I can see that I can select these grids. They're in my model now. I have control. Now I can click on the grid. Now you can see that I can move. If I select the circle, I can move it around. Well, I see another grid here. Well, that's the architectural grid that's still showing. But this is my grid, and I can actually turn that head on and off. I can move it maybe to this side. So now I have control. I can even control how far these grids stick into my floor plan and things like that. So you'll be glad that you can control these individually. I don't want to see the architectural ones, so we can turn those off. This is another feature of Revit that you will get very used to, is turning things on and off no matter where they are. And what I want to introduce you to is the idea of categories. Revit is composed of families, which are individual building blocks. And I have a separate video that I'll link below about, they're kind of like Lego pieces. You've got a building block that's for architects. They have a toilet building block and a wall and a door and a window. These are all blocks that they bring into to build this model. We have building blocks like receptacles and lights and switches and panels. They're called families. Well, those families are associated with a category. So I think the best way to show you what I mean by categories is over here in the project browser under families. Let me open that up, expand it. The first headings you get, let me close some of these. The first headings you get are the category. There's things called analytical links. There's annotation symbols, cable tray fittings, cable trays, ceilings. These are all the categories of families. Down here, we get things for electrical, like our electrical equipment. Electrical fixtures are separate categories. We can control their visibility separately. If I want to turn off all of the walls, for example, I can do that. If I want to turn off all the toilets, I can. Plumbing fixtures are a category. So we have different categories. Now, the way we control those categories is to go over here in our floor plan. Under graphics, down here, there's a thing called visibility and graphics overrides. You'll get very familiar with this button. Let's edit the visibility. Again, here's categories. Now they arrange them in model categories, annotation categories. So annotation categories are kind of the two-dimensional text and tags and just two-dimensional pieces. And you'll see here there's a lot of air terminal tags, area tags, there's text notes, title blocks are annotative. They all kind of the two-dimensional things that are not part of the 3D model. Go back to model categories and you get things like ceilings and cable trays. And go down here, we have ducts, electrical equipment, electrical fixtures. These are the categories I was telling you about. You can control the visibility of those, whether they're on or off, simply with a click of this checkbox. I don't have any electrical stuff in here yet to turn on and off, but I can show you what I mean by turning off architecturally. Let's say I want to turn off the walls. Unclick walls and say, okay, they disappear. The walls are gone. So one fell swoop, turning off the category called walls, they're all turned off. That's the basics of how you can turn things on and off. Now there's more granular control of turning things on and off, but we'll get into that as we get further into these lessons. So turn those back on, and I can go into annotative categories, and I could turn off the grids. If I hit grids here, now it turned off all the grids, ours that are in our model and the architect's. Well, in some cases, you want to leave your own model grids on and turn off the architectural grids. So that gets a little more complicated. We have to get into the visibility of a linked model versus the visibility of our own model. So let's go back and turn grids back on. It's annotative. Go down here, and you can click here and then just hit G, and it'll pop you down to the G's. Turn grids back on. Now, we are turning off things in our model. We're dealing with the visibility of this first floor plan power. Although it turned off the architects too. Why is that? Okay, up here on the tabs, you go clear to the right, we get to our Revit links. Click on that. Now we can get to the controls for Revit links. We only have one link, an architectural link right now. The visibility, the display settings are controlled by the host view. What does that mean? Well, we are the host. Our model is the host. We are hosting the architectural models link. So we are the host. What we do in our model determines what happens in the architectural model. It mimics what we are doing because it's set up to display by the host. We want to separate that. We want to be able to control this separately. And if I just click on the by host view, I pop in this whole nother Revit link display settings. So now I can control what happens of just that architectural Revit link. And it gives me some similar headings that I had in my own model. There's a basic one that we want to change to custom. Click on model categories. We want this to be not host, not by us. We want to customize it. So hit custom. Now I can control, I'm in the Revit link, and look up here if you get lost. We're in the Revit link. I can turn on and off things in the architectural link, just like I could do it in my own model. I want to turn off the annotative element. Let's go to custom again of the grids. So go down to G. I'm in the Revit link, and I'm going to turn off the grids in the Revit link only. Okay. So I no longer see the architect's grid. I turn them off in that link, but I still see my grids because I didn't turn them off in my model. So as you can see, there's two different sets of controls. We're controlling now the architectural model separately, the visibility. Now, another part of that visibility real quickly is the override, the graphic overrides part of it. Not only can we turn things on and off, but we can control how they look. And you can get deep in the weeds on this, frankly. And we'll get there eventually. But for right now, just realize that you can basically turn things on and off by category here. That's a simple way of controlling how things look. Now that we have the architectural model linked and set up the way we want to start developing our power plan. Now, one more step before we actually start drawing in our electrical items is, in this case, we have access to the mechanical plumbing model also. which typically has electrical connections that we need to make. We need to connect things like furnaces. They might have wall heaters. They might have exhaust fans, things like that are in this house that we need to connect. A lot of times in residential projects, you may end up just having a PDF or a CAD version of the mechanical model, which is fine too. Then you'll just have to draw those in yourself. But in this case, I want to show you, if you got lucky enough to get a mechanical model, we are going to link that in to this as well so we can see their equipment. We're going to go back to Revit Links, and that is in the Insert tab. Over here, we have Link Revit. We're going to, like we did the architectural model, we're going to link in the mechanical model. Link Revit. It opens up to where we stored it. Here is the mechanical. We don't want the backup. We want the regular. So the mechanical, we want project base point to project base point, which is still selected. Open that. That will link in the mechanical model. As we can see, it's up converting from 23 to 25 in that model as well. So give it a second to do its thing. It's not a very complicated. Now, what's this box? Nested links, invisible. The following nested links will not appear because their reference type is set to overlay, okay, in the mechanical. Now, what does that mean? Well, the architectural model was linked into the mechanical model, like we linked it into ours. It was linked in either as an overlay or an attachment. If it's an overlay, that means that it won't get linked into our model as well. So we don't need the architectural linked in again. So that's the normal procedure, that we only want to bring in the mechanical. We don't want to bring in the architectural. So this was fine. So now what happened? Well, I see a few things popped up. I see some green boxes. So that's something new, but that's about all I see. Oh, maybe down in here, if we weren't paying attention, we've got some more boxes out in the garage area. So we've got our mechanical model linked in. Now, because this is our project template is set up on our power plan to show some of the mechanical equipment. Let's go back to that linked control of visibility and we'll see what's happening here. So back to the edit the visibility, Revit links. Now you can see we have a second link in here, the mechanical. Right now it's being controlled by our host view, which is fine for now. If we need to go in and change the mechanical, we can. It looks like the mechanical doesn't have the grids in there, so we don't have to worry about that. So we're fine with controlling the mechanical model now based on ours. So if we go to our own model, we can see that down under mechanical, we have mechanical equipment checked. So it's showing up. Now we don't have any ductwork checked. If we set ducts, let's see what happens. Now we're starting to see some blue, and here's some green. We're starting to see ductwork. Well, I don't want ductwork showing up in my electrical floor plan, power plan. I may want it showing up in some other view that I use to coordinate, maybe in a 3D view or things like that. But in this view, I don't want ductwork to show up. So that's why I have it turned off in my model. And as we saw, the mechanical link is following what I do. Now, I can't click on their pieces individually. I'm clicking on the entire model. So I really can't get into their pieces and see what they are. When it comes time to show connections for their equipment, I'll have to add something into my model that has some equipment information, which we'll get into. So the next step in my power plan is I really would like to have some room names in here so we know what all these rooms are. Now, if the architect has rooms with room names, room tags in their model, we can just mimic what they did easily. Let me show you how you can do that. This is an annotative thing, two-dimensional tagging, if you will. So we go to the Annotate tab, and there's a special command over here called Room Tag that we need to click on. So Room Tag, which is shortcut RT, click on Room Tag. The rooms show up as this blue shaded and these big X's. Each of these X's is showing there's a room physically put into the architectural model that we can get to in our model. So if I hover over this, you can see their tag name pop up and a number. So this is the great room. This is a hall. This is a restroom. This is a BR bedroom. So we can just drop these tags into our model, copying what the architect did. So click on that, there. And I can just put these anywhere I want, and I can move them around. So I'm just going to drop these in. There's a shortcut to this. I can just go up here. There's a button over here called Tag All. So click Tag All, and it lets me go down to room tags. But I also need to make sure I include elements from linked files, my architectural link, and say OK. And there, it put room tags in for every single room. And again, these are in my model, so I can click on it and hold it down and drag it, or click on it once and then find the little move symbol and drag it from there. And I can move these around to where I want in my actual model. So I can rearrange these to see how I want. Now, these are only in this view. Annotative elements like this are only in the view that you put them in. For example, if I happen to jump over to this first floor lighting plan, double click that, you won't see those room tags. They're annotative. They only show up in the view that you put them in. Model elements, on the other hand, like doors and windows, things that you would actually construct, can be visible in multiple views, but just not these annotative elements. So there we have all of our room names or room tags in this project. Now we're at the point where we can actually get into some electrical design and drafting. So what we're going to do is we're going to bring in some receptacle families and put them into this model. Like I mentioned, families are the building blocks, and they're arranged by category. So if you expand this families heading and scroll down to electrical fixtures. Now let me just show you, electrical equipment is pretty much, think of distribution equipment like transformers, panel boards, panels, transformers, more transformers. These are equipment, and then the actual devices, you might call it, are called fixtures in Revit. So we have duplex receptacles, a high voltage receptacle, which will be our 240 volt receptacle for like a range. And then we have some junction boxes that we'll use for connecting mechanical equipment. But for now, we're going to start with duplex receptacles. And again, all of these are loaded into this residential electrical template. So expand duplex receptacle, and there's a few options. These sub options under here are called types. Under one family, the duplex receptacle, you can have multiple types of that family, which has different characteristics. And I'll show you how those work. But right now, we don't need the GFCI. We're going to put a standard receptacle. You can just grab this and drag it in, hold your button down, drag it in, let go, and we want to install this in this family. Now, I'm getting the do not enter sign, the circle with a slash. Well, what's happening here is this family has to be attached to a wall. As I get close to a wall, you see it there, the receptacle symbol pops up. And if I get away from the wall, it's gone. I get close to the wall, it wants to attach to that wall. Now, if I keep moving it around, it's looking for different things to attach to. This kind of behavior is called a hosted family or a face-based family. It's looking for the face of a wall in this case. Now, up top, place on vertical face is the default. Now, we can place it on some other face like a horizontal or slanted face. If you click on that, you can see that now I've got some kind of a thick box in there. Well, it's trying to put a receptacle on maybe the floor or the ceiling, some kind of horizontal. And as you drag it around, you can see now it's trying to put it on the sink. So it is trying to attach itself to something. We want to place a vertical face. And this is how most electrical families are out of the box. They are trying to attach to a face. They're hosted to the face of this model. So we will get close and let it attach. Now, if you've done any electrical design for residential projects, you know that there's a lot of code rules, NEC rules and local rules and codes that affect where receptacles are placed, how far apart they can be, what height they can be, all that kind of stuff. So I'm not going to get into the details of all of that in this video. That's a whole nother subject. I'll touch upon it because that's something you'll need to know. But I'll also give you some links in the description below for some good YouTube channels, especially that have great code reviews and code lessons for that. But the basics are any piece of wall that's 2 feet or larger has to have a receptacle. So in this case, I've got the doorway from the door to the closet looks like it's wide enough to need a receptacle. So I'll put one there. Now, again, as you move this around, it's trying to find different surfaces. Sometimes you'll have trouble getting the right surface. You may need to hit the tab button. Now, the tab button is special in Revit because since we're in 3D, we can have different things stacked on top of each other vertically. The tab will cycle through those things that are stacked. For example, down here, we have a back of the toilet line is right on top of the wall line. So if I hit tab, it will find those different, see, I'm just hitting tab and it's bouncing around. It's finding different surfaces, different faces that are stacked on top of each other. Tab cycles through those. You'll get used to using that tab button. But in this case, this is popping right to the wall. So now I just click it and there it is. Now the question mark shows up because it can have a label associated with it, which I may or may not need. But I escape out of there. There we go. Now this template is set up to show this symbol as a nice thick line. That is controlled in settings, which we'll get to in the future. But this template is set up for that visibility. Now I can click on this and I can move it around. I can't move it away from the wall because it's attached, it's hosted, but I can move it horizontally. Now, why can I move it here? Well, that wall actually extends in front of this closet up high, and so it follows that line. So you just got to be careful where you put this. Same thing with this. The door interrupts it, but there's still a wall there above that door. You can see this is a symbol, a two-dimensional symbol. If I click on it, there is data within this symbol. And that's one of the pieces that makes Revit so powerful for us in electrical, is that we have electrical data inside this symbol that we can use to connect to each other and make an actual logical electrical system. Let's take a look at what's here. This first box here shows you what this family is. And specifically, this instance or this one receptacle at this location has this data. If I were to put another one over on this wall, it may have different information in this box. So let's take a look at that information. First of all, you get the family name, Duplex Receptacle, and the type is called standard. We saw that there was a GFCI type as well. But this one receptacle now, it's related to level 1. So this elevation from that level is 1'6". Now, is that to the top, bottom, center? It depends on how the family was constructed. In this case, I just know from experience that it's to the center. It's telling you it's hosted to a linked Revit model, offset from the host, which would be the wall. If we want to have this receptacle a foot off the wall, we could do that. We don't want that in this case. Now, electrical loads, panel and circuit number. We do not have it connected yet to a panel, so that this is empty. We don't worry about this data here. Now, phasing is project phasing, not electrical phasing, but project phasing. We can say that the phase that this receptacle is created in is new construction. This whole building is new, so everything's new construction, and we're not demolishing it. But if you had a remodel, you could use these things to dictate whether this is an existing receptacle or a new receptacle. Does it stay? Does it get demolished? That can all be determined here in the phasing. And then these other things we don't worry about. Down at the bottom, it tells us the electrical data. It's 120 volt, single pole, 180 VA. And it's grayed out. I can't get to that. Well, how would I change that? There's also other parameters or variables associated with this receptacle. This is the instance one, so this is this one only. But if I click on this thing called Edit Type, now I'm getting into the type properties versus instance. So type controls every standard duplex receptacle in this project will have this information. So if I am going to change the voltage of this receptacle, every single standard duplex receptacle in my project will change to that voltage. The load classification. If you're doing something like a commercial project where you're adding up loads and applying 125% to continuous loads, maybe you're applying the first 10,000 VA plus half of the rest to receptacles. Commercial loads have different demand factors. Now we're residential, so we're going to be doing a totally different kind of load calculation based on the NEC rules. This isn't as critical in this residential project, but because Revit was primarily made for commercial. Again, the load, if we were doing commercial load summary, the load would be 180 VA per receptacle. We're going to calculate it differently. So these don't matter as much residentially, but just let you know it's all there. And a lot of this stuff too is just, if you want more information about this type of standard receptacle, you can put things in like that. And we'll get into some of these as we get into lighting. But that's the basics of the type parameters. So if I jump over to look at a GFCI, what makes it different? Well, the default elevation starts out at 4 feet. That makes it different. I guess this was set up for maybe an above counter type of GFCI. It ends up looking different symbol-wise too. See, it adds a label, GFCI, to this as well. So that's a type parameter. If I change the type to the GFCI, it changes how it looks, and it would change every single receptacle that's the GFCI to look like this. Let's go back to standard. Now I need to place another one. Now there's another way we can place receptacles. If we go up to the Systems tab, you'll see it arranged by HVAC, and it pretty much means the MEP tab. We've got mechanical, plumbing, and over here we get electrical. Sometimes you'll see electrical on the left. These can all be actually moved around, so we can move it over here if we want. But I'll leave it here for now. We can put in cable tray and conduit, parallel conduits, electrical equipment like panels and such. We're doing devices. So if I do the drop-down device, I can get to my electrical fixtures devices, like receptacles, and we can get into communication and data, fire alarm, lighting, all these other electrical trades as well from here. We're doing electrical fixtures. Click on that. Now it lets me choose here what do I want to put in. So then I can go down to my standard receptacle and do that. Personally, I like to drag things from the project browser. I treat it like kind of a tool palette. So that's my preferred method. Another great method is if you already have one in and you just want to make a copy of it, copy behaves differently. If I just click on it and go up to my Modify tab and find Copy, it'll let me copy it from some point. Let's say from here. Well, Copy, though, won't let me put it onto another wall. See how it's copied? It's only going horizontally. I can only copy things to the same host, which is this wall. So copy has limited use sometimes in Revit. What's more useful is to right-click and go up here. There's a bunch of context commands, but go to Create Similar. That is like inserting another instance of this same family type, but it will let me put it anywhere I want. So I use Create Similar a lot. So here we go. Now, another code rule you'll run into on residential is from an end wall, I can't be further than 6 feet away from an end wall. Well, we're 6 feet. What I like to do is go to the Annotate tool, Detail Line. Now you have different kinds of lines you can draw. You can use a line tool, a rectangle tool, circle tool. You can draw whatever shape you want. I'm going to stick with line for now. And I can pick my line style. I did red before, but what I'm going to use is just something like a medium line. Now this from here to here is probably like a foot. So I'm just going to draw it from here. And I'm going to go maybe up 5 feet max. See how I've got a dimension line there? So maybe 5 foot is as far as I want to go because this is a foot. That will let me put this receptacle not more than 6 feet away. So I use lines like that to space my receptacles. Now the next rule is I can't be more than 12 feet apart along the wall. So let us figure out what is 12 feet from this receptacle with our drawing lines again. So again, I'm just using these medium lines. Let's go along the wall, and we have 6'1" to there. So we can pretty much go another 6 feet. I like to keep it just a little bit short. And let's put that here. So right click, Create Similar. And as we get close to that wall, it will snap into place, something like that. Now, one thing we want to worry about when we lay out devices is the vertical height and how that relates to the architecture. Are these windows clear to the floor? How far from the floor are they? Can we get an 18-inch receptacle. Let's say we want to put this here instead of between them. Well, there's a few tools we can use to take a look at the architecture, even within our model. We saw the 3D view default that shows the exterior of the building. Well, there's a ways we can look at the interior of the building. One thing we can do is drop a section, create a section through this building. Now up top in the quick access toolbar, there's this little thing, the circle is a section. You click on that, and then we can draw a section symbol. Pick the start point. Let's start out here somewhere. Drag it to the right, and I want to keep it parallel to my back wall. And I can go all the way through the building if I want, or I can just go through one room. Let's go all the way through the building for now. Click a point. Now, when you click it, you can see that there's a dashed boundary for this section. This controls how far left and right, east and west, our section will look. And then this says how far north, or I call it into the model, if we're standing at a section looking like an elevation at this wall, how far in do we want to see? So it doesn't matter so much here with the exterior wall, but I'll go just outside the exterior wall, escape out of that. Now, if I double click, not on the line, but on the head, then it will open up a section view, section 1. It also creates a section 1 view over here in my project browser. Now, you may not see it right away. It might have gotten buried somewhere. And what I see is some question marks with a plus and section, building section. So it created its own place in the project browser for a section. And there it is, section 1. If I'm going to save this section and want to call it something, I can actually hit F2 or click on it to rename it. And maybe I'll call this something like section, and I like to use capitals, section, back of house, something like that. And we can rename this. But there, a section. Now this section has this box around it. If I click on that box, I'll see some grips. These squiggly grips will break the section in pieces. If I want to eliminate the center of this and have 2 separate sections, see how that works? Undo. You have an undo button up here. Or I can grab this circle grip and drag the section down. I don't need to see this high, so I'm going to pull this down to the roof line maybe and stop. Now you'll notice that these grids moved along with this section. And that's one reason that we brought these grids into our model, so that they follow along with our section. So the annotations will follow along with our section. We also don't need to go that deep, but this can be adjusted. We can even adjust left and right from here, just like we could. See how that moved? It moves in both of these views. But let's take a look at our bedroom. Now, what we see is that our receptacle is mounted up on the wall. That's our 3-dimensional symbol. It's a cover plate that we see on the wall, and it's below these windows. So we are okay to mount this under the windows. We're also seeing some blue stuff here. What's this? This ends up being part of the, click on it, part of the mechanical model Revit link. And these look like some ductwork and maybe some diffusers, some floor grills. And so that can be used for coordination with our electrical model if we have some interference or clashes. But our basic reason for this is to see that wall. Now, what else can we do? Another thing we can do is to create another 3D view using a camera. So we'll go up to the quick access toolbar. This little house is the default 3D view. Now we already have one of those, but if we do the drop down, we can get to a camera view and create our own perspective type of camera view. So click on camera. Now we can place the camera anywhere we want. I'm going to place it as if you walk into the room through this door and you want to look at this northwest corner. I'm going to drop it kind of in this corner. I don't want the door. I'll put it right here. And then my second click will aim the camera, and I'm going to aim it beyond the walls and click there. So that gives me a view of that room. We can see our electrical cover plate right there. Now we can change this view like we did before. We maybe want to change the discipline to coordination so that it looks differently. Now, when we change its discipline, it also moves it around on our project browser. So our 3D view now is under coordination right there. And we can give this a name. I like to name views. Specifically, the 3D views, if I create another 3D view, it will write over the old one. So I want to make sure I have a name on here. So I like to leave it something like 3D, I'll say bedroom. And I don't remember the name of this bedroom. I'll put Northwest. What if I want to change this view? It's easiest to change it from here. So if you hit F8, or let me click on the view, hit F8, you will get this view control. We can zoom in, we can orbit, we can pan left and right, we can rewind if we were creating a walkthrough. But I like to look at one, there's one here called look. If I click and hold look, now as I move my cursor, my mouse cursor up and down, I'm looking left and right. So I can aim it so I look down. Now you won't see everything until you unclick. I see the grill for the HVAC system. I see, and I'm escaping out of this, and I see my cover plate. Now out of the box, Revit cover plates just look like a rectangle. There's no symbol, there's no, receptacle holes on the face, no screws, nothing fancy. And we can always add that, but that's a family editing procedure, which is an advanced topic. We're not going to get into any family editing in this lesson. So this is very basic. But that gives you at least a 3D representation of what that looks like. Now, F8, we can also go to up, down right here. Hold it down. Now I can go change my eye level of my camera up and down. So another thing I can do is I can hit this walk. Now I have to warn you that it's very sensitive. If you hold down walk and you barely move your cursor forward, it walks pretty fast. See that walk? I'm barely moving. If you go too far, you will walk very fast. I can spin around. There's my closet door. I can do a little bit of a backup, but you have to be very gentle with the walk command. But as you can see, it's a handy tool for walking around this house. Now I'm going to go through this door, which is closed. It'll let me go through walls. Let me walk out here and see what we get. There's my hallway. Let me turn. If I memorize my floor plan, I should be able to get around this door. And I went too fast. You can see what happens. It's a little hard to navigate this way, but this lets me look around. Now, I'm only seeing a certain distance because my camera, where I stopped my camera, is my depth of view. But I can actually change the far clip offset. That depth of view is 27 feet. Let's go 100. 100 feet. 100 feet. Now I can see further. Now I'm outside, and there's my driveway. So let me do the look. Look up, look back. Now we're outside our house, looking at the front. We can walk into the garage. Again, be careful. And you can just tour the building this way, and it really helps you to get an idea of the architecture of this building. So pop into the garage. Now look at that. Now we see that we have a furnace, it looks like, and we have a water heater. Now these are up off the floor. They haven't drawn in the rack or stand that they're sitting on. But anyway, again, this gives you an idea of what's going on in the building. So I'm going to take this back to where I was in the back corner, just so that it matches the name I gave to this view. So let me just kind of get it back there. Trying to walk my way in. There we go. Walk my way into that room. So that's the other way. There's yet another thing you can do to see this in 3D. Now, this one you have to have at least something electrical in here that you can grab to create a view. So let me just actually window around all these devices. Up here under view, there's a little teeny box. It's next to this X. Selection box. Now, it says selection box, but it ends up being what's called a section box. Click on that. There. It did some kind of a 3D view, but if I use my mouse wheel to zoom in, I can only see bits and pieces of my architecture. What it did is it created a little box around the pieces that I picked. I only picked these receptacles, and so it's limited. But I can take that box and expand it. Well, I need to be able to see this box. In this view and in my project template, I don't have the box turned on. So here's some practice on how to turn things on and off. Go back up to your visibility. And we want to turn on, in our model, a thing called a section box. Now, let's look in the model category. Click here, hit S to get out of the S's. Is there a section box? No. Let's try annotation. Click somewhere, hit S. There, section box. It's off. That's why we can't see this box I'm talking about. Say OK. Now we have the outline of a blue box. There's a lot of boxes here, and I told you I'll tell you about these green ones in a minute. But you click on this blue one, that's called a section box. Click on it. Now we have some grips. This is kind of a left-right grip, an up and down, and an up and down, and a left-right. This is the top of the box grip, and this is the bottom of the box grip. So we can move it, and we can move it to the right. And what it's doing is it's establishing boundaries of a cut, of a section. They call it a section box for that reason. We can drag the top up, and let's say we want the top to be just below a ceiling. We see the closet doors. You go further and you'll see the closet. Now I'm into the restroom. We can drag this around and see pieces of our house. Now we can just make this completely, take the whole house if we want. Now we're seeing some of the furniture and some of the cabinetry. So this is another nice way we can look at the interior of the building. And we can change its look. We can go back to hidden line so that it's more of a black and white. We can even go wireframe. But the shaded or consistent colors is kind of a nice way to look at it. Again, this is a basic architectural model. The walls are just gray. But again, we can use our navigation box up here to spin things around. We can hold shift. We can pivot like we did before. We can zoom in. So this is a great tool for taking a look at what's in our model. And maybe I want to pull this up a little bit. I went above the ceiling. So stay just below the ceiling. The ceiling looks like it must be higher in that room. So there we go. So we have a few nice ways to look at it. Now, here's that 3D view I was telling you about. We need to rename this. I'll call this 3D section box. So now we have a number of 3D tools we can look at. Back to our power plan. So we're good there. We want to finish this around, and let's just do a quick check to make sure we're not going to be further than 6 feet from this wall. So I'm going to go to about 5'8", right click, create similar, and get rid of that. Now I need to make sure that I'm not further than 12 feet around here. I may need to add yet another receptacle. I'm almost 6 feet, 6'4", so we're right at the brink. And we're only 5'4", so we make it. We made it. Looks like we are good there. Now, we just go through the rest of the house and add receptacles like that. If you look in the code, you'll see that if your hall's greater than something like 10 feet, we need a receptacle. I think it's a good idea anyway, whether it's required by code or not. So we can put a receptacle, say, in the middle of that wall. Down in this bedroom, our closet's in a different location. We have different rules. So we want to go through this and make sure we're not further than 6 feet from the door opening. Let's go to about 5'10". Again, create similar. These are all coming in at 1'6" height. You can tell over here. We could change that right here if we need to. It's an instance parameter. Again, what we see here are parameters, variables that control just this one receptacle, this one instance that I'm putting in. It doesn't affect all of them. The only thing that affects all of them is if I jump into this edit type. Now this affects all of the standard types of duplex receptacles. So I will just go through the rest of these bedrooms and get these put in, and I will zip this through so you don't have to watch the slow process. Okay, that's that bedroom. Now let's go back to the master bedroom and do the same thing. I'm going to create similar, get that in there, and then start my dimensions. 4 feet. Now let's check this last one. We may be too far. You know, we're more than 6 feet away. So we're going to have to put another one right here. Makes sense. This is a pretty big room. It needs 5. Now let's see what else we have for rooms. Let's go into this hallway. I want to do the same thing in this hallway. Let's get a receptacle into this hallway somewhere like that. Now the laundry room. This is a special room that has special code requirements for the laundry. It's going to require us to provide a laundry receptacle, laundry circuit that would typically power the washing machine. The dryer is its own connection. So we will need a connection for the washer, but I also like to, in this case, put a receptacle in for, this looks like a counter, a cabinet. So let's take a look at this room and see what it looks like. So I'm going to do the section box here again. Let me put a receptacle in here, right there. Now, this receptacle, I may want higher. I want above if this is a cabinet. Let me just click this and do that section box and we'll see what we have here. Again, it just does a tiny little box that we need to show. Now, we've already turned the section box on for our 3D view, so it sticks that way now. But we do need to spread this out to see what's in here. All right, so I'm seeing a lot of different things. I see my ductwork up here. Let's click this and I'm going to look from this other corner. And I want to get below the ceiling. There we go. I'm starting to see my laundry room. I can pull this in. There we go. And let's get over here and look at that angle. So, and this must be the floor. There we go. So we have our machines and then we have a counter. So I want to make sure I get that receptacle above that counter. Right now it's under here, I can't see it. So let's go back to the floor plan. How can I raise that up? If I click on it, the actual elevation from the level is what I want to change. Not the offset from the wall, but I want to put this up at, let's say 3'6". Now you can put 3 and a foot mark and put 6 in inches if you want. You can also just do a shortcut. 3 space 6 is understood as 3'6". And now let's go back to that 3D view. There it is. It got popped up. And maybe I wanted it at 4 feet, but we'll keep it there for now. And now, because this is an instance parameter, only that one receptacle got put in at 3'6". And let me go ahead and rename this. I'm going to call this 3D laundry room. These pieces of equipment, how will I know what they are? Now, they may be labeled on the actual architectural plans. If I had PDFs of the architectural plans, I could see that, but here you can't see any labels. What you can do, now as long as we have this set to select pinned elements, because this is part of the pinned background, if you remember. If I hover over something and hit tab, eventually, there it lit up. It will light things up. So if I hover over something and I hit tab, it lights up. Now I can click on it and I will see the information of that family, even though it's in the linked architectural model. So this says washer front load. If I click on that one, I get dryer front load. So we have washer on the left, dryer on the right. So that's one way you can figure out what things are. So this is the washing machine. Now, it just needs a 120 volt connection. Now, if I right click, select, create similar, this is going to use the same elevation of this one. I can change it back once I put it in here, or I could just make sure I create similar from one that's already at the height that I want. So I can do that. Let's put that there. So that's our receptacle for the washer. Now for the dryer, that will depend on whether you have a gas dryer or an electric dryer. We're going to assume that in this case, we don't have gas available, which is frankly happening in a number of areas here in the US. So we're going to go with all electric. Let us hook up a dryer connection. Now dryers, if you're familiar with those, are typically a 240 volt connection. So line to line. So we need a special receptacle that can do that. Let's take a look at this receptacle. We can't change voltage or anything here, but let's take a look at the type. What can we change about this? We could change its voltage, but we can't change the number of poles to make it line to line, which would be 2 pole. So we can't make this receptacle be a 240 volt 2 pole receptacle. we need a different receptacle. Well, that's why we have in our project template already another kind of receptacle. This one's called a high voltage receptacle over here. Let's bring that in. Standard, drag it in, and we're going to put it on that. Well, it's also wall hosted, as you can see. It wants to connect to a wall, so let's put that right, and it's finding something else to connect to. Sometimes you'll find that what's it snapping to? Who knows? Click there. And it's also mounted at 1'6", but it has a different symbol. Is that the symbol you want? It may or may not be. If you're using out-of-the-box Revit symbols, you're stuck with what they give you, unless you get into family editing, again, which is more advanced. So we're going to live with the symbols we get for now. I have many videos on my channel that show you how to actually customize these families and symbols and all of that, which you can take a look at. It's a more advanced subject we're not going to handle here. So we're going to live with that symbol, but we also want to make sure it has what we need as far as electrical characteristics, because even though we're not going to use the load of this, we're going to do it with a different method. We still need the voltage right so we can connect it to our panel and have a correct panel schedule. So let's see what we have for types. High voltage type. Looks like this one is already set up for us 240. Now that's the nominal voltage in the US for a house. Sometimes you'll hear it called 220, 230, 240. The code defines this as a 240 volt receptacle. So we're going to go with that voltage. It is 2 poles because it is line to line, not line to neutral. Load classification isn't as critical right now for residents, and the load is not critical for, we're going to be figuring out the loads a different way than commercial does. But 240 volt 2 pole is what is important. So we're good there. Now, when you have a special type of receptacle, I typically like to put a label on it, because an electrician looking at this won't be able to know that this is the dryer and this is the washer. So I'm going to label this. Now I can just type in some text. Now the way you type in text, up here you can see the big A, which is a text tool. It's also up here in the quick access. I can just click on text, and then over on the right, I can do a drop down to figure out what size. A 1/4 inch high text. This is in like a paper space view, a sheet space, actual dimensions, or a smaller 3/32. Well, so I can pick 3/32. Arial is the font, and I can just type in something like dryer. I can either close this or I can click out here somewhere and then escape out of it. And now I have a piece of text that I can move around. This text happens to have an opaque background, not transparent, so it covers up what I cover. I can move this around with the little move sign. And I can just put that here. I can also click on this, and up top, you can see I can add a leader. Left leader straight, a right side leader straight. I can add a left side arc leader, right side arc. And then I can even pick if the leader starts at the top left, at the middle left, bottom left, right, and all that. I can even set up how I want this justified, center, left, right. So there's a lot of things I can do with text. Let's say I want to put a leader out the left. Adds a leader, and it gives me some control points. Here's the end, the point of it, if I point to that receptacle. And let me say this dryer's up here, and I want to put what I call a shoulder. I can do that so that it's straight down. So you can get the appearance that you want. Out of the box, and in this template, we just have the open arrow symbol. You can actually change that. If you click on the text, you have some instance parameters just for this one piece of text, or I can change the entire type of text. The type is called 3/32 Arial in the family text. I can make the leader arrowhead different. This is just a 30-degree and ends up being open. I can make all of my 3/32 Arial have a filled arrow, 15-degree. Okay. There. Let's see. I like that better. Now, any text that's 3/32 Arial will have that kind of an arrow. So we can add labels to things, and this is just what I call dumb text. And in this situation, maybe that's fine. For when we get to mechanical equipment, HVAC equipment, we may want something smarter than a dumb text. We will get to that when we get to the mechanical equipment, and I'll show you how we can do a smart text, which is called a tag. Kind of like the room tags, but we'll be able to tag our equipment. And we can do the same thing for this washer. We can actually just click on this and copy it up here with copy. If we do create similar, it puts us into the text command. But if we actually copy this one, because it's not hosted to anything, this works. I can click anywhere and then just say I want to copy it down here. Now I can move this where I want. I can move the arrow where I want, and I can change this instance of text to washer. So at least we have things labeled now. Now I can go to some other rooms and finish my receptacle layout. Now in the pantry, this is just a storage room. I'm not going to need any receptacles in here, so we'll leave that out. Now we have great room, dining room, kitchen. Now the kitchen is going to get busy, as we know, electrically, but the great room and dining room will treat like any other room. And it's hard to see because of this grid line, but there's actually a closet door, entry closet here. This is looks like the front porch. So is this piece of wall wider than 2 feet? We can double check with our measurement system and see 3 foot. Yeah, it's almost 4 feet wide. So we need a receptacle. So let's go ahead and create similar from here. Now, again, are these windows too high? And now see, as you get here, it wants to jump around. So what you can do is place this on a good piece of wall here, escape out, and then you can drag this around along this wall. It'll even go to the other side of the door if I want. So I'm going to put this here, and I'm going to stay just a little shy of that window. If someone sets a little table with a lamp, they have a way to do this without stretching across. Now this piece between the doorway, the opening, and this closet door is less than 2 feet, so I don't need a receptacle there. But now I continue on from this spot, and I'll need something within 6 feet. So again, I will go through and start measuring. That's 1.3 feet and another 3 feet. So we got 4.3 feet, 4.4 feet. And let's go another couple feet here. So we'll get a receptacle. And again, just like we did elsewhere, we will go through and get all these receptacles put in this dining and great room. So now the next one has to be not more than 12 feet away. So let me just draw my line and go about 11.6, 11.7, and let's go ahead and create one similar right there and continue around the room. Go up about 9 feet, create similar. And we'll do the same here. Now I could just copy this from here to less than 12 feet there. Now, what happens here is it put it down at 0. So the copy is not always a reliable way to duplicate something. It's messing with its height. So let's get rid of that. And we're going to do our create similar again after we figure out how far away to put it. I'm going to say just short of 12. Best to actually do create similar so that it, especially with these hosted elements, so that they get hosted to the right piece. And yes, that's still at 1.6 feet. And let's continue around. We are 9.7, so I can go about 2 feet away. Get one in here. Now what's interesting is you can actually mount receptacles to grid lines. That is strange, but just keep that in mind if that's happening. See how it's flipping around too? It's trying to host to the center of the wall, so you really have to watch these hosting. Now, how are we doing? This is the end of this cabinet, and we have to be within 6 feet of that. So let's see how far we are. Just too far, so I'm going to go ahead and add another one. Now, we could probably play around with some spacings and maybe get it just to work, but, you know, I'll just add one in this case. So that takes care of that part of the great room. We also have this part of the great room, which we need to deal with. And this doesn't look like it's longer than 12 feet, so we can get a receptacle in the middle of this wall. It's not really a hallway, it's part of the great room, so I'll put a receptacle there. Now we can take a look at the kitchen. This is going to be a little busier. So let us see what we have in this kitchen. I'm going to do some sections. So let's draw a section. And just in case you're wondering, this seems like it's getting cluttered with sections. When we go to put this on a sheet and print it and all that, like a PDF, if the section symbol doesn't have a sheet in it, like if we don't actually put the section view on a sheet, this symbol won't print. And I will show you how that works when we get to the end of this project and start making sheets to print and print sheets to PDF. So we can put sections wherever we want, and it's not going to clutter up our final drawing. So let's go ahead and add a section here looking, and I'm going to go through the wall. And let's see how far we're looking. Again, I don't want to look further than just the wall surface itself. Double click that, and it's high. We can pull this down. So we're looking at that east wall, and we can see we have cabinets with a backsplash, and we have more upper cabinets. So we need to get some receptacles above this counter space. This would be considered part of the kitchen counters. And according to the NEC rules, we have to have receptacles at certain distances, even above counters, no more than 2 feet from the end and no more than 4 feet between them. It's a little tighter spacing than the floor receptacles. Again, review these NEC rules that I've linked below, and you can pin that down, but we're going to go with that. And I want these counter height. Now remember, we put one down here at counter height, so I can just use that one, create similar, and put it here. So now we have a couple of things that it's trying to hook to. We have a wall surface, the fat line, and then this ends up being the backsplash. So you can see if I connect it to the wall, will I even see that? And I'm going to get rid of all these and reopen my new section. We can actually see that, and that's a little too low for the backsplash. So let me click on this and raise it up. I'm going to put it up at 4 feet. Now you may think you want a horizontal one in a backsplash. You could, but that would actually be a different family, a horizontal family. It'd have to be created that way. So that's a custom family, unless we can find one somewhere that we can bring in. But typically that ends up being some kind of a custom family that we have to get into. So we're not going to deal with that. So back here, let's take a look at how far away we are. So let's go to our annotate. And from the inside, well, from the outside, the wall's underneath. So from the edge of this counter, I want to be within 2 feet. So there's 2 feet mark. I'm going to pull this a little bit here. Now, you may worry about back-to-back boxes. Well, this one's down low, this one's high, so it may not be an issue. And frankly, these are what I call diagrammatic, so they're not exact dimensions, and an electrician is going to take this and actually mount a box typically to a vertical stud that may be anywhere along here. So these aren't super critical. These are approximate dimensions anyway. So let's see how far we are. Let's see how far we are from here. Now we want to go 6 feet. So we're 6 feet 1 inch. So we are just barely going to make it 4 feet between them. Now, another way you can just move this a little bit is click on it and then use your arrow key down to slightly nudge it. If you hit shift arrow key, it's a bigger nudge. See that? That's pretty common with Windows type of things. So I'm going to nudge it just a hair, and then I'm going to put another one down here. And we know that these are 2 feet in and 4 feet between them, and it just fits. Now this one also is up at 4 feet. Good. So we're good there. Here's our section just to make sure things look good. Now we're going to move across the doorway over to here, to the south wall of the kitchen. Let's take a look at that. I also want to do another section. Now this is facing up this way. Well, I don't need to redraw it. I can just click on it, and there's a little arrows right here that I can use to swap this up and down. You can also rotate it if you need to. But let's do that and double click that. Now I'm looking at, I can pull this down. Now I'm looking at the south wall, and I can even see some HVAC in here. The south wall, and it looks like we can tell by the symbology, by what it looks like, we don't have labels on this stuff. This looks like a range, cabinetry. This looks like a microwave, and it probably has a vent built into it to ventilate this space. So we need to make sure we get receptacles in for those. And then we have what looks like a refrigerator over here. Now our section goes deep into this room, so we were seeing some of the receptacles beyond it. So let's pull that back in here. So there we go. Okay, so we need some above counter receptacles on either side of this range. Now, what's our distances? We need to check that. This is 3 feet. So we only need one receptacle. Let's use our above counter receptacle that we already used. Put that here. And again, it might try to stop at the thin line, which is the backsplash. Well, we're not mounting it in the backsplash. We're mounting it above the backsplash on the wall. So we want to go a little bit further so it snaps to the wall. There we go. Same with this area. Snap to the wall. So now we have those. And then we need a receptacle for the refrigerator. Some people mount that at 1'6". I like to show these up around 4 feet. I feel they're easier to get to when you pull the refrigerator out and get into it. So let's go ahead and do that. Now, this is having trouble finding the wall because looks like the refrigerator itself is clear smashed against the back wall. It would have been nice if the architect left it away. They didn't. So to get to the back wall, I'm going to have to find back wall over here and then just drag it over like that. Another thing about the NEC is it's going to require GFCI or GFI, ground fault protection, on many receptacles in the kitchen. So you'll need to follow that. Now you may want to indicate GFCIs here, or you may include those requirements in a list of notes or specifications. So in this case, I'm not going to be showing it for all of these. I'm going to let my separate written specifications remind the contractor to put GFCIs and arc fault receptacles, tamper-proof receptacles, all of those code things within some notes, not actually on the plan. Different people do it differently. Some people get very explicit about what type of receptacle this is. As you recall, we did have a GFCI receptacle available to us right here. So we could click that if we wanted to say GFCI. But you're kind of stuck with where this label ends up. I personally don't like them. If I'm going to say GFCI, I prefer to just add text that says GFCI, and I can put that where I want. Something like that. But in this case, we're going to leave it off. Now, we need to provide a receptacle in this all-electric house for this range. Now, if a range has not been picked out yet, which often it isn't while the home's being designed, we'll just put in a standard 50 amp outlet that's also 240, 2-pole like the dryer. So let's use the dryer symbol. It's already set up for 240. Create similar. And let's put that. Now, it again wants to attach to the back of that range. We want to attach to the wall. We can't get to it. So let's do it over here and then drag it in. There we go. There's our range connection. And again, it's already set up as a 240 volt 2-pole. We don't care about the load here because we're going to count for the load with a different kind of method. But we do want to label in here. So we can right click, create similar, type in range. And sometimes I like to say what size the outlet is here. So I'll do something like that, range, and then I get my leader, get that turned down and pull up the shoulder and do something like that. And then finally, I have kind of an island here. Now, instead of drawing a bunch more sections, I can repurpose these sections. Let's say, for example, I can just swap this view of this section. And now when I click it, I'm looking to the left at this island with this sink. Now, it looks like we have something underneath here. Again, as long as we have our pinned elements checked, we can hover over the architectural background, go over one of these lines and hit tab until it lights up. There it is. Now click it, dishwasher. So that's what it is. It's an under counter dishwasher. So I want to make sure that, and you can now, as I zoom in and out, it kind of is apparent. And there's the face of it. I want to get a receptacle down underneath here for this dishwasher. I don't want above the counter. I want a low one. So let's go ahead and do create similar. And looks like the dishwasher has a little gap behind it so I can actually find this wall. Otherwise, put it up here and move it. And maybe I want to move it over here to the side of the dishwasher. Again, electrician will rough it in where it makes best sense. I want to put a label on this that says that's a dishwasher. So I will go ahead and do my create similar. And maybe I'll just use something like DW for dishwasher. I don't think this wall extends above the island. I think it happens to be within the island. So let's take this section and draw right through the island. I'm going to turn it around and let's see. Yeah, see that? It only has a wall below the countertop. There's nothing here to mount anything to. So we will need receptacles on this island, but pretty much at the ends. Now there's code rules for that you'll want to check out. But in general, we pretty much need a receptacle at this end and then at this end that are mounted up high, close to the countertop, so that somebody can get a cord there and power countertop equipment. So let's go ahead and get a receptacle mounted there. And then we'll want to check the height of that. Now, what's the height of our counter? Well, we can add dimensions to this to see. So go to the dimension mark down at this level, and then let's pop it up to there, top of the counter. It's just a 3-foot counter. I think most counters end up being a little taller than that, but in this case, the architect put them down at 3 feet. So let's get the receptacle up around 2.6. So this one, 2.6, 2'6". And I want the same thing down here. Now this one is not letting me attach to the bottom of the wall. And some of this has to do with how the wall was drawn in the architect's plans. So this gets annoying with hosted families again. But let's hit tab. There it is. It's swapped down. So tab is your friend. If things don't work, hit tab until things line up where you want it. So tab right there. Now this one got put at 1'6", so we need to make sure we put that at 2.6. And again, check our section. The section is cut right through the middle of that, so we need to drag it down here so we can actually see that receptacle. And there it is. Now you may wonder, how are we going to indicate to the electrician, the installers, that these are at a different height? Well, a lot of times we'll use different symbols for that, like above counters can have some partially filled in things or have a different symbol. Again, because we're using out-of-the-box receptacles, we don't have that available to us right now, so we'll have to use a different method. One thing you can do is just type in 2'6" AFF, above finished floor. And so you'll just have to manually say that, and you can copy this text around. These here are 4 feet. So something like that, 4 feet, AF. Some method of notating that. And I may want to do that down here as well. 3 foot, 6 inches. So that's one method you can do that. You can also do it with notes. Say anything above a counter is a certain height. I can copy this note. Something like that. However you like to notate that. So it looks like our kitchen is all set up. Let's see what else we need to do in here. We have restrooms. Let's get to the master bathroom. And typically you will find receptacles above the sinks. So let's go ahead and throw those in here. Now, again, we need to figure out what height we want those. Let's move our section over to here and we'll flop it around. There we go. Let's take a look at this east interior wall. So here we have our sinks and the cabinets with looks like mirrors above them. So I like to get the receptacle just about there. So let's try one of these 4-foot receptacles. See how that's 4 feet. We will right click, create similar, and put it on this wall. Now again, to not intercept and interfere with the cabinetry, I'm going to hit the wall first and then pull it over to make sure. Again, that's how these hosted elements work. Let's check that height. That's the kitchen. So there. Now we could put this down at the 3/6 level, and that looks a little better. So we'll do the same to the other one. Let's create similar this one, get it down on this south wall, and move it over. And it's at 3/6. We're good. Now again, this would be a GFI, GFCI type receptacle. We're going to handle that with general notes. So that is that bathroom. Now we have yet another bathroom over here that we want to do the same thing. So we can actually just right click, create similar, and zoom into this, and we'll get it on the side wall, a clean place, and move it 3/6. So I'd also like to get a receptacle on the exterior of this house. So I'll put one here on the front porch area. Let's use one of these. And that would be a weatherproof and GFI type receptacle itself. And then also in the garage would be good to get some receptacles in here. Now, one thing we have to note is that this garage ends up being at a lower level. And let's just show you that with a section through the house. We'll draw a section here. Take a look. How far is that looking? Just past the wall. So let's see here. Here's our main house, and here's the garage on the right. Here's the track for the door. We can see that it steps down to this level here that we need to pull over. And it's actually at a level called grade. So our receptacles need to be in relation to grade. So how are we going to do that? Our floor plan view is based upon level 1. So we're going to have to change that. I'll show you how we can do that. And in the garage, I like to put them up at 4 feet above the floor. We do need to be above 18 inches for code reasons because we have gasoline, most likely. Even if you have electric vehicles, plan on having gasoline in here. And so we need to get those up above there. Let's do a 4-foot receptacle. So this guy is already at 4 feet. Let's take him, create similar, and I'll put a couple on this left wall because we don't know where the homeowner may put a workbench or something like that. So we'll get a couple receptacles here. Now I'll put one there. It's at 4 feet. However, it's 4 feet above level 1. We need it 4 feet above grade. So what we can do on this receptacle itself is we can change its relative level. We can change it to grade level. Now, like I said, you can't change the level of an entire view, entire floor plan, but you can change relative levels of individual families and instances. So there, now you can see it's 5/6 from grade. So it didn't move the receptacle up or down. It just changed its relative measurement. So we actually need to move now this receptacle down to 4 feet above its level called grade. And then let's continue copying these over by using create similar. Now, because this floor plan is set up for level 1, it's always going to refer them to level 1, even if I do create similar. So I have to do this exercise for each of these receptacles. Here, here, and here. Now, if I don't want to do each one individually, I can select, and now because I have pinned elements allowed, I'm accidentally selecting my linked model. So let's go ahead and turn that off. This is why you want to turn that off once in a while. Turn off these select pinned elements. Now when I click, I'm not selecting the element, and I can do my window that I'm trying to do. I'm going to window these 3, and I did pick up 3 electrical fixtures. Now I can change all of these at one time rather than individually. There's many different selection tools in Revit. One of them I did show you earlier was this whole filter idea right here, the filter. You can also right-click on an element and say, select all instances visible in the view. Now, they don't mean this window that I'm windowed in. They mean the entire view, so the entire first level floor plan. Or I can go all of them in the entire project that are this type. And then furthermore, you can even include legends if you have things in legends. So you can use these tools to help you select items. So I also want to get a receptacle outside. This ends up being, if we hover over it and click, it ends up being a condenser for an HVAC system for the air conditioning. So I'm going to go ahead and get a receptacle out here for that as well. There. And again, that one's going to be based off of grade level, 4 feet. So that should complete at least our receptacle layout. Next, we need to connect other equipment like the HVAC and plumbing. So that is why I linked in the mechanical model so that we have the locations for their equipment. We don't have electrical data available. And you may think, well, is there some way that I can actually hook up to this? Let's see what it is. This exhauster. Is there any way I can hook up to that exhaust fan? Well, we cannot get to the electrical connector of a linked model. So no, we have to put something into our model that has the proper electrical connector and electrical characteristics to actually connect it to our electrical system, our panel. So you could copy monitor this actual fan if you want. Now, sometimes mechanical equipment like that does not have the proper electrical connectors in it. The family doesn't. So my preferred method is to actually just use my own electrical connector in my model and place it on or next to the mechanical device. So for example, what we have in our preloaded families down here is a junction box with a load, is what that means. And this is, again, an out-of-the-box Revit family that you can download from their cloud. And I've already preloaded those. So they have a 120 volt, a 208 volt, 2-pole, 208 3-phase, all these different kinds of connectors. We're going to go with the 120 volt single phase. We're going to assume that we have available the actual HVAC PDFs of their design with typically a schedule or even cut sheets of their equipment so that we know what voltage these are specified at and what horsepower or full load amps they are and what kind of overcurrent protection is allowed. So we have that information. We're going to say off screen and we're going to use it. So we're going to say this is a 120 volt. And what this is just a junction box symbol. It happens to have a 3-dimensional junction box also with a height from level. We don't know exactly where to connect this, but we're just going to put it anywhere. Again, this is diagrammatic, they call it. The electricians will, in the field, figure out exactly where this will go. But we're going to put a junction box right next to it. And I'm also going to move my room tag out of the way, which is nice that I can move that. And if you click on this, you can see up top, the key is it has a power connector. And we're going to be using those in the future to connect these to our load center, our residential load center or panel. And then this is set up so it has an instance parameter for the load. Now, again, we're going to do our load calculations in a different method rather than using the load here, but I like to make the load match, at least for future reference. So we're going to say they told us this is only 100 VA exhaust fan. Because this is an instance parameter, remember, instance means only for this one junction box because it's in this box. I could reuse this junction box all over the place for my exhaust fans, but I actually want my exhaust fan to have a name associated with it, and I'm going to show you how we can use a tag that's smart that reports its name. So let me show you how we do that. When it comes to tagging this, I could do just text like I did for the range and for the laundry equipment. Or I can use the power of Revit to draw the name out of the junction box and report it so that if I happen to change the name of this junction box, the tag will change with it. And that's a key to learn, is this smart tag. So let's go up to the annotate tags. We used room tags before, but we also have what's called a tag by category. And that we know what the categories are: electrical fixtures, electrical equipment, lights, things like that are categories. So it'll tag by whatever category this is. And the default tag, because you can have different tags for the same category, the default tags are down here, loaded tags and symbols. You can see in here that here's all the categories that you can tag. Cable trays. The default tag for a cable tray, loaded tag, is called cable tray size tag. Down here under electrical fixtures, we have an electrical device panel tag. Well, that would indicate that if I put this tag on an electrical fixture, like a junction box or a receptacle, it will tell me what panel it's connected to. Maybe I want that. Maybe I want something else reported. Maybe I want the name of the equipment reported. So this is where the default is, but there can be other tags in here. As you can see, there's a circuit tag or a panel tag. And we'll get into how to load these and change these, but just to let you know that there's a lot of different tags for the same category. And so we'll just have to decide which one we want. And we can have multiple in the same project. Let's tag this and see what we get. Tag by category, hover over this, and we get a little question mark with a line. Now in this version of Revit 2025, up top is where it says whether you get a leader line or not. Previous versions may have had a box over on the left here. But if I unclick that, now I won't get a leader line. I'll just get the question mark. But let's go ahead and leave the leader line in there. Now, why are we getting a question mark? And we can move that around. We're getting a question mark because it's looking for a panel, but we don't have it assigned to a panel. I would like this tag to report the name of this device. So I make sure I have my tag selected, and then I want to change it to the electrical fixture tag standard. There. We're still getting a question mark. So it's trying to report some data out of this junction box, but what is it reporting? Well, from experience, I know that it's looking for the name of this box, and the name is reported in a type parameter down here called type mark. So if I was to put bath fan in type mark, we have to get the shoulder right. So that's what it's reporting. So if I was to change the name of this from something else, that tag would change. It works both ways. If I change the name of this bath fan to go bath fan 1, hit enter, I'm changing a type parameter. Every 4-inch square 120-1 type of this family will be a bath fan 1. So if we go down to edit type, there, it changed it to bath fan 1. Now, if I have another fan over here, let's do create similar over here at this toilet. Because I selected the name type tag, not panel tag last, that is my default now. It changed the default. So I can use tag by category again, and I get bath fan 1. Now, if I want this one to be bath fan 2, let's say I want them called two different things, and I don't need it boxed, let's change it to bath fan 2. I'm changing the type. Well, what does that mean? It means my first one I put in now is bath fan 2. So that's the type parameter issue. If I want two separate pieces of equipment with two different type parameters, I have to create two different types. So I need to create a bath fan 1 type and a bath fan 2 type. So the way I do that is I go into the edit type and I want to duplicate this, copy it. Duplicate this, and it's trying to give me a name. I'm going to call this the name I want, bath fan 1. And I want it to say bath fan 1 down here. I have the name of the type, and then I also have the name tag of this type. Now this is bath fan 1, and this one is still bath fan 2, but I don't really want to change the name of this 4-inch square box, so I'm going to also duplicate it and call it bath fan 2. Hopefully you can understand that that's the difference between types and instances. Now, it gave me an error about having the same type parameter. Well, it's the same type parameter as that 120 junction box that we put in. That shouldn't be a problem. And so the best procedure then is to have a separate type for each piece of equipment that has some kind of different characteristics, different voltage, different name. Now let's say that we find out that the bath fan has a little more load, bigger fan, more CFM, more VA. But first of all, we want to make sure that we create a new type for the laundry fan. So let's edit a type, duplicate it, and let's say laundry fan. And we want to put the same name in the type mark so that it gets tagged properly. Now we can find the tag, or we can just do a right click, create similar, and let's put the tag there, laundry fan. Now this fan, we're going to say, like I said, has a different VA, so let's go ahead and put that up to 200 VA. So now we have our 3 exhaust fans. One thing I mentioned is that these junction boxes do have a height associated with them. So let's use our section and take a look at that. We want to keep track of the 3D aspect of our model as well. May not be so important for some projects, but it's a good practice to get used to it so that if the architect wants to bring your model into theirs and do some basic interference or clash detection, we don't have a junction box sitting on the floor. Now, we don't know exactly where it's going to be up here. This is just diagrammatic, but let's at least get it above the ceiling, right? So there. Now, I can actually just take this from this view and just move it up. And it still is in the same horizontally. I can nudge it over, but I'm not trying to get exact. I just want to get a relative idea of where that is. At least it's there. So on the other one also, let's see what height that ended up at. It ended up at about 8 feet. So let's just round that up to 8 feet. And I'll do the same for this fan. Get that box up at 8 feet. And like you noticed here too, it's a horizontal box. It may be a vertical box in some cases. Again, in our situation here, we're just getting close and we're dealing with out-of-the-box families. So we have to live with that limitation as well. Let's check the laundry. And it looks like it could go up to 8 feet. It's right on the ceiling, which is fine. Okay. Now, other equipment we have out here in the garage. So hover over that. That's the mechanical model. And we haven't pinned the mechanical model, by the way. It's probably a good idea to pin that. And then we have to make sure we can select pinned elements to get to it. Let's tab over this a couple times. And that's a furnace. And we're going to say in this project that we're going all electric furnace. So it will be, let's say it's something like a 20 kilowatt connection. We're going to use our junction box again. Now we don't need the one up at 8 feet, but we can lower it, create similar. And we'll say that its connection's back here. And let's get it down. Again, now we're in the garage with a different grade level, with a different floor level. So let's go relative to grade and let's put this box up at 4 feet. And we're actually going to edit it and call it something else. We're going to call this electric furnace. Let's say that we found out that this is a 240 volt furnace because it's such a high load. So let's change the voltage and characteristics of this type. That's another reason we need a separate type, because we have different type parameters. 2, and load classification is not going to matter for residential. So now we have a 240 volt. I mean, the actual load is an instance parameter for this out of the box family. So we're going to call it 20,000 VA. And then we have an electric water heater as well. So let's do create similar for the water heater. It's a different type. Duplicate electric water heater. It's also 240 volt, and it is going to be, now we need to make sure that we also put that type parameter down here under electrical furnace, which I did not. And let's get some tags. Electrical furnace, electric water heater. This guy is going to be 5 kW. In this garage, we found out that the homeowner is going to have an electric car charging point placed on the wall. So we need to get a connection for that. Now, it could be a special receptacle. A lot of times people will just plug into a 50 amp 240 volt outlet. So we will go that way. Well, where do we have that kind of outlet? Well, we have one for the dryer and we have one for the range. So let's take the range special receptacle, put it here. We had just called this a standard high voltage receptacle, and we just gave it some voltage here. We didn't need to give it the load again because it's residential. Now, we could do the same thing here where we can duplicate it and call this EV charging. I'm not calling it charger just because technically it's not a charger on the wall. The charger's in the vehicle and the charging point is on the wall, but that's, you know, that's getting picky. Electrical charging 240. And again, I'm not going to worry about its load in this case. But because I made it a separate type, I can tag it with its name. So that's another reason to make different types for these things. And let's see what height it's at. Let's move it to grade and 4 feet. Now, also one thing to note about this different floor level is we can see these devices because they are still within our view range. Remember the view range for this floor plan. We have the bottom at level 1. Just as an example, if I was to put a receptacle below level 1, so way down, let's say we want this down at 1 foot above grade itself. Apply. It disappears. I can't see that receptacle, even though it's there, because of the view range. Again, now view range is very important in Revit. It'll cause a lot of visibility issues if you don't really pay attention to it. So how could I allow this receptacle to show up in this plan? Well, I can lower my view range to below the floor a couple different ways. I can change the bottom of my view range to actually level below. Now I get an error because the view depth plane is set above the bottom. Now the view depth we haven't talked about much, but the view depth is down here below the bottom. For example, if you're going to show underground conduits or other kind of underground or underfloor, you can set this below the floor level. It will show it as a different line type, might be dashed or might be shaded. So we need to also set this level at the same or below. That allows our receptacle to show up because we changed the actual bottom of our view. Now, the only thing of changing the bottom of the view for the entire plan is that if I had anything else in the crawl space or things like that, it would show up now because I dropped my level down to grade. So if you don't want to change the entire view to a lower level, there's one little kind of an advanced feature I feel like I need to show you, because even in a residential simple basic project, this can easily come to play. So the proper way to do this is go back to our view range. 90% of this view needs to be at the associated level for the bottom. And we're going to handle this differently with what's called a plan region. Up to view. Under plan views, and this is where you would go if you're going to create a whole new plan. And we will end up doing that eventually for a site plan. But here, this is where you would make a floor plan. When we get to lighting, we're going to make ceiling plans. But this is called a plan region. A plan region creates a region, like a sub area, within a view. As you can see in this little picture cartoon below, they're drawing that purple box around a portion of the wall, and then you can set a different view range within that area to see things differently just for that area. So, for example, in their case, they had some high windows. You couldn't see them with the normal view range. Maybe the cut plane wasn't high enough, but I don't want the entire view to have a high cut plane. So you can encircle an area, small area, and change the plan region just for that. So it's a way to have a smaller area with a different view range. Let's do that. So view, plan views, plan region. We're going to make the garage, and I'm going to start right at the grid line here, and just make, and instead of using a line, I can select a rectangle tool. I'm going to make it a little bit bigger than the wall. I'm going to encircle this garage, and I want to go outside too in case I have things outside. There, I've made a plan region, that thing, and I'm still I'm in sketch mode. The purple lines and the check mark means I'm just sketching this, because I can continue to pull lines around and change the shape before I accept it. And then as part of this, I can set the view range of this region separately. So this is the one where I want to make the bottom actually at the level below. The cut plane is still based on our level, and I'm going to move it down to 3 feet above level 1 or 2.5. And the top, I'm fine with the roof, and the view depth, I have to go with level below. So I pretty much did what I was doing before, but I'm only doing it for this purple rectangle. And then you won't notice it until I say accept. Now you can see the receptacle, because this box now has a different view range. So that's how you can deal with that. And you can do it with just a section of wall to see a window. You can do it with one sunken living room. There's many uses for this. So that lets me see things differently. Now I notice I need to connect my condensing unit outside. I'm going to start with my furnace. Create similar. My furnace connection is back here, let's say. And what's its height? Let's get to grade level. 4 feet above grade level. That's good. Again, I don't worry about the load so much, but let's say it's only going to be a 10 kW load. And let's duplicate this and call this condensing unit, 240 volt, 2 pole. And again, I forgot my type parameter down here, the type mark, so that my tag works. And let's use my little guy up here, tag by category, condensing unit, and I can use the little move command to move that around. So there we have a completed power layout. The next step is to get all of this connected up to a panel. And by the way, we need to throw a panel or a load center into this project. So we will deal with adding that and circuiting next. So now it's time to add a panel, or in this case, a residential load center to this project, so that we can get all of this stuff circuited to it and develop a panel schedule that will show the load names and the circuit breaker sizes. So like I mentioned before, this project template has already in it the families you need. So let's go down to the electrical equipment this time. A panel or load center is an electrical equipment, not a fixture. So open electrical equipment. We can see transformers and panel boards. Now, these are 3-phase 208 and 480 volt panel boards that we'd use in a commercial installation. In our case, we were going with a single-phase panel. Now, don't let the 120 volt scare you. This is, for some reason, the way that Revit names this out-of-the-box single-phase panel, and we're going to fix it. So we have an MCB recessed or a surface. There's 2 different families for recessed or surface. In this case, we're going to put it in the garage. Let's say we're going to make it recessed. We're going to make it look good in there. So let's open this up, and we have 3 different amp ratings attached to these. So that means we have 3 different types. Now, in reality, we'll see that the amp rating is not a type parameter, so it's kind of a misnomer, but let's just at least pull the 225 amp to start with. And we pull out here, and we are trying to put it in our garage. We're going to throw this in the garage. Now, as we can see, it's not letting us put it out in the middle of the garage. Again, this is a face-based or a hosted family. So it's looking in this case for a wall or grid line. So there, and you can see it's putting a box recessed into that wall. So I'm going to put this panel down here towards the front of the garage. Now the reason I'm doing that is because our meter is going to be on the outside of the house. And we're going to say that, like some utilities require, that meter has to be within 5 feet of the front of the building. Of course, utilities vary all over the country, but around here, that's what they want to see. So I'm going to also put my panel just on the inside of that meter in the garage. So I'm going to put it up here, and it's going to be recessed in the wall about there. So click it. There we go. Now, out of the box panel just is a box. There's nothing fancy to its symbology. But let's click on that panel, and here we go, single phase panel, 120 volt. Now, I can't get to voltages or phases or poles in here. So that's a type parameter. So let's go to edit type. And I don't want it to be called 120 volt. This can be a 12240 volt panel. So we're going to make a duplicate type, and I'm going to call this a 120-240 volt single phase panel. Or, we also call it split phase, because it's a single phase of 240 volt that they split right in the middle. They throw the neutral right in the center of that to give us 120 volt between hot and neutral on either side. Again, the panel voltage, the maximum voltage of this panel line to line is 240 volt, and the number of poles is 2. There's 2 hots. And there's no load classification anyway with a panel. So the dimensions of it are type parameters. So that's probably why they have 100 amp and 200 amp separate, because they'll be different sizes, and it depends on how many circuits you have. This out-of-the-box family happens to have some smarts in it that will change the height of it based upon how many circuits you have. Now, we can't enter how many circuits are in here. It's not a type parameter. Let's go ahead and accept this. That is all here. There's a lot of instance parameters in a panel. All the loads are based on this one panel instance. The elevation is based on this. Now, 4 feet, well, 4 feet from what? The bottom, middle, top? We'll have to look at that. But down here under electrical circuiting is where we get to some more electrical information. The maximum number of single pole breakers. Right now it's set up as a 12 circuit panel. That's a small panel. For a home nowadays with all the electrical connections, I would go with the 42 circuit. So let's go 42. And that's 42 full-size circuits. And then the mains and the main circuit breaker, we're going to leave the mains at 225 amp. But the main circuit breaker, I'm just going to have a 200 amp circuit breaker. And then the distribution system is already picked out at 12240 single-phase 3 wire. It is automatically set up to match my voltage that I said this panel is. There's a way that we can add different distribution systems. If you're in a commercial world, you may need a 120-208 three-phase system, or 277-480 volt three-phase system. You may need a medium voltage, or maybe you need some low voltage 12 volts. That can all be added to your model if we need it. But this is all we need for now. So we're good there. Now, this is all set up to receive both 120 volt and 240 volt two-pole connections. This all has to be set up this way, or we can't connect our receptacles and junction boxes to it. So that's a key in Revit too. These things have to match, or it won't let you do it. And a lot of people run into issues with things not connecting, and that's the basics of it. So we can start here in the garage if we want. And just to let you know that the way Revit circuits is it assigns a circuit automatically, the next available circuit. I cannot say, connect these receptacles to circuit 1. Connect them to circuit 10. I cannot specify that. The way Revit's built, it tells you where it goes, and we can easily move it around after, but that's the way they set it up. So I'm going to connect the receptacles, standard receptacles in this garage to my panel. So I can select them all, and the way you can select more than one is to hold down the control key and then select another one. You can see the little plus sign, which means I'm adding to my selection. You can select all 5 of these, and then let go of the control key. And then I can power all of them up, hitting the power button. You see some dashed lines, which can indicate wiring. It's not there yet. They're just dashed to give us an idea. That's where wiring would be shown if we wanted to. But now we get the selection to pick a panel. Since this is our first time to select a panel, it says none. So we can hit the drop down and see what panels are available. Well, you will only see panels that match the electrical characteristics of these receptacles. Like I said, they're set up at 120, so it can connect to our 12240 volt split phase panel. So click on that. Now they are automatically connected just by doing that. If you look over at the right, circuit number 1, and the panel's name is this long name, 12240 split phase. They are now connected. That's all I have to do. Now, if I do want to show arcs between them for wiring and a home run, I can hit the arc wire or chamfer wire buttons. On previous residential projects, I did it that way because that's how we do it most of the time commercially. A lot of people, though, will just put a circuit number next to the device rather than all the arcs. So you can do either one. In this project, I'm going to do it the simpler way with just circuit numbers. So I'm not going to hit the arc wire button. You can tell here what I have selected is a circuit, not a device. not a panel. I have a circuit selected right now. I can edit that circuit. I can add more devices to it. So let's say I want to add this outdoor receptacle to this circuit. I can hit Edit Circuit, and now I'm in the Edit Circuit phase. It defaults, you can see the blue, it defaults to Add to Circuit, the plus sign. Or I can click it just to make sure I'm adding to the circuit. What am I adding? Well, I want to add a receptacle. The ones that are already on the circuit are dark. The ones that are not on the circuit are light. So this means that I can select that receptacle and add it. Now, one thing I'll note is that I can only select electrical pieces. I can't select even room names, which is kind of handy because when things get busy, it's hard to sometimes to get narrowed into that. So that's handy. Let me just click on that. Now I've added it. It darkens up. I've added it to the circuit when I hit finish. Now, why am I worrying about adding all these to circuits? Well, this is one of the great powers and advantages of Revit, is that I can add things to the circuit. It will automatically tally up the load in like a commercial environment when you add up loads one by one. Residentially, it's not as important because we're not adding loads that way. We're going to do it based on a square footage method and things like that. But we still want them connected so that we can indicate which circuit they're attached to. So we want this all interconnected like that for a number of reasons. Now, I don't see anything different here in the plan after doing all of that. What's the big deal? First of all, I'd like to give my panel a name. Right now, it's just called this. Well, I don't have to go into the type parameters and do a separate type for the name here. Panels are different. In panels, the name is already an instance parameter. And if you go down here to General, Panel Name. So it's an instance parameter to give it a name. And I can just call this, it's the only panel in the house. And how many people have a name on their panel board or their load center in their home? None that I know of. But for circuiting reasons, we're going to give it a name. And I'm going to use capital. We're just going to call it P1. Apply. So it's called panel P1. Now I want that name to be reflected. Again, I want to use a smart tag. Get in the habit of using a smart tag versus just dumb text. So let's go to annotate. And I can go to tag by category or again up top. And it's going to take the default panel or equipment tag. Let's see what that tells us. There. The default happens to be the panel name. And I can have a leader on it, or sometimes on panels I don't want the leader. Well, how do I get rid of it? I click on it, and then I go over here and uncheck the leader for this instance of this tag. And now I can just put that in front. It doesn't say panel in front of it or anything fancy. It just says P1. When you get more advanced, we can get in here and edit this tag to maybe have an underline or maybe quotes. Maybe it says panel. We can do some customization to it, but again, that's a more advanced feature that we're not going to get into in this beginner lesson. I want to also label these receptacles with what circuit. Now we know what panel, there's only one panel, but let's get the circuit number. Now how can I do that? Let's see what happens if I tag a receptacle. Tag. Okay, we get a question mark. Well, what's that question mark? Let's see what this tag is doing. And a lot of this depends on how it was named. This one just says electrical fixture tag. Well, that doesn't tell us what it's tagging. You know, what data is it pulling out of this receptacle? Well, we can't tell by the name. Well, we have others, like we saw before. We have a panel tag and a circuit tag for electrical devices or fixtures. So let's try this circuit tag. There, circuit 1. And again, I don't want the leader, so I'm going to get rid of that. Now, I can put the one right next to that. So now let's just right-click this and do create similar and go around to all of my receptacles to add a 1. Now, it's putting a leader in because I have leader checked. So I can just uncheck leader here as I'm putting it in is where you check it, not here. There, and it's way over there. This one, the tag ends up being way off base. So now I can just put a 1 next to each of these receptacles. I could have done it with text, but the joy of this, I will show you, is if I want to change the circuit, it is very, very simple. Okay, those are all in circuit 1. Now let's look at a panel schedule, a directory of these circuits. There's a few ways we can do it. We can go up to Analyze and say Panel Schedules, and create panel schedules, and it'll give us a list of our panels that are in the project. And if it's checked, it'll make a schedule. That's one way. It's kind of a hard way to get to. Think about all that. You can just click on the panel, select it, and up here you get a choice to create a panel schedule. Let's do that drop down. Now we can use the default template or choose a template. More templates. We can have different templates for different kinds of panels. Let's say choose a template so we have our list. In this project template, we have branch panel main circuit breaker, which is really intended for commercial use. And then we have one that is a custom one I created called Loadcenter main circuit breaker, and that's the default. Let's choose Loadcenter with a main circuit breaker, say OK. It pops open a panel schedule. Now what's in this panel schedule? It has the name. And again, it's already been set up as a Loadcenter. This is a custom template. Tells you the location based on the room name automatically. There's no supply. We don't have a supply. We haven't fed this panel anywhere. It's a recessed. That's already included. Some of these things are just blank. We don't need them. We can add them later. Some of these things are just text. But it does report the voltage. It's single phase, 3-wire. We can put in an AIC rating when we know that. A mains type. This one ends up being a main circuit breaker type. And that changes all of these. And then I have my 225 amp mains with a 200 amp main circuit breaker. Now, down here we get circuit descriptions. Odds on the left, evens down the right. And we have lots of room for a circuit description. We have a trip rating for the breaker, number of poles. Now this center area that's shaded and has some numbers in it, this would normally be the area where the loads are added up and reported per phase, per circuit for commercial loads. This is how we calculate the loads in a commercial panel. For a residence, we don't calculate it that way. We are going to be using a square footage method and a method that's in the NEC that we will get to later in this lesson. So that's why this is scrunched down. You can't really read it. Revit won't let you delete it for some odd reason. All we can do is scrunch it down to make it illegible. Again, Revit was primarily made for commercial buildings. And then down here would be reporting what kinds of loads and all that. Again, it's blank for this simple circuiting directory. This description just says receptacle. This is where we can type in a little more description. We can say something like garage receptacles. And this is what would be put on a label in that load center so that the occupant knows what circuit does what. Living room receptacles, kitchen receptacles, etc. Now we can get to that description also within our plan. If I click on this, I don't see the circuit, I see the fixture. If I want to get back to the actual circuit, I have to hover over it and hit tab until I see the dashed lines appear. And it says electrical circuits. Click on that. Now I have selected the electrical circuit and I can edit the circuit. I can add things to it, take things off of it. And then I can also change the load name. As you can see, it says garage receptacles. That's what I just typed in to that load description. You can change it here as well. In fact, I find it's best practice to type it in here as I'm creating my circuit and also change the rating of the breaker as I'm typing this in. Now, in residential, we know that most breakers are just a 15 amp breaker. So I will change this down to a 15. And then I can escape out of that. Now that changed it. If I hit P1 up here on my panel, it changed to 15 amps. So you can see they report back and forth. That's a very powerful feature in Revit, is how that it's database driven so that you change things in one place and it typically changes it everywhere. So we don't have to keep a separate Excel spreadsheet for the panel schedule. And in commercial work, we don't have to add up receptacles and add up lights and watts. It does it all for us. Now, the other thing I was telling you about, the smart tag on this receptacle, right now we're circuit 1. If I want to move this around, this is where I do it. I have to change circuits in this panel schedule view itself, not on the plan. So I take this, you can see here I can move it down, down, down. I can move it across to the other side, just back and forth. Or I can move it up, or I can just move it too. I just want to take it and move it anywhere the green shows up. So I want to put this as circuit 41. Now I'll go back to the floor plan view. Look at that. That is the power of Revit's circuiting, and that's why we do this. I can easily move things. I can even change. If I had multiple panels, I could change it from panel 1, P1 to P2. It would all happen behind the scenes. So there you go. So I'm going to go ahead and put this back to circuit 1. Simply as move 2. There it is. Back to circuit 1. Now we'll just go through the entire house and start connecting receptacles and loads to circuits. I'm going to put my furnace in, click on it. It's already set up for my 240 volt connection, so that panel should pop up. Now see it changed the name to P1, not that long 12240 volt name. P1's the last panel I used that meets the criteria of this connection, so it pops up automatically. It's automatically going to circuit it to circuits 3 and 5 because, again, this is a 2-pole 240 volt receptacle. So I'm good with that. And I don't have to accept it or anything. It just did it automatically. I can just escape out of here. Now I want to make sure that I put a load name in here. Let's call this electric furnace. So the breaker for this, we found out from the manufacturer, the maximum overcurrent protection is a 100 amp breaker. Now, this is telling us that the power exceeds 80% of the defined breaker. Well, sometimes mechanical equipment is set up that way so that it's above that 80% mark. That 20,000 VA may be like a minimum circuit amps versus a full load amps. So we're okay here because that's what the manufacturer told us. Now the electric water heater, we also want to connect. So hit power, goes to P1. It hooked up to 7 and 9. And we want to call this electric water heater. And the rating for this is a 30 amp breaker. Apply. And let's go back to our panel schedule and see how these are all showing up. Now I'd like to move some of these 2-pole breakers over to the other side. And I want to leave the top 2 for a generator connection. If you've ever done a generator connection for a home, you'll know that there's typically a metal plate that slides up and down to interlock the main circuit breaker with the generator feed. So I'm going to leave that available. Now, how can I leave this available so it doesn't get used up for the generator? What I'm going to do is put in a spare circuit breaker. Now, I can do spares by just clicking on there and go up top, and I can hit assign spare. I can put a space also, and that reserves circuits so they can't be utilized for connections. So let's say assign spare, and I want it to be a 2-pole spare. So I can just type here 2. And it will expand it. I've got this set up so that when it has 2-pole breakers, you can see that line between the circuits is gone. I have it set up that way. And then I can even change the name. Future generator connection. There, I've reserved that. And I want to make this a 30 amp breaker. So there, we have a 30 amp spare breaker for the future generator. But then I want to move the furnace over here like that. And move the water heater, move to over here like that. And let's get those circuits reported on our floor plan. Right click and do a create similar. And let's get 6 and 8 on there. And I'm just going to put it in here. And that's a 1012. I'll put it right here. So we have things all circuited. Let's continue on into the laundry room. Now the dryer is also a 240 volt connection. Again, let's go up to power. I want to call this dryer, and I want to make that my 30 amp connection. Apply it. And then I'm going to tag it. Right click on the tag. You can see how quickly this goes once it's set up. The washers on the laundry circuit. Now I can have both of these on the laundry circuit. So I'm going to hold control down and pick this as well. I have those both selected. They turned blue. Let's go to power. P1, it assigns it to the next breaker. And again, I'll go on the panel schedule and move things around as I like. This one's called the laundry, and it has to be on a 20 amp breaker per the code. So I'll leave that there. And escape out. Let's go ahead and tag these as well. Tag, circuit 7. And that's circuit 7. I'll come back to the exhaust fans later because I want to add some controls for those as well. Let's jump into the master bathroom, and we just have a couple receptacles here. Now, code rules say that we have to have separate circuit for bathrooms. We can have multiple bathrooms on the circuit, but you'll get the blow dryers and the curling irons and the hair straighteners and all the appliances. So I'm a believer in circuiting each receptacle in the restroom as its own 20 amp circuit. In fact, I've had to bring in a separate 20 amp receptacle and circuit into my own personal restroom. So here we go. Power that up. Master bath receptacle, and it's a full 20 amp. Apply. And let's get the circuit number on that. Same with this one. Power. MAS. Now you can see it pops up. If you start typing in, it has an auto fill for you. So I can just click on that master bath 20 amp, and that will give you a little bit of a shortcut. Create similar. Now let's get to the master bedroom. I'm fine with all of these being on a single circuit. I like each bedroom on its own circuit. So this time I'm just going to select one and circuit it. So master bedroom receptacles. And it's going to be a 15 amp. Now I want to add the rest of these. So now I'm going to use the edit circuit method where I add them by selecting them in circuiting mode and then finish. Now they're all added. Now I can simply right click and start tagging. Now there is a shortcut where I could just hit annotate tag all like I did with room names. I can say electrical fixture tags. Now it put a bunch of question marks everywhere. Now which one goes to which? Because these are set up where they're far away, if I click on that, I don't know which receptacle this applies to. So I find that tagging all does not work well in this situation. So let's undo that. And you can use Control Z also to undo. There we go. So I prefer just to manually go through. And I like to be in control of where stuff lands. There we go. Now the hall receptacle, it can be on any circuit that I want. I typically like to throw it onto a bedroom circuit, so I'm also going to put this in the master bath circuit. So how do I get to that circuit? Hover over it, hit tab, there we go, click on it. Now I'm in circuiting mode, so I can hit edit circuit. I'm in add to circuit, click the receptacle, finish circuiting. It's circuited, get it tagged. So you can see once you do this a few times, it starts to become second nature. Now, just as an example, what if I want to remove this receptacle from that circuit? Let's say I want to put it on its own circuit. Well, again, I can just hover over this and get into the circuiting. I can say edit circuit, and now I can say remove from circuit. Hit remove from circuit, click on this device, it changes it back to shaded, and then there's no circuiting information. So it goes back to a question mark. And I can add this receptacle to its own circuit, or I can include it to some other circuit. So that's how you add and remove. So let's go ahead and put it back on. Edit circuit, add. Voila. Now, when we get to the kitchen, again, if you review the NEC rules, you will see that there's specific circuiting requirements. In general, we're required to have 2 small appliance branch circuits that serve the above counter spaces and the dining area. A minimum of 2. Of course, that makes sure that we have enough power in our kitchen for all these electrical appliances. I personally like to keep my main 2 in the kitchen and then add circuiting for the dining as well. Depends on your budget, of course. If someone's doing a very budget-conscious house, you can combine things down to the code minimum. You live with the consequences, but the way I'm going to do it is apply the 2 circuits in the kitchen for the above counter. I also put my microwave on its own circuit, typically because it's built in. I even put the refrigerator on its own circuit. Some refrigerators can get pretty large in load. So let's go ahead and do that. So the above counter receptacles, I've got 1, 2, 3, 4, and I have island receptacles 5, 6. So I would really like to divide those so that half are on one circuit and half are on the other circuit. So I have some diversity in circuits if I'm setting crock pots or whatever we put on the counters here, coffee makers, espresso makers. These aren't both on the same circuit. So what I'm going to do is pick this one, circuit it. You'll see that I like to circuit one first and add the rest. So kitchen, circuit, A, the 20 amp circuit. Let's edit the circuit and add additional. I don't want this one. I want this one. And I want this one. So those three are on this circuit. And let's go ahead and tag those so I can keep track of what's been circuited. Circuit. Okay, now let's do the other circuit. This guy. Power. Kitchen. Circuit A. And then I'm going to change that to a B. 20 amp. That's good. Add to my circuit. Let's see, that one's selected, so I need to select that one. And not this one, but this one. And then tag. Now, if I was creating or editing this tag, I would make it a little closer to the device rather than way out here. But again, we're going to live with the way it is out of the box. There we go. Now I need to connect my refrigerator. And I could even say that this is the fridge. Now I can do a smart tag here if I want. A smart tag for the name fridge. Now it's less likely that I'm going to be changing the name of this. But in a commercial setting, this fridge would have a different load. So I would definitely keep this different. So I'm just going to do it as good practice. I'm going to call this a refrigerator as the type. I'm making a new type. And in commercial world, I would put it maybe up around 1500, 1200. So like I say, in commercial, you're more worried about these loads than we are in residential. And I'm just going to call it fridge for a shortcut for its tag. Now I'm looking for a tag that's not the circuit, but it actually reports what is this. Similar to what I did down here with the furnace. I have two different tags on this furnace. And it's the same piece of equipment. It's the same category. How can I get to two different tags? Well, what I can do is I can right-click on the tag that I want to duplicate, and it will do that for me. So if I right-click on the name, then that's the tag that it will use for this. See how it says fridge? Now, I don't have a leader. I can add my leader over here and move things around. So that tags the name. Now, if I want to hook this up to a circuit and then tag it, I will use the other tag. So you can see you can have many different tags for the same piece of equipment for the same category. Let's go refrigerator, 20 amp circuit, escape out of there, and let's tag it with the circuit tag this time. There we go. So it has two different tags. We could get fancy and have a mounting height tag as well. We don't have one made for this, but that's a custom tag you can make too. So they could report. And whenever you can, it's best to report the data from the family rather than just text. So we're going to keep that in mind. Now, one connection I realized I did not get in here is my microwave connection. So let's go ahead and put that one in now. So I'm going to duplicate this receptacle. And again, I'm having trouble finding that wall. So let's hit tab. There it is. And I want to mount this up at like 6 feet. We can check the elevation, swap it, and see what we get. So this is up at 6 feet. Now, a lot of times we'll find this receptacle up in this cabinet above, and then the cord comes through a hole. So I'm going to just do that here. Again, the electricians that install this will rough it in exactly where it needs to go based upon cabinet shop drawings and things like that. But we want to give them an idea. How is 7 feet? Is that too high? Yeah, let's go 6'6". 6'6". There we go. That's a little more representative of where it may end up being. And this is microwave. I'm going to add yet another type, duplicate. And again, this is good practice for things like commercial work. I'm just going to say micro for the tag. And so now what I'm tagging is this tag. And let's go ahead and show how we can right click, create similar, and let's go ahead and turn leader on as we're installing it right there. And we need to get it circuited, and sometimes it's hard to just get to that. See, I lighten up the tag, and I want to light this up. There we go. And let's go to power it up. This is going to be the microwave. 20 amp circuit. Escape, and let's get the circuit tag. No leader. And now we can connect up the dishwasher to its own circuit as well. Dishwasher, 20 amp circuit, we're good there. And let's tag it. Now we have a mixture of text tags and smart tags. We can go change these if you want, but I just want to show you both methods so you can determine which one works best for you in your situation. Now I mentioned the dining room could be tied into the kitchen or be its own circuit. So I will create the dining room as its own circuit. I'll just go ahead and control select each of those and add them to a circuit. Dining receptacles. And let's go ahead and tag all these. You can see it's just repetition. And as you do it, you get faster and more confident. We're a little over halfway done with circuiting this entire power plant. One thing I noticed down here in the garage area is we didn't connect this condensing unit. Let me go ahead and connect that now. And it took up two circuits, 2729 to P1. And just one thing too under P1, it's connecting it by default to a circuit breaker in P1. Now there's some instances, especially when you get into commercial world, that we may need to disconnect it to a feed-through lug. So there's other methods of connecting loads to panels. Or let's say I'm connecting a panel to another panel. You establish an entire logical connection system amongst your entire electrical distribution system. So this is a simple example with a single panel, but you can see where it can go from there. So let's go ahead and get back into the circuit by hovering over it, hitting tab, clicking on it. Load name is condensing unit. So we'll say that the HVAC guys told us that we need a 60 amp breaker on this. So we'll do that. So then we'll get that circuit tagged. So here's the tag, create similar. And there we go. So another piece here is this EV charging point, which is a 50 amp feed. So power. And it's 50. And let's go ahead and apply circuit tag to that. Now, if you're familiar with electrical, you may know that these will take a larger wire than 14 gauge or 12 gauge. So you can indicate that on your plan, or perhaps you would indicate that on the panel schedule, or maybe you'll even have some kind of a note that would indicate what that would be. Now, a lot of times in this level of wiring, the electrician will just do that on their own as they circuit things up. And as they see the panel schedule, they will see these breaker sizes and provide proper, wiring size for that. I'm going to go ahead and move these two pole loads back, save it, of course, move it over here. Again, you can arrange these however you like. Let's move this up here. Again, move these around however you like. Also, one thing I noticed in the garage, typically there's a garage door opener that may be attached in the ceiling. So how do we add a ceiling receptacle? These out-of-the-box receptacles are made to attach to a wall. We don't have any wall up here. So in my normal commercial work, I have a custom family that's not hosted. So it's a free-floating receptacle that I can put anywhere. We don't have that here. So what we will do is we will just use the junction box symbol because it's free floating. And we'll just say it's the garage door opener connection. And then the electricians will just have to realize that that may be a receptacle. That's one way to do it. Another way we can do it is we could fake in a piece of wall that's here and then hide it. Now it looks kind of weird in 3D, so I don't do that. I'm just going to use the junction box. So let's just use, it's 120 volts, so I'll use my fan. I'll put it up here. And I'm going to treat it like an equipment connection, duplicate it, and say garage opener. Could be garage door opener. Garage door opener. It's going to be maybe taller than 8 feet. We can look at the section, but we can tag it with its name. Leader. And let's connect it to this circuit. So hover over, select, edit circuit, click on the junction box, we're done. And then that is now circuited to circuit 1. And I don't need a leader, so we can get rid of it over here. Let's look at that section just because we're trying to pay attention to the third dimension on this project. Can't tell, but if you hover over that and click it, you'll see that it's a room. And so that's the ceiling line, is that roof line. So we want to get this above 11.6, and it's also above the grade. And let's go 11.6 and see where that ends up. To the bottom of the box. There we go. So that could be a recessed receptacle up in that ceiling. Now, what happened? We can't see it. Well, guess what? This is a view range issue still. Let's check the view range. Now, remember, we have a plan region, so it's not the standard view range of the main view. It's the view range of the plan region that we need to deal with. So let's look at that view range again. Our top limit is the roof. Our receptacle is above the roof. So now we need to be above the roof. It won't let us add an offset above that roof, so we may have to go with unlimited. And there we go. Now we can see above the roof. So again, the almighty view range is very important. Let's go finish the rest of this house. We're going to put the rest of the great room on a circuit, including the hall. So let's go power. Great room, receptacles, and it's just a 15 amp. We're being economical here. Again, we want that hall, and we're going to put that exterior receptacle on that same circuit. Finish and tag it as we go so we can keep track. And I don't want the leader. So on future ones, I'm going to turn off the leader here as I install it. But circuiting is a great way to keep track of what you've already done. You know, cover your, mark your tracks as you go. Will also help you realize if you forgot any. And we have a couple bedrooms to do, so we will do those separately. Power, edit circuit, bedroom, receptacle, bedroom. Let's see, bedroom 1, receptacle. 15. The last bedroom. 4 receptacles, 15. See, if you do it all right here, then you don't have to go into the panel and do it. Saves you a step. Edit circuit. It's also nice to do this from the plan view to remind yourself what that circuit actually serves. Right click, create similar. Let's go through and now you can see what I did is I accidentally tagged something else. What is that? A wall tag. Well, I can actually tag the architect's walls, which I don't want to do, but you may find yourself accidentally tagging the wrong thing and just get rid of it. I can tag many things, walls, doors, windows. So I just want to make sure I tag my electrical stuff. So again, we're going to connect up this receptacle in the bathroom to its own circuit for all the restroom tools that we use. 20 amp for that. And there's no other receptacles, so I can just escape and create similar. 29. So there you have it. The main connections are done. We still have some exhaust fans to deal with, which we will deal with now. So for this laundry fan, many times the control of that fan will be done with a separate switch on the wall. Now, out of the box, Revit doesn't actually give us a switch that's not in the lighting controls category or lighting devices. So now we have an issue with visibility. If I turn on the lighting devices, which is switches, let's go down and look at lighting devices, which includes light switches, then every light switch for the building, when I add those to my lighting plan, will show up in my power plan, and I don't want that. How can I isolate just the laundry fan switch and not see all the rest? Well, one way to do it is to customize a switch family to be a different category. By default, it's a lighting device category. I can also make one called an electrical fixture category, and that's typically how I would do that. But that's family editing, which we're avoiding in this lesson. Another way is I could just draw in text that represents a switch symbol that only shows up in this plan. I could also use what's called filters to filter out every other switch other than the one I want. So there's a few different ways you can tackle this. What I will do in this situation is just do the symbol. Now, the only problem with that is it won't be a 3D modeled element in my model. If I was to look at the wall, I won't see the two switches on the wall, one for the lights, one for the fan. So, you have to weigh the options there. But in this case, I'm not so worried about that. So what I will do is I'm just going to use an S for a switch. And I can rotate that with this little guy here. And I'll put that down here. So that's my shortcut method in this situation for my laundry fan, unless you get more complicated. But having said that, let's go ahead now and connect the laundry fan. I can connect it to this laundry circuit. I don't need a separate circuit. So let's go ahead and do that. Let's just hit Tab, Edit Circuit, connect there, finish connecting. And again, let's go ahead and tag it. And the same with the toilet fan. Some people may connect these to the lighting circuit and have it powered with the lights. So in this case, I'll do that. I'm not going to circuit it yet. I'll wait till I do my lighting. And then I'm going to say that it's controlled by the lighting circuit. So what I will do is just add a detail line arc. There's a number of different ways to draw an arc. This arc here is start, end, radius arc. So that means I select the start at the J-box. The end is out here. And the radius I get to choose. I'll choose that. And I'll say something like 2 lights. Simple as that. And that will indicate that this actually gets controlled by the lights and the light switch. And I just have to remember to circuit this to my lighting circuit. Same thing with this bath fan. I'm going to do the same thing. Let's just arc it. And say 2 lights. You may have a more sophisticated fan. It may have an occupancy sensor or something like that. It may be on a timer. Anyway, you work with your HVAC designers to decide which way that gets controlled. And there you have it. We've got the power plan complete. Now we're going to work on the lighting plan for this house. So we have a separate plan for lighting. If you look under here under electrical, lighting, ceiling plan, lighting. Now, these others are called floor plans, and this one's called a ceiling plan. Well, why is that? What's the difference? Well, it's standard practice in building drawings that at least the architect will create a ceiling plan, often called a reflected ceiling plan. And all that means is it's as if the ceiling is reflected onto the floor. So that's why those are called ceiling plans. But also in Revit, a ceiling plan is built differently, behaves differently than a floor plan. And a lot of that comes down to that view range issue. So let's get into a ceiling plan. So let's double click first floor plan, lighting. Now, one thing I notice here is that I'm seeing double grids. I'm seeing the entire site. It's not cropped right, things like that. Well, back when we did our power plan, we have the same thing. We need to crop these views. And I'll show you a couple ways to do that. You can actually crop it manually by turning on the crop view, crop region visible, and then you'll see this big box. And then we can pull these down and crop the view like we did with that one section. That's one way to do it, but then we have to do this for each plan. There's a way we can do this globally that we can use for multiple plans, and that's where these green boxes come into play. I want to create a crop that works for all plans, and it's a 3D crop, and that's called a scope box. So if we go to view, you'll see up here scope box. Click on that, and like it says, it's a box that defines the scope of the view. Now there's a height involved to this because it's 3D, and 40 feet's plenty enough height, and we can change it as we go. We just pick 2 points of this rectangular box to define it. I just want to box in my house itself without seeing any of the site. So I'm going to go just outside the house, and the bottom will come down just outside. Now I want to make sure that I catch this condensing unit, so I'm going to go a little bit outside there, and I can adjust this. That's the scope box, and I can give it a name. And I will call this house. It's the building itself, and I apply it there. Well, I didn't change anything other than it gave me a box, but I can confine this view to that scope box now by making sure I'm escaped out. I'm in my ceiling plan. I can go down to scope box under extents, right under view range, scope box, and let's say I want to choose house. Apply that. There. It pulled in the crop like a cropping box would do. Now, what's nice about this is I can now go to my floor plan power and apply that box here as well without redrawing it. And now both of my plans are cropped exactly the same. Now you can see in a multi-story building, this would really help too, because second floor, third floor, etc. would be cropped the same. You may have a separate technology plan that shows network connections and TV connections and things like that. So let's go to first floor lighting now. We have it cropped. We also want to fix some of the architectural issues that we had to fix on the other. Now, what makes this a lighting plan versus a power plan? Well, first of all, like I said, it's a ceiling plan, and we'll look at that. But also, it has to do with which categories are turned on and off. So if I go to my visibility settings for my model categories, you can see I have cable trays turned off, conduits are turned off, data devices are off, electrical fixtures are turned off. I still want equipment because equipment, again, is panels. I want to see my panels in my lighting plan as well as my power plan, so I leave that on. But I don't want to see the electrical fixtures. I don't want to see the receptacles on this plan. I'm creating a separate lighting plan so that it's not as cluttered. Now, architects sometimes will combine lights and receptacles together on their plans when they do electrical, but they don't typically, that I've seen, circuit things up. And so they won't have all the clutter of the circuiting that we do. So as electrical designers, we like to separate those into lighting and power separately. So that's what determines a lighting plan, is what's on and off. And of course, lighting devices and fixtures are turned on. They're turned off in the power plan. But we also want to turn off the architect's grids like we did before. If you remember how to do that, visibility, we want to click into the Revit links. We have 2 links. We want to make the architecture link over here, not by our host view. We don't control it. We want to control it separately. So click on that. And now we head down the custom path. Custom here, click model. We want that to be custom so we can turn things on and off. And the annotations, we want to make custom. And then we want to go down to the grids. Those are annotative. Grids. Turn those off. We also want to set this up for a 1/4 inch scale. So we can go down here to the scale, or we can do it up here and change it to 1/4 inch equals a foot. Apply it. And that helps with this issue. Now, if you have an issue where grids overlap and you've got the scale set right, you can still click on this grid and there's a little split line. Click on the split line and it'll bend that. And now you can grab this grip and you can move the head of this grid bubble right there. And so that's one way to deal with that. And you have to do this on each view. So there's our lighting plan set up. And one thing I didn't mention on this Revit link that I'll do now, you have this choice of visibilities for halftone. If we want this background to be even further shaded so that it's less visible, you can click halftone. And also this underlay means that the graphics for the link, in this case the architectural background, will be underneath anything we show. Now I'm going to leave it off for now, but I'll show you as we get into lighting that that will become a little more important. Of course, we need to save. And we want to get some room tags in here like we did before. Again, those room tags are view by view, so we need to add them to this view as well. So let's go to annotate. We can go to room tags individually, or let's try the tag all. Include elements from linked. Room tags. Now, the visibility graphic setting is set to hide the category in this view. Do you want to enable it? What they're saying is right now, we don't have rooms enabled, so we can't get to the rooms. We have to enable them in this view. So do we want to enable it? Yes. You could also go into here and enable the rooms. Down here, you can see here that rooms are a 3D object in our model. We want to make sure those are enabled. So let's try that tag all again. Include elements. Room tags. Okay. So we did that, but we still can't see the room tags. Well, what happened? Let's check some more visibility things. We have the rooms on. Do we have the room tags, which are a separate category in the annotation? Let's go down to room tags. Room tags are turned on. Do we have rooms and room tags turned on for the architectural model? See how deep this can get? This visibility is huge. Go to our Revit link, go into our architectural custom. Let's go to our model and let's make sure we have rooms turned on. They are turned off in the architectural model. Let's turn those on and see what happens. So now we should be able to tag them. Let's try one. Yes, we can tag those now. So let's go back to our tag all, include room tags, say okay. And now we get it. So those are tagged. Now we can start adding our lighting. Now, like I mentioned before, this project template has lighting families already in it. So let's see what we have for lighting families. We already have lighting devices. We have switches, which we'll need in a minute. Lighting fixtures. Okay, let's see what we have. Now, these are all brought in from the cloud. And if you really need to add more families, here's how you get to it. Go up to Insert. And this may be somewhere else different on your ribbon, but you want to look for the Load Autodesk family. It has a little cloud symbol. In the cloud are a number of Autodesk Revit out-of-the-box families. Now you can find families elsewhere from manufacturers or other online sources too. But the first place you can look is the Autodesk Cloud to see what they have. And that's where these families came from. And you can get into, hit any, and get rid of any kind of search you have. We can get down to electrical. There's architectural versions and there's MEP versions. The architectural versions don't have connectors, but the MEP versions do. So you want to make sure you look MEP. You have panels and all kinds of connections, and the little green circle means it's electrical connector. So you can get to all kinds of devices, generators and equipment and all kinds of devices in here. So that's where these came from. I preloaded them for you so you don't have to go out and find them all. But what we want to do is put in some lighting. Now, typically lighting might be designed by the architect. They may have given you some ideas of what they want. They want down cans here and a pendant or a hanging light here. So there's different sources, but when that gets pinned down and you know what you're going to put in, this is actually how you would actually draft it and connect it up. We're going to say what we're going to do in the bedrooms is a surface mount light in the center. So what we have is a ceiling light, flat, round. The out-of-the-box fixtures are really, they were set up years ago, so they're set up like incandescents. That doesn't matter. We can change the wattage, we can change the names, whatever, to current LED models. but we mainly are concerned about the voltage, and we can change those as well. Let's just drag in a 120 volt ceiling light and see what it is. I get the do not enter sign, which means it's a hosted and it's trying to find a place to host. Okay, by default, it wants to mount this light to the wall. Well, it says a ceiling light. What's going on with that? Well, it's because up here, the default is placed on a vertical face, like we did receptacles and the panel. We need to place this on a horizontal face. So if you go here to this one, place on face, now it's looking for either a sloped or a flat horizontal face, which is what we want. It's finding our ceiling. Now you may encounter, and you will someday, encounter projects that it can't find the ceiling. A number of reasons. The view range maybe is not set up right. Maybe you're in a floor plan. That's why I'm saying we have to be in a ceiling plan, because the ceiling plan is looking up at the ceiling, not looking down at the floor. That's why it's important to have a ceiling plan. Maybe there's no ceilings in your project yet. Maybe the architect hasn't added them. There's a number of reasons. Even architects' lights in the model that have a light source can get in the way of your ceiling, and I have a whole video on that. If you're lucky, you'll be able to see the ceiling and install the light on it. So I'm going to install this ceiling light right here in the middle of the room. Now, I'm not going to worry about dimensioning it and getting exact because, again, usually the architect will, in their reflected ceiling plan, will give dimensions for things to be put in where they want it. But there's that light. Let's take a look at that in section. So here we are. Here's our room. And what do we have here? Well, that looks like the ceiling line. And we have a light up above the ceiling. Well, that's not where we want it. We want it below. Unfortunately, sometimes these out-of-the-box fixtures don't hit the proper side of the ceiling. How can we fix that? Well, in the plan view, there's nothing to do about it. But in this section view, we click on it, and you will see the little flippy button like you see in sections. Click that. Now it's on the underside of the ceiling. Now, if your ceiling has thickness, this may be attached to the top of the ceiling. It's just, again, dealing with out-of-the-box fixtures, this is what we get. So you may have to flip these fixtures up and down to get them to appear right. Now that that fixture's in, we want to set it up for the right name. Very often when we do lighting plans like this, we will apply fixture types, identifiers to the lights. So this may be a type L1 or an L2, or maybe even just an A, B, or C. And the architect may have types already for you as well. So we're going to start giving these some types. We're going to call this a type A. So we go to edit type, and again, we want to create our own type because our tag is going to rely on that type mark, again, like it did on our power plan. So let's go to duplicate the type, and we're just going to call this an A. And type mark A, enter. Now let's check the voltage and wattage of it. Again, residentially, we're not going to worry about the watts. We're not going to add those up piece by piece like commercial, but in commercial, you would type in, maybe if it's a 15 watt LED, you would type that in here. 120 volt, single pole is good. The rest of it, we're not worried about right now. But that lets us apply a type. Let's see what happens if we tag this by category. What's the default tag for this light fixture? Well, it looks like we get a question mark. Well, what is this tag? First of all, it's boxed. Let's see what that is. It's a light fixture circuit tag. But we have another kind of tag as well. We have a lighting fixture tag. It doesn't say fixture type, but maybe it's going to give us the fixture type. So let's try that. And there it is. It gave us our A. So we are going to use A for the fixture type. And then, of course, when we get to circuiting, we will add the circuiting tag. But that way we have this identified as an A. So let's go ahead and create similar. Now we're still in place on face. You may think if you don't have a ceiling, we can add a work plane, and you can add work planes. Now work plane means we can add a three-dimensional surface to the entire model because the plane extends forever and put it at 8 feet or 7 feet, whatever the height of the ceiling is. You can do that and mount fixtures to it. I'll warn you that that gets complicated because, again, those planes extend everywhere. So you're going to have maybe a plane at 8 feet in here, and in the great room it might be at 9 feet, and in the hallway maybe it's at 7.6, and you're going to have all these different planes all on top of each other, all piled up. So I don't recommend going that route. Also, these fixtures are face-based, not absolutely ceiling-based. There's a type of family that can be ceiling-based, and it only works in an architectural plan where it's an actual ceiling. Because we have a linked architectural model, the ceiling in that model is not a ceiling anymore, it's just a face. That's just how Revit works. So we have to make sure we have a face-based family, or non-hosted at all. But let's put this in the middle. And again, it flipped it upside down. So we are going to have to flip these upside down in every situation. So that's going to be a pain. But that's how these out-of-the-box fixtures work sometimes. There we go. It also lets you make sure that you're attached to the right surface. So in the master bedroom, we're going to say we're not using the ceiling light like that. We're going to do recessed cans in the master bedroom. So what do we have for that? Let's go down to a downlight recessed can. There we go. And again, it's set up for incandescent or even a fluorescent. It doesn't matter. We're going to take a 120 volt one, drag it in. And now what's funny is it looks like the do not enter sign. And it's the same symbol. That's actually the symbol that we're going to get. And you can see they kind of flip. This is the do not enter, and this is the actual installing the fixture. It's interesting they use that symbol for the light for a down can. Or place that face. And so let's see if we can place that here. There we go. And then we can place another one over in this corner. And we'll say we're going to have one in this corner. You can see you get little blue dashed lines, which are little helper lines to align things. And you also get some temporary dimensions. And this dimension happens to be from the wall, not from the other fixture, so it's not super helpful. But you can add dimensions too. If you really want to get dimension-wise, if you're doing this and the architect hasn't dimensioned things, you can actually go up to the dimension and come over here and hover over this fixture, and you can get some different places to dimension it to. If you want to dimension it to the center line that highlights there, do that. And then go down to this fixture and get to the center line right there. Click it. And then you click it anywhere to finish. Now you have dimensions center to center, and you can dial this in. Now you can either move this by hand, you can nudge it like that, and depending on the zoom, depends on how far you nudge it. You can also, once you have a device selected, it will let you edit that number, that dimension. Hit 8 for feet by default, and it moves it. Now, which one it moves can vary, but at least it puts them 8 feet apart. And you can leave that dimension on your plan if you want, or you can get rid of it. You can just use it for design and not for a final print. And let's do one more. And I'll line them up vertically and horizontally. Now let's see where these fixtures ended up. Now we've got this section we can use. Here we go. Our recessed lights are recessed down into the room. Same issue. So let's go ahead and flip these all up. I wish it didn't do that. Need to catch all of these. There we go. As I get into the bathroom, it'd be nice if I could see some of the plumbing fixtures and things so I can line things up. What I can do is turn plumbing fixtures on in this lighting plan. And another thing I want to show you is instead of changing each of these plans separately up here, we can assign what's called down here a view template. Right now there's no view template. And again, there's a lot of templates in Revit. This is the template for the view. It controls the visibility of this view. If I click on the none and drop down, we can see there's a few in here already. There's an architectural ceiling plan. There's electrical ceiling. Here's some ER ones. Now these are my personal custom view templates that I've included in this project template. So if we click on the ER lighting plan, we'll notice that everything is set up for a lighting plan already. I've got the view range set up, and I've got things turned on like the plumbing fixtures. If I go down here, I have plumbing equipment and plumbing fixtures turned on. So I can just choose this view template and it will set everything up for me, except for the architectural link, which is not part of the template yet. Do that. Now, we see the plumbing fixtures show up, but we also see the grids. So we still have to go in and turn off the grids in this view template. But it's good to get used to using a view template. We only have one lighting plan in this project. It's a single-story residence. If you have a two-story house, you can set this lighting plan view template up once on the first floor and then apply it to the second floor plan, similar to how we applied that scope box to multiple views. So you'll find there's some shortcuts in only having to set a view up once and then applying it. So you can do that. Or if you don't have a view template made yet, well, you can set up the view and create a view template. If you go up to your view here, right click, and you can say create view template from the view. And you can actually give a name to a view template and make your own based upon how you've set the view up. Just remember that if you get the view set up the way you want it, with things turned on and off and the right shading and all that, save it as a view template and you can apply it. You can also put that into your project template like I've done. So now I can just go to the lighting plan, depending on the scale, say okay, and it's all set up. But I need to fix this architectural link because unfortunately that part cannot be saved in the view template. So let's go to the architecture by host view. We're going to go custom and we're going to go to the annotation custom and turn off those grids. So that's one thing you do have to do to a view template. This view template, for some reason, does not have the rooms turned on, so we need to make sure that gets fixed. There we go. Now that we can see our sinks and our master bath, we can get some fixtures in there. We talked to our architect and found out that they want some light fixtures above these vanity mirrors. And let's make sure our scene is going far enough. See, we weren't going far enough. We couldn't see that wall. Now we can. Now we see this. So we're going to put some fixtures on the sides of the mirror or maybe way high in the mirror. Let's see what we have for light fixtures loaded. We have some sconce lights that we could use beside the mirrors. I think it'd be too high to put it up there. So let's put in some sconce fixtures. So let's go ahead and take a look at this sconce flat round. And the last thing we did was place it on the ceiling. So it's trying to place the sconce on the ceiling. We don't want that. We want it on the wall. So place vertical face and let's place it here on the wall. And what height do we have on that? 6'4". We'll see if that works. Let's get this section set up to look at that east wall. There we go. And there's our light. So maybe we want it to be somewhat centered with that mirror. Up here is too high. So something like that. So that looks good. Now, one thing I will note is that, see, we're seeing that dashed line. Well, because of a ceiling plan, sometimes things overlap. That's where we want to get into making this architectural Revit link an underlay so that it's underneath all of our graphics. So now that we're in a view template, we can't change things here. You'll see it's all grayed out. We have to go into the view template now to do the same thing we used to. Same idea. We can get here, but now we can go to the Revit link. We're in the Revit links box, and here's our architectural. Let's make it an underlay so that it's underneath our stuff. Hit OK. And there, you can see that now it's an underlay. Our electrical stuff shows up on top of the graphics of the background. So we want to call this a fixture like we did before. Let's give it a duplicate name, and we'll call this a B. And you can do L2, or if you like sconces, you can have an S, whatever you like. Let's give it a B. It's also a 120 volt single pole. Power won't matter here. And let's go ahead and tag it with a B, and we don't need the box. Let's see what happens if we just copy this fixture from here to here. Did it give it the right height? Nope, it put it at 0 elevation, so we can't do that. Let's use the create similar. 5'2". Use that wall, and we want it about there. Give us our tag. There we go. Type B light fixtures. Now, this isn't enough light for the entire bathroom, so we're going to install some down cans and get one actually near the shower as well. If you have a waterproof type of fixture, you can actually put one in the shower as well. But in this case, we're just going to put standard cans in here. We want to use this can, so let's go to create similar. Now we want to go back to place on horizontal face and get these fixtures here lined up. And then we're going to put one right here in this shower cavity. And we also need one in the toilet room. Now, we can't see the exhaust fan in this view, but we know there's an exhaust fan in that area. Now, we could turn on the mechanical exhaust fan if we want to coordinate. This brings up another point where maybe I don't want the exhaust fan to show up in my final print of this floor plan, but maybe I want it on just while I'm designing it for coordination. A couple ways you can do that. You can have a different, escape out of here, you can have a different view template that's set up for coordination and a swap back and forth. You can actually create another view, and this is my preferred method, is to actually create another view called coordination view. So I can duplicate a view like I can duplicate many other things. Now, I can duplicate it, just the 3D model part of it. I can duplicate it with the detailing. Now, detailing means the annotative detailing. So it would have room names and all of that. Sometimes doing a duplicate without the detailing helps me to delineate between the actual printed view versus the view that I'm just using for coordination. So I'm going to do duplicate without it. Now I'm in my copy. Now I can change the name of this with an F2. And I will do something like, I like to add like a whole nother digit to this. I also use my own key of lowercase to let me know that I'm not going to drag this view, put it on a sheet. This is just for coordination, lighting, and I put something like coordination. This is a coordination or a working view that is not going to be a final production view or a sheet view. So now in this view, I can get rid of this template and I can start just changing it how I want, like regular up here. Now I can go through and I can turn on the mechanical equipment. Now I can see those exhaust fans and I can dodge them with my light. So what I'll do is I will create similar horizontal face. I'll put my light right next to it. I'm not going to tag it here because the tag won't show up in my actual floor plan view. Remember, tags are view dependent. So now go back to this plan. The light's there in the proper place. It's been coordinated. And now I can apply tags. And I haven't tagged some of these down cans. So let's go here and create similar. Let's get these tagged. Looks like I didn't even label my down cans yet. Well, if I just label one of these, if I change this and just create a duplicate, it's only going to change this one fixture. I need to change all of them. So this is where I'm going to use the right click, select all of them in the project. I want every down can. You can see they turned blue. I just selected every down can in the project, and I'm going to duplicate that and turn that into a C. Apply it. Okay. Now I turned every down can into a type C fixture. And now I can tag these and you can see the C. Now, if I can't get to the C directly, let's say I'm picking the fixture, I can't get to it. I can use the tab to drill down. See how I hit tab and it's picking different things that are stacked there. I know I picked the C because I see the box around it. Now I can pull my C out. And I want to do the tag to the rest of these. A lot of times it's easier to move it as you're tagging it. And I'm getting these all tagged with a C. And I want to do the same in here. So it's simple procedure of just tagging each of these fixtures. Now, unfortunately, I have to go through and make sure all of these fixtures are above the ceiling. Now, you may think, oh, I can just select all of these and flip them. Well, you don't get the flip if you have multiple selected. So we are stuck with individual flipping. So this is a bit of a pain. There we go. And it's only really important if you really care about that 3D model. Sometimes you may not. Maybe you're an electrician doing this for your installers. You don't care about the 3D. All you're producing is a 2D drawing. Save some time. Don't worry about 3D. Just get it to look right here. Now the closet, I want to get a couple cans in there. So create similar. And let's put those in here. And I can use this section to help me flip those. And let's get those tagged. Right click, create similar. We're going to put some surface fixtures in this laundry room. It's going to be utilitarian area. So let's just go here. And in fact, I forgot to tag that fixture. So let's get a fixture tag. And then right click, create similar. And let's go into the laundry. And now what's happening here? I can put the laundry here, but when I get here, there's no surface to mount it. In this case, there's a shelf. And because this fixture is coming in at 0 as a default elevation, it's below the shelf. And so it can't see the ceiling when I put it under the shelf. That's an issue with some ceiling plans. So what you can do is put it out here and then drag it over the shelf. And it's attached to the ceiling. It stays attached to the ceiling, but I need to move it around. And then let's get another one out here in the middle of the laundry room. And again, we're going to have to move this section and fix those ceiling lights to get below the ceiling. Now we have that exhaust fan issue. Let's see if we avoided it. Let's go to our coordination plan and see what's going on. Looks like we are okay. We're close, but we avoided it. And we can nudge it a little further north if we want to avoid that. That's why this coordination plan is handy. We don't have to mess with view templates or change visibility graphics. We can just simply swap from view to view. So that's very handy. Also in this coordination view, you may want to turn on things like ductwork. We can go down to the ducts and the duct placeholders and linings and all the ductwork and air terminals. Now we can see ductwork. So looks like this is a return up in the ceiling of the hallway that comes down to our furnace. Now we have lights under it, and because these are not recessed, we're okay. Plus, it looks like the duct is very high. Now, if we're not seeing the full ductwork, all we see is a line, we can change the detail level of this view to see the duct. And I was saying that this is coarse right now, and the duct is set up to only show a single line in coarse view. If we go down to a fine view and apply, now we can see more details. And now the ductwork is showing up in 3D, so we can coordinate that. So this is just a good way to do some interference and clash detection just visually. And again, we can go to our coordination view and see all of that. And even looks like our down cans here miss this exhaust duct. Let's see where that is in 3D. Again, we want this, it's fine. So there's our exhaust, and it's very close to our down can. So we may want to move this down can down a little bit just to make sure. So that's the kind of coordination you can do when you turn things on and to find view. Let's get these tagged. The pantry, we're going to have a couple surface fixtures in here as well. Create similar. We'll go here and here. We need to get those turned. The extra step of going section. And you'll start to see why I don't use out-of-the-box families. Let's check our coordination in here. Looks like we have no ductwork over here. The only other ductwork we have must be under floor, and we have a little one here that we'll deal with. And speaking of that, we could make another coordination plan as a floor plan view. If you go to the power plan, if we create a duplicate of this view and call it first, let's go lowercase, floor plan power coordination. This will be more of a floor plan coordination, and we can turn on ductwork for this plan as well. And let's go down to the duct. And even we can put piping in here too if we want to look at everything. Pipes. We don't have plumbing modeled in here. We don't have like the hot and cold water and all that. Those are typically small enough to not worry about coordinating with, but we are coordinating with the ductwork. So this would most likely be the underfloor ductwork. And we're only seeing a portion of it because this view range, as you recall, stops at the floor. The bottom is the level 1, view depth level 1. Now view depth here, that part that's below the actual level, let's bump that down to like -10. Well, actually what we can do, let's go ahead and just change it to unlimited. Let's get rid of this. Let's go to unlimited below. We want to see down to the depths of the earth. Okay, there. Now we're seeing the underfloor ductwork for the HVAC system. Not so concerned with this on the power plan unless we're putting maybe floor boxes in that may interfere with some of this. In a commercial building, you may be worried about some underground or underfloor feeders and large conduits that you'll want to check interference as well. But anyway, this is another coordination view to help you coordinate your power with the HVAC in this case. And we can start looking at sections for that. Like in this case, we have a receptacle, but it's here in the room, and this ductwork is most likely under floor. We can check it with a section view. There we go. Here's the ductwork under the floor. So again, coordination view. Back to our lighting plan. Let's get these typed. So in the kitchen, we're going to put some recessed down cans as well. So create similar, or save the project every chance you get. And the one nice thing about hosted families is it does put it at the proper ceiling height. If this, for example, was an unhosted family where it was not attached to the ceiling, we would have to manually figure out how high to mount these lights. So there's pros and cons. Put this in here. Another one here. And we also want to put some above this counter, again, because it comes in at the floor and is trying to find the ceiling. It looks up and sees a counter. So we're going to have to install these and then move them over. So we'll put these here. And then, again, let's uncheck the pinned elements. Window this and drive this over. I'm going to put them right on the middle of this island. And then I'll put some out here. And we have to go through and move all these, unfortunately, above the ceiling. Because we have the depth here, we're only seeing a few fixtures at a time. We could just move this here and get all of the fixtures. But if they're in front of each other, sometimes that can be an issue. Let's see how that works. Once they're up out of the way, we should be good. See, there's yet another one. There we go. And get these all tagged. Now in the dining room, we're going to say the architect said they want a pendant or suspended fixture. So let's see what we have down here for that. Close the sconce. We have a pendant light disc. Again, we have limited options here, but we're going to use a disc for now. And a lot of times our plans are just symbols. They don't need to actually represent the geometry of the light fixture. It's just a connection symbol. If you're getting into architecturally accurate, and like a lot of architects will, they'll show an actual family for the actual fixture they want. That's fine. For our purposes, we are really just showing connections with a fixture type to get things hooked up. Now, I can't do it under the table, so let's keep it out here and drag it over. And then we also need to make sure that it is hanging. Look at that. It's hanging up in the attic. So let's turn this guy over. Crazy how that works. This one needs another fixture type. Now we've got A, B, C's. Let's go with a D for this guy. Duplicate D, capital D, and then we're at 120 volt. We're good there. And that's because we want to make sure we can connect it to our panel. For some reason, if you bring a light fixture in that maybe was set up as 277, commercial voltage, then I couldn't connect it to my panel. So we want to make sure that voltage is set proper, and the poles. Now, the great room is just going to have some down cans in it, so let's throw those in. There, those line up. And then we have another pendant fixture at the main entrance. So let's get all of these fixed above and below the ceiling as needed. One extra step we have to do. And get them all typed. Okay, we're getting there. We have a hall and restrooms, and then some garage, and even maybe some exterior lighting. So in the hall, we're going to have some more surface fixtures in here. It's not as fancy as the master bedroom, and we actually need to add some fixtures to this hall. Let's go with some down cans in the hall. And get those fixed. Use this big section. There we go. And keep checking our coordination. That's our floor plan coordination. Here's our lighting coordination. Now, here we go. There's a return grill up in the ceiling right there. So that light won't work. So we're going to have to move it. Let's go this way. Do something like that. So that's why we check this coordination view. And let's close a bunch of these so we can get back to just our lighting plans. There we go. Move the hall and get this created. It's very nice having that mechanical model available. Now back to the hall. We're going to put these surface fixtures in the hall. One there and one there. And let's put them below the ceiling. How's coordination over here? We're good until we get into the restroom. So let's just go with a surface fixture in here. And we don't want it above the tub. Let's just put it in the middle of the room. Avoid the exhaust fan. And of course, flip it over. Looks like it interferes there, but that's just in section. In reality, we are a ways away. We're good. Then we want a vanity light here as well. And let's use another one of these. Create similar. It's a wall mount, so let's go vertical face. Get it hooked up there. And we can put our section view over there. What do we have? We have a section here we can drag around. Instead of creating a bunch of new ones, I'm fine just dragging these around. They're just used for, as we're designing anyway. Something like that. It's nice to have some light on your face as you're looking in the mirror rather than just above you. Now, we want to make sure we're in our lighting plan when we add our tags. So you want to make sure where you are. Another thing you can do in a coordination plan is you can change colors of things to make it obvious that you're in your coordination plan. Now, the ductwork should help to make it obvious, but we can also change the color of light fixtures. Now, because these light fixtures are not symbols, they're actual, the geometry of the light fixture, the extrusion that's in the light fixture family is what we see. We can change the color of that by changing the light fixture category color. And this is a good way for me to show you how you can override the default color that's set up in this project template. So let's go over to, this is our coordination view, so we're not in a view template. Go over here to our light fixtures in our model, not the Revit link. We're in our model, lighting fixtures. Now, here's where all these overrides come into play. Lighting fixtures. There's projection or surface, then there's cuts. It's like if you cut a wall, it will look different than if it's a wall that's not cut. It's just like a wall below the cut. We're not worried about cutting light fixtures. We're worried about the projection. There's lines, patterns, and transparency. We want the lines of the light fixture to be a different color. So you click here and you can get into an override menu. We can override the pattern. We can override the color. So, we could change these to a dashed if we wanted, but we just want to change the color. So let's change the color of these to something like blue, or even something like jumps out at you. Something like this purple or pink, magenta. Okay. Now see how that changes the light fixtures all to magenta. This is another good way to remember that you are in a coordination view. You're not going to tag light fixtures. You're not going to show circuiting or anything like that here. This is just for coordinating or placing things. So that's another good way to separate your coordination view from your actual production or sheet view. So let's go back here, move things around, and let's go ahead and tag these. Okay, now we're not putting any lights in these closets. You may want to add a down can into these or not. It's up to you. But let's get a light out here, at least on the porch. And I'm going to put it, I think I have a receptacle over here. I'll put a light over in this wall too. So I'm going to use another sconce. I'm going to use a different sconce. Let's use this uplight sconce just to have a different look. And vertical face here, 6'4". That works. There we go. And if you want to see what that looks like, let's drag the section over, flip it, and take a look. So there it is. Looks like that. And I'm not going to worry about centering above because these, again, will be mounted to studs and they may not line up exactly anyway. This guy needs a type. We're going to call that an E. Duplicate, that's an E. 120 volt, we're good. And tag it. Now in the garage, you could put some kind of a surface LED circular fixture here, or some people use what looks like an old shop light, either hanging or surface mounted to the ceiling that's still an LED kind of a strip. So I'm going to say I'm going to use a strip like this. Now let's see if this is hosted or not. Here's a 2-foot and a 4-foot. I'm going to use a 4-foot version, drag it in. Now let's see. Now I don't get the place on face or vertical face. So this means this is a non-hosted, finally, light fixture that we can specify what height we want, and we can put it anywhere we want. This is the pleasure of using a non-hosted light, is we have much better control. Now, to turn this, it's horizontal. If I want it vertical, I can hit the space bar and things will turn. So I'm going to put them like this. Now, what height do I want? Well, what height is my garage? Let me put this in here and then we'll take a look. Let's flip this and look at it. All right, so it came in at, it's calling 0, but 0 is not at the floor. It's a certain level above this level. Now we're also in the grade level, so we need to do that. And then we need to move this up to get to the ceiling. So I want to move this up here. I can't use an absolute dimension because it looks like maybe that's how it works, 7 feet. That puts it up at the ceiling. Here's my coordination view. I'm okay. There's no other ductwork in here, so I'm good. So let's go ahead and see if I can copy this, because I've already got it at a height I like. I'll put it here. It's going to end up being above the garage door, which is okay. And let's see if that looks right. Yeah, we're looking good. But I also want to make sure I give this a fixture type. So I want to select both of these and give it a fixture type of an F. And then I want to copy these over here. So there's my garage fixtures, and I need to tag them in the lighting plan. And then I want to get some sconces on the face of this garage on either side of this door. Now, even if I only have a couple different sconce families of looks, I can still give them different type names. Again, this is just kind of representative of a fixture connection. So if I take this, create similar, vertical face, place it right here, I can still give this yet another name. I can call this a G. I don't have to make it an E. I can make it a G. Even though, again, it's the same family, I can still give it a different type name. And I'll have a schedule somewhere or a list that identifies what A, B, C, D, E are. What model number is our basis of design, you know. What voltage are they? How many watts are they? How many lumens? All that. So that's what this identification does. So let's get another one. This side. And these are going to be tagged. And I can indicate how high they are. I can let the architect indicate how high they are. I also want to tag my panel in my lighting plan. So let's go to a tag. B1. There's one more thing I would like to add for my lighting back in my kitchen. I really want to get some under cabinet lights under these upper cabinets. So let's see what we have for that. We have a downlight under cabinet. Let's try that one. Pull that in. And again, we have a non-hosted family. There's no place on face. So we can put this wherever we want. So let's see. Let's put that under the cabinet. Out towards the face of it. I'm going to hit spacebar to turn it. There. Now let's take a look at this. It's not quite as long as I'd like. So we can adjust that. I'm going to use the smaller section here. There it is. Oh, it's way out there. So the upper cabinets are not as deep. And also, it's kind of looking like a blob at this scale. Let me hit up top. There's, at the quick access toolbar, there's a thing called thin lines. I can click on thin lines, and it temporarily, you can toggle it on and off, temporarily turns all line types into thin. So they're not as thick. And it helps us see the shape of that. And so now we can move this over and actually move it up. See how it's free floating? It's not attached to anything. So I can do that. Now, if I want that to exactly touch that line, I can use that align tool that we used previously on levels. Align to there, from there, and it's aligned. All right, so there's that. Now, coordination-wise, how are we doing? We're okay there. As I zoom in and out, you can see that upper cabinet shows up. I want to make this a bit longer. So let's go to this view, flip it. There we go. I'd like to make it a little more of this length. So what is that length? We can use the dimension to figure it out. The dimension of that cabinet is 1'9", and I want to bring it in a few inches, so maybe 1/6. So where can I fix that? It's not an instance parameter here. It's a type parameter. So let's jump into the types, and here we go, the light length. It's only 1 foot. Let's go to 1/6. And then I can use my arrow keys to nudge it over. So something like that. And since maybe this is all one cabinet, it's hard to say because this may just be the architect's rendition of these cabinets. In reality, the shop drawings of this cabinet from the vendor may have a recessed area under here where it goes. So there maybe I can't continue it through this joint. So I have to just get approximate here. What I'm going to do is show these connected together at this center line. So let's go here and do a copy. And I can use built-in automatically snaps to these areas. So if I snap it to that corner and then copy it to that snap to that corner, it puts them right in line with each other. And then once that's copied, I can select all of it, hit copy again, and maybe snap it from this center line between the two doors and do it here. And that gets things copied exactly. So in my first floor plan, I have that. Now, did I type these yet? I did not. Let's make sure I go through and give these a type. I think we're at H. So we will go edit type, duplicate, H, just like before. Okay, so we're in our actual plan, not the coordination plan. So we can do type and get it on each one. We don't have any above cabinets here. We do have some here. So let's see if we can take these and put them down there. So let's do create similar. And they come in horizontal. And let's see, our upper cabinets are right here. Now we could go a little wider on this version. So let's flip this down. Right there. And make sure we're looking at the wall. There we are. Let's see if we can go, let's just go one wider there. So right now it is, let's go 2 foot length, see how that looks. And let's say we're just going to go with a 2 foot length. They probably come in standard sizes. Now, because this is a different length, that would typically be a different type. Type usually includes length. Now, as you can see, what happened is I changed the length of this type, which changed my H's. Now they're too long, they overlap. So that's the pitfall I get into in changing the dimensions of the type. I need to go back, undo this, till I get back to the old. There we go. I went back enough where things are right. So what I need to do before I change the length of this type, I need to create a new type that will have a different length. So let me go to edit type and duplicate this. Now I can go to I, J, K, whatever, or because this is similar to the H, I'm just going to call this an H1. That's another way of having a different type, but it still says they're kind of in the same idea. They're both under cabinet lights, probably the same manufacturer, just differing in length. And then this one, I can make my 2 foot length. It won't change the H's, it's only changing the H1. And so that's how I want to do that one and get that moved over. I also want to put this H1 over here. So I'm going to copy that, kind of to the center line and get centered. Again, it's not exact, something like that. And let's get these typed. There's the H1. The next step we're going to accomplish is adding lighting controls. If you do any commercial work, you probably know that lighting controls can get very sophisticated very quickly. Rarely are we just switching the line voltage on and off. We typically have to include some kind of occupancy sensors, daylight sensors, timers, time clocks, all those kinds of things. And that is most easily done nowadays as a digital lighting control system, whether it's room by room or as an entire building. Residential lighting can be that complicated if you have the budget for it. Otherwise, it is still a lot of times just line voltage switched, which means a switch just interrupts the 120 volts to the light. That's how we're going to do this project with just line voltage switching. But just know that you can get as complicated as you need to and indicate it that way on your plans. So let's go with the old-fashioned line voltage switching and just show switches on the walls. So what we're going to do is go down and find our light switches. That's under lighting devices. So we have lighting switches, and you open that up and you see a bunch of different kinds of light switches out of the box. Most of these are different because they have some kind of a label attached to them. Like a low voltage switch, you pull that in and you put it on a wall and you'll see the LV is part of it. Now, it covers up part of the switch, so it's not ideal. It'll be upside down if you put it on this wall. So I don't love labeled switches personally. I like to add my own text to the label, but we're just going to use single pole and three-way switches in this line voltage light switching scheme. So we're simply going to pull a single pole breaker. We're simply going to pull a single pole light switch in here, and it is a place on vertical face, another face-based hosted symbol, and it's coming in at 4 feet above our level, which is fine. And we'll put that there. Simple as that. Now you have to decide if it's going to be above the sink, above the counter or not. Let's try that. We'll get to the hallway in a minute. This bedroom needs one here. Right there. If you look at the 3D aspect of this, let's move this section down here. Flip it over and look at that wall. You'll see that it is actually a cover plate like the receptacle. That means you want to make sure you're far enough away from the door trim. So in this case, we want to make sure we pull it over. Again, in the two-dimensional world, we're not as worried about it, but if you want your 3D model to be accurate, you want to pay attention to that kind of a thing. Now the hallway is short, but we still would like three-way light switching at least each end. I don't think I need to put one at each of these, at every door. Like this door doesn't need its own light switch. Once you come out of here, you can easily get to the light switch that I put here. I'm going to use the built-in three-way light switch because it has a little 3 on it. And even here, you'll see it's an upside-down 3. See what I don't love about that? But for this case, we're using out-of-the-box families. I will go ahead and do that. The other way you can do it is just install a regular light switch like this guy, and then put your own text 3 next to it, which I prefer, frankly. Now for the great room, we have to think about how we want to do the switching here. Now your architect may show switches on their plans. Sometimes they'll show switching and with a dashed line indicating what controls what. So we can use their plan for that. In our case, we'll say we don't have that, so we have to invent this on our own. For the great room, we have an entrance here. We may want to turn it on and off from this hallway. We do not have a back door out of this residence. We may want to control it separately at the dining area or the kitchen area. So I'm going to put 3 controls in here. So we've got a 3-way at the entrance. We're going to have another 3-way at the kitchen. Let's say it's over here. And then if you're familiar with line voltage switching with 3 ways, if you have more than 2 of them, you have to have what's called a 4-way switch. It has 4 terminals on it. So we'll do that. So let's see if we have a 4-way. There it is. And put that like right here. Again, it turns to 4 sideways. We're just going to live with it. So that's how line voltage switching is done. We're going to include a couple switches for the kitchen and dining area, and we'll just have these all switched together. So again, we'll put a 3-way here. Now, you may think that, well, these two switches would typically be in a double gang box with a single wide cover plate with two switches. And I've seen there's some nice families out there, custom families that you can get that show it that way. And so you can use that kind of a system if you really want to be that accurate, if you want to be what I would call like architecturally accurate so that it looks right in a rendering. In our case, for our electrical diagrams, we're not worried about that. But if you are, there are options out there to use that kind of a custom symbol. And let's put the three-way over here by this hallway. And do we have a good place to mount that? Yeah, we can mount that above this counter. And then in the hall, we're going to put one here for this entrance. And at the garage, we will put one to control this. If you go in the laundry, you're going to be coming back out the laundry. We don't need to worry about that. Let's get a standard switch into the pantry. So let's find one of those. There we go. There's the pantry switch. And also for the laundry, we just need a laundry switch. This closet gets a standard switch. Master bath will have, we could have a couple switches if we want to do sconces independently, but we're just going to keep it simple. Single switch, and this little separate toilet room gets a switch. A single switch here should be fine. You wouldn't typically turn the lights off here because you have to come out this door anyway. And then for the front porch light, sometimes those can just be on a photocell sensor, and it gets tricky if the photocell's built into the light because as the light turns on, the sensor may see that and turn itself off, so that gets messy. We're just going to put in a manual switch. And your energy codes may determine whether you can even do that or not. And let's get a switch in the garage. Single switch in the garage. Now, mounting height for this gets tricky because the garage is at a different level. So let's go down to the grade level and make it 4 feet above the grade level. And we'll say that these lights by the garage come on with the porch light, and we'll get that indicated. Now, back in the kitchen, we do have some under cabinet lighting that we may want to control separately. So let's go ahead and put switches in just for those. So one switch for that bank, and we'll put in a switch for this bank. Now, what's happening is as I do this, it's seeing some other things, and I have to use my tab to get to the right wall. And one thing I'm noticing too is I still have thin lines on. Let's go up here and turn the thin lines off. There we go. That's why we're not seeing some thickness on these lines. But trying to do this, it's trying to find the edge of this cabinet. So I can either do it here to find it, or when I'm over here, I'll hit tab until it finds the right surface like that. Remember, stacked surfaces work like that. So there we have that for this under cabinet lighting. So we should be good with lighting, switching. Now we want to get things circuited. So the next step will be to get the lighting circuited and the switches and all that indicated. So now we're going to circuit these lights and indicate the switching scheme. This will be similar to what we did on the power plan. However, in this case, for example, in this bedroom, because I would like to show that this switch controls this bedroom, I'm going to have some wiring showing. I'm not going to show the wiring going throughout the entire house, like from bedroom to great room and all that. But within each switching area, I do want to show wiring to show the switching. So it's going to be a hybrid of indicating circuits with numbers and also indicating switching with the built-in wiring tool. Now, you could just draw arcs, for example. I could take annotate and detail line and do my arc. I could simply take an arc from here to here and draw it like that. These are hard to modify. Like I'm trying to change the arc of that. I can't. Look what it does. Or I'm trying to move this and I can't move it around. So these are very rigid. You don't want to use these. Let's use the built-in wiring scheme that's built into Revit, and it has a lot more advantages, which I'll show you. So the first thing to do before we do that is we want to make sure we know how things are circuited so that they're on the same circuit, so it will allow us to do the wiring. Some people will wire the light to the same circuit as the receptacle in the room, and that's perfectly viable. Personally, I like lighting on a separate circuit from the receptacles. If you've ever worked in your house, you've ever wanted to change out a light, and you don't want to rely on the switch, so you go turn off the circuit breaker. Well, you want your receptacles to be on because maybe you need some plug-in power tools to do your work, or maybe you'd like to plug in a separate work light to the wall if you don't have a battery light. Anyway, I like to keep them separate. It only adds, a couple breakers to your entire building to put lights, because we can put a lot of lights, especially with LED lights, on one circuit. So it only takes a couple of extra circuits and some extra wiring to make it work. So we're going to do it that way. So let's start circuiting our lights. We're going to start in the garage. Let's get these 4 garage lights circuited up. So just like power, I'm going to pick a light, and I like to hit power and label it. So I'm going to say garage lights, use some abbreviations. And I'm putting my lighting on a 20 amp circuit so I can get a lot of lights on here. Edit the circuit, and let's find the rest of these. There. Because I want to show the switching, I'm going to put the switch on the same circuit as the lights so I can connect the wiring. So a switch has a voltage also. And it doesn't have a load, but it does have a voltage. So we want to make sure that our switch is set up as 120. Luckily, it comes in as 120, so that's good. So we can add that switch to the same light circuit. So how do we get to the circuit? We hover over it, hit tab until we see that, click it, edit circuit, and add that light switch. And it hooks up just like a light or just like a receptacle. There's a couple different ways to do the wiring. If I get into the circuit, hover, hit tab, click on it, I can click one of these symbols here to actually add the wiring. There, I clicked on the arc and it added arcs. So if I get back out of it, you can see that it added arcs for me. It puts them where it wants, and it's not always maybe how I'd want. Maybe I want the switch attached to that one. Maybe I want this down here instead of, so you can live with that. And sometimes I do that if it works out right. It even shows the home run, which in my case, I'm not going to do that. Commercially, you'd have a home run that would have a panel and circuit identifier here, but we're not going to do that in this residential project. So what I'm going to do instead is I'm just going to start doing my own wiring. I'll show you how that works. The one trick is you have to know where to connect it. So if we go up to systems, you can get to the wire, and it may be on the left, it may be anywhere, it can be dragged around. Drop down to, I like to use arc wire, and I want to select the connection point of this light fixture. Now, you may not know where that is. We're looking for a symbol that's a little pink or magenta circle. It happens to be, in this case, in the center of the light fixture. And I just ran across it, and sometimes it's hard to find. But you can get close and see if that works. Looks like it's working. So yeah, it did connect. The connection point is around the center. So we want to go arc. So let's connect. There's the circle showed up. Center. On these arcs, instead of picking two ends and center, we pick the center second. So center second, and then go up and find the next connection point, which should be another circle. Sometimes it shows up as a square. And then I can do the same thing here. And I'm just going to attach these. And because I'm coming from the panel, now a lot of times they'll actually wire it from the panel through the switch and then up to the lights. So I'm going to go from here to my switch. Now the switch connection point is way at the wall. And then let's go from here down to here. Now, if it doesn't connect right, like if I did that, you would see an arrow and a home run. And that lets you know that I missed. Like if I connect it here, it works. It found the connection. A little tricky. And then this here, you can change where this wiring hits the device. There's a little teeny circle. It's hard to see with the fat lines. If you go to thin lines, click on it, you'll see that little grip. See that grip? I can move that grip wherever I want. I'm not disconnecting. I'm not grabbing this, which would disconnect it. I'm just saying, where do I want that line to graphically hit that switch? I'd like it to hit right there. You can do the same here if you need to, but these ended up okay. So that's how you can do hand wiring. And I'm just doing this to show that this switch controls these lights. Another way you can indicate switching, which we do sometimes on commercial, is to just put a lowercase letter A and put a lowercase letter by all the lights that are A's. That's another way you can do it without having to show all the arcs. In this project, I'm going to do it like a lot of architects do it, a lot of electricians do it with the arcs. But for circuiting reasons, I'm going to use my circuit tag. Now let's see if I can find a circuit tag. I think we saw one before for lighting. So let's go to the tag. And it's trying to tag the fixture type. But once we do that, we can go and pick the other tag, which was the circuit tag standard. And there we go. So now we're connected to circuit 31. Let's look at our panel schedule. And you'll be able to find that over here on the left. Now there's a panel schedule heading. Double click P1 and it opens up. And here we are circuiting our lights. So now we can continue through this house circuiting up lights. So I'm going to do this side of the house from this circuit, and then I'm going to do the other side of the house with the other light circuit. I'm going to just hover over that, connect it, edit circuit, and I'm going to start picking lights and switches because I want the switches wired up as well so I can show the switching wiring. So let's go here to all these lights, and now that I'm in the circuit mode, it's easy to pick lights, and I'm not accidentally picking tags or room tags. It just makes it a lot easier to select only the electrical devices. Let's go to hallway. And I need both of these switches. And let's get the laundry with its switches. So that's this side of the house. And I think I have everything. If not, I can add them later, but let's say we're finished with those. Now I can go through and show my wiring. I'm going to do hand wiring again, hit the arc. And this connection, as you can see, the circle is in the center. So now I can just do this and then click it again to get the switch. May have to move some tags around, but this pretty much hits where I want it to. Depends on how picky you want to get. But now that they're all circuited, they're very easy to just show the wiring. So let's show the wiring from here, middle, to that switch, and that hits fine. And then this one, I'm going to show wiring from here to there, and from there to there. You can see it gets fairly easy just to do this circuiting. And from here to this guy. Now, where's the connection for that? We don't know for sure. Let's try there and see if it connected. And then I want to go from here. That's connecting properly. And then let's let the switch leg be right here. And that connected. We can pull this a little bit here. Simple as that. So let's go to the master bedroom and continue with our wiring. And it goes pretty fast. And let's see, the hall lights, do we have yep, we have those circuited. We can verify over here. So let's get those circuited. And this hall, sometimes it's hard to get these out of the way. You can change the arc of the wiring, which is another reason it's nice to use. You can move it down here to give it a different shape. You can even right click on there and add a vertex, insert vertex. And you can pick where do you want the vertex to be here. So click there. Now you have two of these grips to shape your line. And so you can do, some interesting S shapes. You can add more vertices. You can get rid of them. So a lot of control on what you're doing with this wiring. Now in commercial work, sometimes we will show conductors in here. And so we can add conductors with the plus and minus. In this case, we're not showing the wires. So that doesn't mean anything right now. And again, remember, this wiring is actually, it's like a Romex. It's a cable. There's wires in this. This isn't a single wire. In commercial, it may be a conduit. So again, wiring is the term they use, but it's actually cabling or conduiting with wires or conductors inside of it. And let's do the laundry room. Again, if I miss, that worked. But if I miss totally, like that, you'll see this arrow. And we can simply drag that arrow into the fixture to get it connected. And there's your visual indication that it actually connected. Now, I also need to add circuit numbers to the rest of these. So I'm not going to use this tag. I'm going to use this tag, create similar, and get circuit numbers onto my lights, like I did with my receptacles. And you can decide if you want to show it on every single light. Maybe you just want to show it on one in the room. I've done it both ways. I used to just show it at one in the room, and then I've had other clients that like to see it on every light fixture, so I just got into that habit. It's fairly easy in Revit with this tag feature, especially if you have to change it. If you put text in and change circuit numbers, that would be a nightmare. Okay, now we can circuit up the other half of this house. So let's start here in the pantry and work our way around. Power, west lighting. And I may change the other circuit to be east lighting. Let's edit circuit. We're going to get all the lights and switches in the other side of the house. So as you know, if you're familiar with this kind of work, there is a lot of connections. Now, I do a lot of zooming, as you can see, to get it move around. You can also just push down the center mouse button and pan, as well as zoom with the scroll wheel. But if you hold down that scroll wheel, you can pan as well. I just have gotten muscle memory for this kind of zooming. Now I clicked on this, but it won't let me select that because I'm in circuiting mode, which is handy. Otherwise, that would cause an error if I tried to circuit up a section view. Make sure I get all these. Now, the other thing I can do is I can just window this and get all of the electrical stuff, which is another handy feature of circuiting mode. So let's say we're finished with that. And of course, save. Now we get into wiring mode. Now for these, I just want to wire them to their switch. Like that. Same with these. These get wired to the switch and to each other. You have to make sure, remember how these connect. There we go. This connects from there to there. And luckily, if you get close, it usually figures it out. There we go. And then we want from the switch to these kitchen lights. And I missed. Nope, it caught it. Nice. Now I want to go from this light to the switch. And depending on which way this gets fed, depends on how I go. I'm just going to go from here. Again, this is diagrammatic. The electricians will wire this up how it makes most sense in the field, depending on what obstacles they run into, fishing these NM cables through the structure, etc. But this is just an indication of how this gets switched. We're also switching the dining light from here, so let's get a connection out to there. Now I missed. I got the home run. So we need to make sure we pull that into the actual connector. There it is. And then let's get this wired out here. We have a three-way. And we're going to do all of this from here. Let's get this switch attached. There he is, right there. And get this connected like that. Nope, missed. It's the only hazard with doing this kind of a hand wiring is you really get picky about how that connects. But usually just takes a couple tries. Just for example, if I was to try to use the automatic wiring in this scenario, it would try to interconnect every one of these rooms together. Let me show you. I'm going to highlight over this and hit tab. And it's going to take 2 hits to get the tab. There, if I click that, you can see that it is trying to interconnect these guys here. It's trying to put a home run there. It would interconnect all these rooms together, even out to here. So I don't want to use the automatic wiring, and that's why I'm just doing this by hand. Sometimes in commercial work, it tends to work, but you know, this guy's kind of in the way, so I'm going to move him. The way you move the head of that section is to grab it there. And it doesn't really affect what the section covers. That's determined by this guy. Also, you know, it may be tough to get 3 or 4 cables into one fixture. Again, this is not an exact wiring diagram. It is just a diagrammatic indicator of how we want things switched. So we got those all connected. Let's get the hallway connected. Restroom. And I hope you're following along and trying this on your own. Just pause the video where you need to. Do your own. Practice it a few times. That's the way you'll learn this, is lots of repetition. Now, did this get attached to a circuit? We did attach that to that circuit. I'm going to move it over to this other circuit, but let me go ahead and show circuiting first. Now, I noticed in the garage I didn't get everything circuited either, so let's finish that up. Now we can finish this. This is the other circuit 33. Now I'm going to connect these outside lights to this other circuit. Let me tab into this. And this is where I'm going to say east lights. And I want to edit the circuit. And I'm clicking on one that's already circuited to the other circuit. Let's see what happens. We get a warning. You have selected elements that are already part of other circuits. They will be removed from the original circuits and added to this one. Okay, I'm fine with that. And that's a good warning in case you didn't remember that. Finish. Now I'm going to wire these up to show that they are all switched together to that switch. So what's happening here is as I connect it, it's not finishing the connection. Well, that means that something is not set right. Well, let's check circuiting. That guy is connected to circuit P131. Let's check this switch. It's connected to the other circuit, 33. So I need to move this to my circuit. Now, the way I do that is even if I go up here, I could change it to panel, but I can't change the circuit. I can only do that by coming into this fixture, tabbing till I get to the circuit, click the circuit. Now I can edit circuit and select this switch. Again, I'm selecting an element that's already on another circuit. I know that. I'm good. There. Now, as you can see, it finishes this connection and doesn't make it a home run. It's happy that it's all in the same circuit. And it wants to show it down there, so I'm going to pull this arc like that. Now here's that piece that I can drag over there. The actual grip is a little bit different than the actual connection, so you have to play around with that. And I want to make sure that's good and get as picky as you want. Let's get circuit numbers on those. Now we have all the light fixtures connected to circuits and to their switches. Next, we're going to create a one-line diagram or single-line diagram, which is a typical way of showing how service comes into our house, how it's connected to the panel, and the sizing of all of that stuff. So we're going to create a simple two-dimensional diagram on what's called a drafting view. So go up to View, and under the Create, there's one called a drafting view. So click on that. It's just a two-dimensional view, kind of like if you ever did CAD, it's like that's two-dimensional CAD, and it's just like drawn on a piece of paper. And we call it a one-line diagram. Some people call it a single-line diagram, same thing. If you need to become more familiar with one-line diagrams, I have a separate video, which is linked in the description below, about what is a one-line diagram. So we're going to call this one-line diagram, and I like to put the voltage of the system. Now, this is a residential, so it's kind of obvious, but I'm going to put the 120, 240 volt single phase 3-wire system, which is a standard nomenclature. And the scale, I'm just going to make it a 1-to-1 scale. So 12 inches equals a foot. And we get a blank canvas. And over here under drafting views, we see one-line diagram. Now, unfortunately, Autodesk Revit does not come with any one-line diagram symbols whatsoever. So we have to draw them all from scratch. If you're doing a bunch of these kind of diagrams, it's smart to make the symbols as separate families. Now they're just annotative families, they're just symbols, but that way you have families that you can drag in and use for panels and meters, things like that. We don't have those in this project, so we're just going to draw everything by hand. This also will just be a dumb diagram. There's no smarts to it. It's not tied to the model whatsoever. So let's just go up to the annotation. We're going to use detail lines, just annotative detail lines to draw this diagram. And we have different line styles like we did in our floor plan, and we have different tools. So the first thing I'm going to do is draw my load center, which is a residential panel, and I'm just going to use a rectangle. And I'm using medium lines. So let me just draw a rectangle. Now, how big should this be? Well, we're in paper units, sheet units right now, so actual real world. So if you had a diagram on a piece of paper, how big would you want that to be? Well, I typically would draw a panel maybe like a 3/4 inch wide by 1 inch tall. But for now, I just put it whatever, and I can adjust these dimensions now. So click on this, 1'7" wide. That's like actual dimensions, 1'7". That's too big. I only want it like 3/4 of an inch wide, 3/4 inch, and that's tiny. And then the height, I only want it like 1 inch tall. So as you can see, we need to zoom in on our diagram. So that can be our load center. And let's put some text in there. We're going to use 3 30-second Arial. And this is all just dumb text in this diagram. So remember, built in, we have 1/4 inch and 3 30-seconds. We'll use this. And we can just put a name on here of P1. That's the name of our panel. And we don't need that huge. And we can move that panel down here. Just call that P1. Now in this diagram, we want to show how P1 is fed, what serves P1. So we're going to draw another line from the center, and it snaps to edges and centers. Center up here. Now this P1 gets fed by, in this case, a 200 amp 12240 meter base, self-contained meter base that will have the utilities meter plugged into it. So we need to draw a symbol for a meter base. Now, depending on what you typically use, I use something like a circle with an M in it. So let's get the M in there. M. And then I want to put a circle around it. Now, remember, this text is set up, if you look at the type, as opaque. So it'll blot out anything for a certain background. So I need to keep that in mind as I draw my circle around it. So let's go to the circle tool this time and pick somewhere in the middle of this M, and let's draw a circle around it. Now, if I stop there, you can see where the opaqueness of that M interferes with the circle. So I need to make the circle larger. Now, how do I change the diameter of that circle once it's already drawn? Well, I can go here and I can type like 1 inch, and then that's huge. Or I can just redraw that circle to make it how I want. So let's go here. And I know that I need to be a ways out to avoid the opaque. There we go. Now I can circle this whole thing and get it down close. Now there's no snap here. So I just have to get it close. This is just a diagram. There we go. There's our meter. Now the meter is fed by what? Well, typically ahead of the meter is the utility transformer. It could be a pad mounted transformer, or it could be a pole mounted transformer. You know, when you coordinate with the utility as you design this, you'll find out what they're going to serve it with. In my case, I found out they're going to serve this with a small, maybe a 25 or 50 kVA little pad mount transformer out near the street. So I'm going to show it like that. So create similar. Now this does try to line this up here, and we'll go up to a transformer. Now what am I going to use for a symbol of a transformer? Well, a symbol of a transformer a lot of times has coils with a core and more coils. I'm just going to draw something that kind of looks like a pad mount. So I'm just going to draw something that looks like a pad, and it's going to have the transformer sitting on it. So that's kind of a symbol for a pad mount transformer, and that works for my situation. Now what happens ahead of the transformer? Well, this is the primary side of the electrical distribution system, which is not in my scope. It's not in our electrician's scope. It's already done. The transformer's already there. So I'm not going to worry about what's ahead of it. So what I would also do in this one-line diagram is start to add some labels to things. Now, again, we're just using dumb text in this situation because it's just a diagram. So I can say utility, pad mount, transformer, click out here. Now I can change the width of that text with this grip. I can get really thin, do something that makes sense. I can move it around, and then I can also, like I did before, add a leader. Now I'm going to use the straight leader. So there we go, and get a little shoulder on the guy. So that. I want to do a similar tag for this meter, and this will give me some guidelines. You can see the little blue guidelines to help me line it up. So let me line it up down here and say utility meter base. And maybe I want to scrunch that in a little bit and put a leader. Like that. And then this guy is going to be our load center. Again, the name of a residential panel, and it's usually a plug-on circuit breaker load center. You can get as detailed as you want in this description. A lot of times this will be called out in notes or a separate specification sheet that says exactly what manufacturers are allowed, that kind of thing. So here it's just a generic label. And then a lot of times we'll have the sizing of this. What is this conduit and wire, or what is this cable? So you can put things like that. So for a 200 amp service, maybe code would say I need something like a 3/0 copper cable. And you can get detailed and say that it's 3/3/0 if you want the neutral to be the same, or if it's a reduced neutral. If you have a ground, you can put all that in here. For this one, I'll just put that and put the arrow. Now you have some choices on these arrows like we saw before. We can go up here, hit edit type, and we can change it. Now I don't want to change from this arrow for my standard arrow, but I would like to duplicate this text and make maybe a loop. So let's duplicate this 3/36 arrow, and we'll just call it loop, a different one that has different type parameters. Remember, this is types. And let's go with we have dots filled, dot opened, triangle filled, heavy end. So a bunch of different kinds of things. Let's go with a dot open. See what that looks like. There. That's kind of a loop. And I'll use that for a cable. And now from my pad mount transformer to my meter, maybe I want that in a conduit. So maybe here I'd say something like a 2-inch conduit with 3/0 copper. And then you may want to indicate on this diagram any grounding. Now we're going to establish our ground here because this is our service disconnect is inside this load center. Now sometimes you'll see a meter with a service disconnect outside, which is where you would establish your grounding and your bonding, attaching neutral and ground together at that first overcurrent. And then your panel inside becomes a sub panel, if you will, where neutral and ground are not tied together. So that's some of the details of what happens in the wiring for this. But in this case, we are going to have a main circuit breaker in here. So I might even indicate that on this diagram. Even though my panel schedule shows a main circuit breaker, it's helpful to have it in this diagram as well. The size of it can be on the panel schedule. So depending on how detailed you want to get with that ground, you could indicate they have a number 6 going to a ground rod or 2 ground rods and number 6 going to your water pipe, things like that. In this case, I'm not going to get that specific, but so this is just a simple one-line diagram. Now that we mentioned this meter and transformer, it'd be nice to show some of that on our plan view. So let's create a site plan that would have all of the site work on it rather than our building plan. So let's go back and take a look at our floor plan. So I need to create a site plan that is not cropped like this. So could I just copy this power plan? Well, I could, but if you recall, we have a grade level. And I want my site plan to be at that grade level. Now, even though the site may undulate and stuff, I think the actual base level of a site really should be at that grade. So we're going to create a new plan view based upon the grade level. So let's go to View, Plan View, and hit Floor Plan. Now this is showing me, because it says do not duplicate existing views, it's only showing me the views that I have not yet created a floor plan for. If I wanted to use level 1, again, I can uncheck this and use level 1, but I just want to use the grade level. So let's say grade level, yes, create one for that. And now it created a whole new plan called grade. And by default, this template is set up to apply a view template to it called electrical plan. Well, I don't need that view template because I'm just going to create a site plan. I don't have a view template for a site plan, so I'm just going to modify this on my own. There's only one site plan, so I don't even need a template. So we're back to the no template land. One thing I want to make note of, though, for the site plan is this north thing. I talked about early on that we have two different norths. We have a project north, which aligns the building in vertical horizontal for ease of drafting. But for a site plan, I actually want a true north. So I'm going to change this to true north. And that automatically tilts the building to make true north. Now this big green box is probably a scope box in the architectural plan for the site. And I could do that. I could create a scope box. Again, I only have one site plan, so I don't need to get as picky about scope boxes as I do on the building plan. So I'm just going to crop this manually. The way I do that, turn on the crop view and turn on the crop region. Now I can crop this down. So let's go ahead and crop this down to roughly that scope box. I can't use the scope box that's in the architectural. I would have to create my own if I wanted one. But I can use it to help me pull in the crop. Something like that. Now, what scale do I want my site plan? Well, I would typically base it upon the same scale that either my architect did, or even if you have a civil engineer doing site work on this job, kind of mimic what they've done. And they are typically not in 1/8 inch or 1/4 inch. They're more of a 1/10 of an inch, 20th of an inch kind of scale. So I'm going to set this one up for a 1/10 of an inch scale, which is similar to 1/8 inch. And then I also want to make sure I name this floor plan, hit F2 as a site plan. So I'm going to call this 10 so it appears above my floor plan. And I'm just going to call it site plan. And I'm going to call this electrical, not just power, because I use a site plan to show both power and lighting on the site. So I'm just calling that electrical to be generic. Now, a few more things on this site plan. I typically don't need to show any grids because I'm not going to refer to anything inside the building. So let me turn grids off. And I can just do that for both my model and the linked model by just turning them off here. If I just go to annotation and turn off the grids, it turns them off in both because my Revit link is still by host view. So if I don't change that to custom, then I can control it with my model, which is the host. You also may think, well, I don't really want to see all of these receptacles inside the building. How can I turn those off? Well, I could turn off the electrical fixtures, and in this case, that may work. But let's say I had a receptacle that I wanted to put out here, on my driveway somewhere. I'd want to see that receptacle out here, but I don't want to see the ones inside. So we're going to get tricky and use what are called filters. And we'll deal with that later. I'll show you how that works. But for now, we're just going to let these show for now, and we'll deal with that filter later. What I want to show on here, and I want to make sure I have lighting turned on as well, because I'm going to install a pole light out here on my site. But let's get the service going. So I have this panel here. I'm going to put the meter just outside of it. And then I have a transformer that's actually, I found out, that's out here at the street. So what can I do? I want to show that transformer. So let's go down to our families and see what we have. Let's go down to electrical equipment. We have dry type transformers. Well, that's not what they use on the utility. They use a wet or a liquid filled. So here's a wet transformer. And there's different sizes. Now, these are pretty much commercial sizes out of the box, but we can still use them. Let's drag in the smallest transformer we have, a 75. Ours is going to be typically like a 25 or a 50, and it's going to be single phase. But let's get that in here and see what it looks like. It looks like a box. So we're going to put this transformer out here near the street. And we're going to say we found out from the utility that's right there. And it's at 0, it's at grade. Now, if we go to our 3D view of the site, we have the section box view, which doesn't show the whole site. Let's go ahead and just do another generic there, 3D site. And we're going to save that one as 3D site. We can change it if we want to a different look, colors and such. But here's our transformer. And we need to add a meter over here. So let's go to our site plan, and I'm going to get rid of those extras. And we're going to add a meter. Now, we don't have an out-of-the-box meter family. So what I've included in this project template for you is miscellaneous electrical equipment. I also have a miscellaneous electrical fixture. Remember, those are two different categories, so they will be controlled differently and displayed differently. So we want to use the electrical equipment. So I'm going to take this guy, and it's just a box with an electrical connector. Pull it out here. You will see it's just a box. It's a three-dimensional box if you look at the 3D view. See that box? I can shrink that and grow it and turn it and do whatever I want to make it be, let's say, a meter base. Again, it's just a close approximation of something. At least it's something 3D in the model. As you get into custom families, you can make that look exactly like a meter base and put a meter on it and all that. But for now, we're going to use this. And what you can do is if you hit spacebar, it spins around its insertion point, which is right there. So you can take this and put another one in. And then if I get close, as I hit spacebar, it spins parallel and perpendicular to that line. So do that and get this right here on that wall. Get rid of that one. And then I'm going to shrink this down to be dimensions I want. Now, because you see these little grips, these are instance parameters for the size right here. They're not a type parameter. They are an instance parameter. So I can stretch this however I want. And then I can also use these to dial it in. So as a foot wide, I don't need it that tall. Let's go with a foot tall and the depth be 6 inches. So there. And then the height is set up at 0. Let's put that up around 4 feet. See how that looks? There. So that can represent our meter base just fine. And its surface on the outside of the house. Now, why can't I see it in my site plan? You guessed it. It's a view range issue. Let's go to our view range. What do we have? The bottom's at grade. Top is only level 1. So the default for this view is only the level above, which is only level 1. Well, we need to go higher than that. So let's go unlimited on our site plan. Another thing I like on our site plan is I don't need to see the walls. I just want to see the roof. It's as if I'm in an airplane view or satellite view. So let's make the cut plane up above the building, like at 50 feet. So now we see the roof line. That's what we want to see. And then we can point to this and we can call this, because it's a piece of electrical equipment, it has a panel name associated with it. So we can call this meter base. And I could go in and change it to the proper voltage, 240 volt, 2-pole. There's no need for me in this situation to actually connect my panel to it logically. It's going to have the same load on it as my panel. I'm not even using panel loads anyway, so I don't need to. But you could interconnect behind the scenes this panel to the meter and then the meter to the transformer and get that all connected if you want to have that reported right and the loads right. But in this case, I don't need to do that. But I do want the name. So I'm going to put a tag on that, and I want a leader, meter base, and get that. If this is not hitting right on the meter base, you can disconnect the end. Now this isn't text. Remember, this is a tag, so it behaves differently than text. By default, it has an attached end. So I can unattach, make a free end. Now I have a grip, and I can do that. I can also change my tag, like text, to have an arrowhead. So let's go arrow fill 15 degree, so it will mimic what I'm doing on my text. And on my site plan, I'd also like to call out the panel, so that when you're looking at the site, you can see the electrical distribution equipment. So let's go P1, get that up here. I'm going to put it in alignment with the meter base, and I'm going to get this shoulder in alignment there. So it shows the panel P1, it shows the meter base, and then I'm going to want to tag this. This has a panel name as well because it's a piece of electrical equipment. We're going to say utility transformer, just as a way as identifying it and tag by category on the plan. Okay, so the last thing I'd like to do on this service is show my line coming from meter base out to this transformer. Now there's a couple ways we can do this. We can simply draw some drafting lines and indicate that typically PVC conduit feed, or we can actually model in some 3D conduit. Now residentially, you don't have a lot of opportunity for showing those conduits, but on a site it makes sense. And it may be handy for coordination with other utilities on this property. The civil engineer could bring your model into theirs and do some coordination with the water lines and the waste lines, etc. Gas line. We don't have gas here, but if they had gas lines. So the way we can accomplish that is to first make sure we have conduit turned on in this plan and make sure it is set up the way we want it to look. We have no view template. Let's go to our visibility. And let's make sure we have conduits and conduit fittings enabled. We do. Now, the one thing I like to do with conduits, kind of like the ductwork, I would like the conduit to be two line, so like three-dimensional conduit, show both lines, not just a center line. That depends on the detail level of that view. I could change the entire detail level of the view to fine. But then I see things I don't want to see. If I, for example, I go fine, now I'm seeing back boxes and things like that. Even though I'm going to turn these off, it's a good practice to just make the main view either fine, either medium or coarse, and then just make the things you want to see detailed be fine. So again, you can change the detail level of individual categories. Right now it says just do it by the view settings, which is the standard out-of-the-box way to do it. But on conduits and fittings, I want them to be fine. So let's go to fine. That way when I draw these, I'm going to see three-dimensional. So what I have is I'm going to be coming down out of my transformer with my conduit, going horizontally, and then coming up vertically into my meter base is how that would typically be done for an underground conduit. If there was a vault out here, I may come out horizontally out of a vault, but I don't have that situation. So we're just going to come out underneath. Now this transformer is arranged so that the front is at the bottom This is where the primary and secondary feeds enter the transformer. Typically, primary comes in on the left entrance, secondaries come out the right side. So I'm going to draw it that way. So let's see. Let's go to our Systems tab, and we're going to go to Actual Conduit. If you click on Conduit or hit CN for the shortcut, now you're into the conduit installation. This lets us pick out which family and type of conduit do we want to use. Now, it jumped into conduit without fittings. Since I'm not doing detailed installation diagrams with fittings and such, I'm going to use this conduit without fittings. It will install elbows, but it won't get fancy with other fittings like connectors and things like that. So we're fine without fittings. And this is using rigid non-metallic conduit, RNC, which would be like a PVC style of Schedule 40. So that's already what I want to use. Now there's other things. You can use EMT, rigid metal conduit like a GRC, Schedule 40 or Schedule 80, rigid non-metallic PVC. And that's with fittings and without. So I'm fine with this one. And then we can specify the justifications, the reference level. I'm going to reference grade, upper end of it, middle and lower end of the conduit itself. So I can pick if I want the top to be 3 feet below grade. And then I can pick the dimension of the conduit in trade size. So first of all, we're going to pick a 2-inch conduit, which is what we showed on our one-line diagram. So we're good there. And I want the top to be down at least 3 feet below. We're going to say we want it 3 feet below. So let's go with 3, enter. That'll put the top of my conduit at 3 feet. Now, we will see if I can even see this conduit that's below the grade. I could start right here. Now, depending on what piece of equipment I'm dealing with, that may be a problem. If I connect on that, I'm good. Now, some pieces of equipment, if you connect right on it, it will try to attach the conduit to a face of that piece of equipment. Let me try it at the panel end and show you an example of what can happen. So if we go to conduit, if I click on this there, what it's doing is it is showing me the face of the bottom, in this case, of the panel, and this is where the conduit's going to hit. I can move where I want that conduit to come up into the bottom of this panel. If I need to get that specific, I can do this, and it will actually attach the conduit to this box. So if I move the box, the conduit goes with it. You may or may not want that. It depends on what level of detail you're going to get to. A lot of contractors that do detailing will want that specific. They will want to show dimensions and all that. For my purposes, as the engineer or designer, I don't need to get that specific, and I don't want that kind of rigid placement. I want to be able to move my conduit around independent of this box. So for my purposes, I'm not going to connect it that way. And in this case, I'm actually just connecting to the meter base, so I don't need to worry about that issue. But if I was going to try to connect to the panel, I would draw my conduit here, and then I would take this and move it under the panel. And that way it doesn't try to connect, and I don't have those constraints. That's just a little note. So let's delete that. We're going to go from the transformer to the meter base. So we have a 2-inch, 3 feet below. I'm going to use this section is my secondary stub out. And I can try to angle it if that works. Maybe I want to give it one little bend, which is fine. And I'll come into my meter, let's say right in the center of it, and it's not going to attach. And sometimes it gets picky about where you can place it. There we go. So that placed a conduit, and it's just a horizontal conduit, and it's got a slight elbow there. Now, it'd be nice if I could gently curve this like PVC. We don't have that option in Revit. I've had a number of people bring that up. They wish they could. I do too. So we just have to approximate the bend. Now let's look at a section of this. So we maybe want to turn this conduit up into our piece of equipment. So let's get a section out here. I like to do a section that is parallel with my conduit. So let's do this. and make sure our depth is far enough. Let's see what we have. Now we need to drop down, and we need to see conduit. Now what's that? Why is a conduit floating up in the air? Well, because I messed up. When I put the elevation, I said 3 feet. Well, that's a positive 3 feet, so it put it above the grade. I need to be a negative 3 feet. So this is good. We're checking. Let's do a -3. There we go. Now, did it change the whole thing? We'll find out. Move this up here. And what I do notice is that now I don't even see that conduit. Why? View range. Check the view range. The bottom is grade, and I can't see below grade. So I want to extend this down below the grade. Now I can just say -10 feet, or I can just say unlimited. There. Now I can see unlimited, and it'll be a little bit different line type because it's in that region called the view depth. So this view depth gets a different look to it. Let's go back to the section. How did we do? So yes, it took the whole thing and put it underground. Now my view depth doesn't encompass this meter, so I want to extend that further. There we go. Now I can see my meter and my panel. Well, here's my meter box. I want to get this conduit. Now, I'm only seeing one line for this conduit, so this view, this section view, has independent controls for the detail level. So I want to make it a detail level called Fine. There we go. And I can even make it colored if I want. And this is just for design purposes, but that might look better. Now, to curve this up, click on the conduit, and then you can see there's the connector. If I right-click right on the connector, now I could just drag this around, but I can't drag it up. It tries to tilt it. So I need to right-click on the connector and say, Draw Conduit. If you don't get the Draw Conduit, that means you didn't click on the connector. See this? There's no Draw Conduit. So you got to connect right on, which is actually the end of it, not the connector. Draw Conduit. Now it will let me continue conduit in any direction I want. I'm going to go up, and I'm going to get close to this box. Sometimes if you connect it to the box, you'll get that connection, and it shows you the face of the device. So I don't want to do. So I'm just going to get close. In fact, I don't want to connect to that panel. Now I'm going to take it and drag it and get close. And because of the thick lines, it's hard to see it. If I want this exactly touch it without being connected, this is where I will use my align. There. And graphically, it looks kind of weird. But that has my conduit up. And let's go look at the other end. I want to get this conduit bent up. So right on the end of it, right click, draw conduit, get it close. And now I can take it and just drag it. I want it stubbed up above the bottom of the transformer. So there's that, and that's, again, getting picky on how that's drawn, but for coordination, that might be handy. And if you look in the 3D view, you can see that we can change the 3D view also to Fine, and then we start seeing our conduit. There, that's a good representation of the site conduit coming in. And then on my site plan, I may just label this the service lateral, and I may just refer it back to the one-line diagram. I don't like to size things in two places. So I'll say UG service lateral C one-line diagram. That's just my preference. And that will refer them back to there. And let's use the aerial loop and install the leader. And there's our loop for that. And things are identified. Now I want to get this light fixture out on my site. What do we have for a light fixture on the site? Let's go down, and we have a lot of these open, so we can start closing some of these. What I brought in is a street light, an antique style. Now this happens to be an out-of-the-box light that is a little shorter, so more of a residential style post, rather than some big 40-foot street light. And again, these are old, so they're set up for halogens or high pressure sodiums. So we're not going to worry about that. Let's just bring in a 120 volt version. And where's this going to go? It's not hosted. It also doesn't have a height. So it's just going to get attached to grade level. So I'm going to put this out here a little ways away so we don't run into it with our vehicle. There. What does that look like? There, that works. May not be as decorative as we want, but again, we're just trying to show a symbol. And it attached it right to the grade level. I can't even I can raise or lower this. I think I'm just moving it around. Yeah, I'm just moving it around. I'm not raising or lowering it. So you're stuck with what you get on the height, but that will work. And we're going to connect it at 120 volt. Let's make sure it's at 120. It is. And we want to give this a name. And for site, I like to give them an S number. So let's call this S1. Back here, and we're going to call this a tag. And we have our circuit tag we used last. We want to use our actual type tag. So let's do the circuit tag and then change it. And I don't need a leader, so click off leader. Do that, and then change this to a standard fixture tag to get the S1. Now, how do I want that controlled? Maybe I want it to come on and off with my lights here. So I can actually wire it up from here, tab over that, click it, edit circuit, and then select my site light, say OK. And then I can put a circuit tag on it. There we go. Now we have our site lighting. Now to deal with this filtering issue. All right, hang in here with me. Filters are a little advanced, but they're very important, I feel, to learn even for a beginner. So once you learn these, you'll be glad you did. So the basic idea is the visibility is controlled by the categories. As we saw, we could turn those on and off. However, we have some things within the category that we want to stay on and some to go off. So how do we subcategorize things? Well, what we do is we set up a filter to look for some kind of identifier in, for example, in this case, for the site pieces that says leave that on, but turn things that don't say site off. How can we flag stuff for site? Well, one easy way to do that is with an instance parameter in each of these things that I do want to show up on the site. Now, I don't want to do it the opposite where I flag everything inside the building. There's too many things inside. But on the site, you typically only have a few things. So it's easier to flag those. Now, first of all, equipment. I always want equipment showing on the site and the floor plan. So I don't need to flag those. I'll just leave those on. But I don't want all the light fixtures showing up, and I don't want all of the devices showing up. So I need to flag this light fixture with something that says this is a site. Over here, in the instance parameter of this light fixture are things called image, comments, mark. These are instance parameters that we can use. I use the comments. So on the comments, it's just text. I can just say the word site. It's just a comment. And it's an instance. So it's only on this one light. What I can do is set up a filter that looks at that comment and says, if it says site, leave it on. Leave it visible. If it doesn't say site, turn it off. That's what we're going to do. So let's go over to, we don't have a view template, so we're just going to get into the regular visibility. One of the categories in here is called filters. So click on filters. There are no filters now. So the way these work is we set up a filter to filter out certain pieces. We can add a filter to this view. And here's some filters that are already made. This comes out of the box, and we're not going to use any of these. We're going to create our own filter, and we're going to call it not site. We want this filter to turn things off. We can't turn things on with the filter. It's already on. We have to turn them off. So I'm going to create edit new, a new filter, and here's the name. I'm going to call it a new filter. I'm going to call it not site. Now I'm going to define a rule. Which categories do I want to control with this filter? Well, I want to control anything that might be on the site electrically, which could be light fixtures, lighting devices. It could be electrical fixtures. Now, I don't worry about equipment because I want the equipment to show. So those three things I'm going to control. And then over here, here's the rules. You can have AND rules or OR rules. You'll use some Boolean logic here. We're only going to have one rule, so we don't need AND or OR. So all selected, that means all of the categories that I've selected. And what am I going to check? Which parameter of these lighting devices and fixtures will I check? I'm going to be looking at that comments right there. So all selected, comments, I'm checking the comments. And what happens with the comments? Here's my conditional statement. Equals, does not equal, greater than. It's like I say, it's like a Boolean logic. I'm going to say if it does not contain the word site in comments, it's going to get filtered out. Say, okay. Where is it? Well, I need to add that filter to this view now. So add my not site, okay, to this view. You can enable or disable the filter easily here if you want to test it. What's the visibility? If it's not site, right now it's going to be visible. Well, I want the not site to be off, not visible. I'm overriding the natural view that lets those categories show up. Everything disappeared. Well, except this one thing. What's that? Well, that happens to be our water heater. I can turn that off with my category by turning off plumbing equipment there. That's easy to turn off without a filter. So now my equipment shows up, my conduit shows up, and now this light shows up. Nothing else shows up because I filtered it off. They don't say the word site. If I had interior conduits that I didn't want to show up, well, then I would need to add conduit category to my filter and make sure that this conduit had the word site in its comments. See how that works? So in this case, anything that's lighting or electrical devices or switches needs to have the word site in it to show up on my site. But that's an easy way. Once you understand how that works, it's an easy way to subdivide your categories to turn them on and off in views. And you can use this in other views. I use this for enlarged views. If I'm going to enlarge the kitchen, for example, and I don't want the devices to show up in my overall plan, only in the enlarged, I can use filters to turn that stuff on and off and subdivide my categories. So we're almost done with this project. It's time to put some of this stuff on sheets so that we can print it to PDF. So we already have some sheets set up. Let's take a look at what we have. We have a starting view, which is not for printing, but we have an electrical cover sheet. Let's double click that. So it's just a blank sheet, but it has in here the name of the owner, ER Properties, a 3-bedroom home, electrical cover sheet, project number. This is the stuff that we brought in from the architectural project info when we brought that in. So it shows up here automatically. Now the date we can change here, and we can change the author and the checker here. Those are just labels that we can change. But what we would do is we would just drag our views onto this sheet. Now, what do we can put on a cover sheet? Well, typically on a cover sheet, I would put something like the electrical symbol list. Well, we don't have that yet. How do we get a symbol list? Well, we have to create one. And when you do create one, you may save it as a generic symbol list and put it in your project template to use it on future projects. But since this is our first project, we have to create one. Well, we could just start drafting on this sheet, but best practice for me is to actually create a detail view or a legend view that has that information that I can drag into the sheet. So how would we do that? Well, we can create that drafting view like we did for the one-line diagram, but we can also create what's called a legend, which is a different kind of drafting view that can be placed on multiple sheets. A trick about drafting views, you can only drag it onto one sheet. Same with plan views, I can only put it on one sheet. So if you want something on multiple sheets, some people like a legend on multiple sheets. So we're just going to create a legend. So we can right click and just say new legend, or we can go up to view and go to legends right here and just do a standard legend. And we will call this electrical symbol list, or just symbols. What scale? Yeah, it's usually just 1:1. It's like our one line, it's just a blank sheet. Now, what symbols can I use? Unfortunately, I can't just drag light fixtures on here and junction boxes to use those. See, it's trying to drag on a box. So we just have to actually just draw the symbols. So to get a scale set up, I'm going to use some text first. Let's just say surface light fixture. And then what's the symbol for that? Well, here we are in drafting mode. We're just going to start annotating and drawing drafting mode. Surface light fixture is like a circle. And then we can copy this down. You can get exact on your copy or just kind of use some of these guidelines to help you. And we can say recessed light fixture. And what happens if we drag in a recessed light fixture? Look at that. It's huge. So it's trying to drag in the actual geometry. So we have to actually draw another symbol. Now you can create families that are just symbols that you can use for this. If you're only using them in your symbol list, it's really not worth creating a family just for that. So what we'll do is I'll copy this down and draw. Again, I'm just doing annotate. So you'll go through and just start drafting all of your symbols. Now I'm going to do this and do a 45-degree line and then extend it. And let's make sure that that matches our light fixture. So we want to do this for each of our light fixtures and for each of our receptacles and the junction box. And then you'll want to put in some abbreviations. You may say something like above finished floor is your AFF, and then get that over here. You may want to put GFCI, any of your abbreviations. So you'll want to create a symbol list that has all of your symbols. And you can put a heading on this, call this electrical symbols. And let's make that larger to pop. You can draw a box around it. You can get fancy if you want, do whatever you want to make this look like that. And I'm just doing an abbreviated one for instruction purposes. You can actually copy that one line down, something like that. And I didn't go far enough because of my opaque. There we go. You can make this twice as wide with a double row of symbols, but that's the idea. So I just want to give you an idea for that. So now we go back to our cover sheet. Let's go find that legend. It'll be up here under legends now. Expand that out. And I can take this symbol. Listen, the way I put it on a sheet is I just drag it in. Pull it over. Drag it in. Electrical symbols. Now, it comes in with a title for that view. So you can click on this and move this all around. If you want to just move the title, you can click on it and move it by itself. But if you want to extend it left and right, you have to click on this. So it's a little tricky on how you control this thing. And then if you don't want this title, you can go up here. We have to create a separate type for that. And this is called this a duplicate viewport. Let's say no title. And show title, you can change it to no. And that gets rid of it. So now you have two different viewport types. Now let's say in this project, we're going to put our panel schedule and our one-line diagram also on this cover sheet. We don't need a separate sheet for that. So let's go drag those on as well. Let's drag our one-line diagram on. Where's that? Up here. Just hold it down, drag it, let go, and now I can put it here. It's very small. And this one, I do want a title. Now, I don't need a scale. To get rid of the scale is a little more involved, and we would have to do some family editing of this view title. So I'm going to leave it on for now. And then I want to get the panel schedule on this sheet. So where's the panel schedule? Down here. Let's drag it on. Let go. There it is. And we'll put that right here. And there's our panel schedule. But that's the basics of getting those onto your sheet. You can also change this title block. If you have a custom title block, you click on it, you have a drop down, and you can select different title blocks. They're just another family, like a receptacle. You can bring in title blocks from your architect. You can create your own. That's more advanced, but that is a possibility. Now we want to create some more sheets. So we can right-click this and say duplicate sheet. We don't need the detailing of the sheet. We just want to start with an empty sheet. Or at least we'll have a title block. And we're going to call this E101. and that's going to be our site plan. Electrical. Let's go find our site plan and drag that on. So where is that? It's under Power, Site Plan. Drag it, let go, and it fits on the sheet. If for some reason it's too large or even too small, we may want to change the scale. But in this case, it looks like it will fit nicely. So we'll put it centered. There's our site plan. Now, automatically in the title, it comes up with the same name as the view. So you get that 10 site plan. Maybe I don't want that 10 to show up in the actual sheet. So I can click on this either way, and I can go down now. View name, I have a separate line for title on sheet. So I can type in site plan electrical, or sometimes what I'll do is I'll try to just select the name I want. I can't right click copy, but I can Control C copy, put it down here, Control V paste if you want it that way, or you can just type it in and apply. And see how that changes? It got rid of the 10. And the scale is what we want. And it will automatically number these details as you put them on. Now you can change the detail number up here under graphics. You click on your view. Up under graphics, you can go up to detail number and change it to 2, 3, 4, whatever you want. If you have multiple views on here, you can renumber them. Also on a floor plan or site plan view, I like to have a north arrow. So how are we going to do that? Well, in this sheet view, we can add a north arrow. So down here under annotations, out of the box Revit comes with a north arrow that we can use. So down here under N is north arrow 2. Drag that in, and you can see it's just a simple north arrow symbol. So you can put that down here, and for a site plan, I like to say true north. On my floor plan, I'll just say north or project north. So let's add yet another sheet. Right click, duplicate sheet, empty sheet, and we're going to call this one, let's go with the 200 series, 201, floor plan lighting. I don't even need to say first floor plan, there's only one floor. Floor plan lighting, and we're going to drag in our lighting plan. So drag that in. And there it is. Put it right there. And the same thing. We want to get rid of this 11. We may want to change it instead of first floor just to say floor plan. So click on there and we can just type it in. Floor plan, lighting. And it's kind of repeating what the sheet name is, but sometimes you'll have multiple plans on a sheet and that will make more sense. And then we want that north arrow here. I can go find it again, or I can just actually copy it from the site plan. So let me go down to the site plan, and I'm going to click it and then hold Control and click True North. So I have this selected. Now I can do a Control C copy, or I can go up here and say copy to clipboard, not the regular copy, but the clipboard copy. If I want to copy between sheets, I need to do the clipboard copy. Go to my floor plan lighting. And now I want to paste it here. Now I could Control V paste, or if I'm in the modify menu, I can go to this paste drop down. I can just say paste from clipboard, or I can be more selective and say align to the current view. That will put it in the exact same spot on this sheet right there. That will also help me maybe line up my floor plan. Maybe I want to drop it down a little bit. And then here I can say project north for this lighting plan. And then I want to set up a power plan similarly. Duplicate sheet, empty, rename it F2. I want E301 for a power plan. This is the power. And let's pull the first floor power into here and line it up. Now I already have that north arrow copied. Let's just paste it again into this current view. If I know I want it on a bunch of sheets, I could even say align to selected view and then pick all of these sheets. But I'm going to do it individually. Align to current view. And take this, move it left a little, move it down a little bit to help line it up. So there are all of our sheets set up. Now we just have a few final touches to finish up this project. So stick around here till the end. We're almost there. One thing I'd mentioned earlier is that sometimes you'll want to have some kind of notes on your sheets. And they could be general notes, or they could be what are called keyed notes, where there's a note tag that refers to specific numbers or even symbols. So in this case, I want to add some notes to my power plan that I have on this sheet. Now, again, we could just start typing on this sheet for notes, but a better practice is to actually create a drafting view or a legend view with those notes that we drag on. It also lets you drag those notes onto multiple sheets and only have to change them in one place if that becomes an issue. So again, I will create another legend, but this time it will be for notes. So right-click, New Legend. This one's going to be called Notes Power Plan. So I have an identifier. Here we are in the Notes Power Plan view. I'm going to start just typing some notes, and I'll say something like 1. Now, some people have symbols like a hex or a circle or an oval or something that they can use. Again, out of the box, we don't really have that. So we'll just use the tried and true Note 1 method, which I'll show you. But Note 1 is going to be all receptacles in garage to be at plus 48 inches above finished floor. So maybe there's only one note for an example. And then we'll say here, power plan notes. And these are keyed notes because they're keyed to numbers. So let's change that to 1/4 inch. And maybe we want that underlined. Well, select all of this. And up here, you can apply an italic or bold or underline like that. And we can put a box around them if we want, or just leave it like that. So if I go to my actual floor plan, I can pull that note into here and put these notes maybe over here on the side. Again, I don't need a title for notes. Now, how do I show that Note 1 on my plan? Well, I go into this plan. Now, let me show you, there's a couple ways you can get to this plan. From the sheet, you could double click in here, and now you can see I can highlight this. I'm working on the sheet. You can do it that way. I warn you that this can be confusing, and that sometimes, and you double click outside of it to get back to the sheet. Sometimes you will start adding notes here and you won't be in the plan view. You'll be in the sheet view, and then things aren't on the right place. So what I would do is recommend not doing it that way. Either get to your actual power view, either up here, or you can do it from the sheets. Now, sometimes it's easier when you get, 30, 40 plan views, coordinations, lighting, all that. It gets confusing. You may want to just make sure, I want to get to the actual view that's on the sheet. So from floor plan power, you can see we have the floor plan and the legend listed. You can get to those by double clicking here. So that's how I would recommend getting to these plans. So what I want that Note 1 to be in here. Now, I don't have a symbol for Note 1, so I'm just going to use a method that some people use, and they just say Note 1. They just spell it out. And I'll put that near the name of this room, Note 1. That will refer them back to that sheet. So let me go back to the sheet, floor plan power. It says Note 1, and that refers them up here to the keyed note. So that's a way to add notes. The other thing I would like to do is I talked about a lighting fixture schedule or a lighting fixture list. So let's go to our floor plan lighting sheet. Again, we don't want to just start typing on the sheet. We want to create a legend for that. Now, we could create what's called a schedule, and Revit actually has a schedule ability built right into it. You'll see schedules here, and there's some built-in analytical schedules. We can create a light fixture schedule that pulls the data out of the light fixture families, kind of like we pulled data for circuiting, and for our tags, we pulled out the name. You can do that with a schedule. That's a little more complicated. I'm not going to deal with it in this simple project, but just know that that's a nice advanced feature, especially as you get into commercial work, that you'll want to be able to set up schedules that pull the data out of your families. But for today, we are just going to create another legend for a light fixture schedule. And we have an A, which is a surface drum, and the B, which is this sconce, etc. So let's do a couple of those. We're going to go to Legends, New Legend, and we're going to call this Lighting Fixture. You can even call it Luminaire Schedule List. We'll just call it Lighting Fixture List. Go up here, we're going to say A in that and just have a separate text for my description. And some people just do a paragraph list. Some people want a schedule with columns and rows like an Excel spreadsheet. So whatever you like to do, I'm just going to say this is a simplistic lighting list. I'm going to say surface, drum, opal, lens, 1500 lumen, LED, 120 volt. Simple as that. A very, very basic description. And then I can copy this down. I can make this type B, and this can be wall sconce, circular, opal lens, and this guy's only 1000 lumens, LED, 120 volt. I would like to get the wattage in here. We're going to say this is 10 VA, 120 volt, and this guy up here is going to be a 15 VA, 120 volt. Something like that. So that's the idea of how you can do a fixture list. If you want to do a schedule, you can jump into the annotate and start drawing, boxes that has dividing lines in it and vertical lines, and you can just create something like that and do a schedule that way. So a lot of options here, unless you're using the actual schedule, which again is more advanced. Let's go ahead and get a title on this. This is just a list more than a schedule. And there we go. Again, we go back to our sheet, the lighting, floor plan lighting sheet, and let's find that legend and drag it on there. Lighting fixture list. You'll notice that the little boxes get filled in if that view gets dragged onto a sheet. So that's kind of a nice feature. You can turn that on or off. And then let's put our lighting fixture schedule up here, our lighting fixture list. We don't need a title. And there we go. That's just the start of that. So now that you're familiar with residential electrical Revit work, it's time to jump into some commercial work. So this video on the screen right now will show you a similar project, but in a commercial project, multi-story. So take a look at that video and continue on with your Revit mastery.